Welcome to our course on Hibernate and the Java Persistence API. I'd like to start our course by asking a question. Have you ever felt it should be simpler to interact with the database through your Java application? If you feel this way, Hibernate and JPA are the answer for you. The core focus of these technologies is to simplify how we work with the database in our Java applications. So let's take a deeper look at our course. I'm not a salesperson, but I am a developer, and I'd like to tell you why I feel Hibernate is a worthwhile investment of my time. The greatest benefit of Hibernate is that it provides a proven persistence architecture. So if you are working on a portfolio of applications, that portfolio can share the same uniform approach to persisting data to the database. So if someone were to come on your team, they would understand how Hibernate works. Therefore, they would understand how your application writes data to the database. Having that standard proven approach is very beneficial. Now, as you work with Hibernate, you'll see how the framework simplifies how we interact with the database. Code that takes about 20 lines in one approach will take about 1 line using the Hibernate approach. So we're writing less code, so that means our code is easier to maintain. Hibernate is also capable of abstracting your underlying database. When you're working with Hibernate, you're not really focusing on whether you're using Oracle or MySQL. That is abstracted from you. You'll also find that Hibernate has a very good group of people surrounding it. There's a strong community, so when you experience an issue, there is normally a solution available to you. There are many resources you can leverage to learn Hibernate and to overcome any challenges you face. Now, since Hibernate is so easy to work with and it simplifies data persistence so much, it's going to improve your productivity. It's going to increase how quickly you can write code, and it's going to elevate the quality of the product you develop. Now, another good reason to use Hibernate or to learn Hibernate is because many employers are looking for this skill. If you were to go out on the internet and look at a few job postings for Java developers, I would guess that many of them would include Hibernate as a required qualification. Hibernate will also introduce you to a new way of thinking about writing code. If you're not familiar with using third-party libraries, it's going to make you more comfortable with relying upon somebody else's code to solve a common problem for you. So let's take a look at the structure of our course. We will first begin with a basic overview of Hibernate and object relational mapping. We're going to talk about what Hibernate does and how it does it. Next, we'll move into actually working with the framework, and the first thing we need to know is how to configure the framework. So we're telling the framework how to speak with the database, and we're also going to provide properties that affect the behavior of the framework. Then we will transition into entity mapping. And this basically boils down to taking an object and providing metadata that tells Hibernate how to write that object to the database. Once we have that in place, we work with our APIs and our interfaces to take that object and perform a CRUD operation on it. So we will call a method, pass in that object, and it's going to interact with the database for that object. And then finally, we'll look at how we get the information back from the database that we wrote there. So we're going to learn all sorts of strategies to retrieve information from our data store. Let's talk about who this course is for. It is primarily for intermediate Java developers. You can be on either side of this spectrum. So you can be an advanced beginner, or you can be kind of an advanced intermediate developer. It's going to help you if you fall within that range. You can ask yourself a few questions just to know whether you would qualify for this course. Are you familiar with collections? Have you wrote code that persists information to a database? If you said yes to both those questions, I would say your skill level is right where it needs to be for this course. Now, if you have experience with SQL and JDBC, that's only going to benefit you for this course. If you don't have experience with these two technologies, you might want to investigate another infinite skills course that can get your skill level to where it needs to be for this course. This course is also aimed at people looking to solidify their foundation within Hibernate. So maybe you already know about Hibernate, but you're looking to reinforce those skills. This is a great course that can teach you some additional things about the framework. So if you're looking to add a new framework to your toolbox, I'll see you in the next lesson. The primary function of an ORM is to persist information into a relational database. So in order to work with Hibernate, we will need a database. For this course, we're going to be using MySQL. MySQL is a very popular open source database. In this lesson, we will learn to download, install, and configure MySQL. So to begin, go to the dev.mysql.com website. Once on the website, click the Downloads tab. This will take us to a page that displays all of the editions of MySQL. We will be working with the MySQL Community Edition. Just click the Community GPL Downloads link, and this will take us to a page that lists all of the software that is available under the MySQL Community Edition. Here you see the MySQL Community Server, also the MySQL Workbench. These are the two primary tools that we will be using during this course. If you are using an operating system other than Windows, you will use these two links to download the products. However, if you are using Windows, you can simply click on the MySQL on Windows installer and tools. So I'll just click the download link next to that product, and then I will click the MySQL installer. This will give me the option to download the MySQL installer. So if you just scroll down here on the page, you will see that you can choose a platform, and we're going to leave it at Windows. I always like to select the second option, which is not the web option, so this will download the entire file. So just click that download link. They're going to ask for your information. I never provide it. You can if you would like. So you can always go down to this link that says, "No thanks, just start my download." So just click Save File, and then save the file to your desktop. Now you can see that I have already downloaded the file, so you don't need to wait for my machine to download it. So now let's begin our installation. I'm going to navigate to my desktop and double-click the installer. I'll next hit the Run button, and then I need to grant the installer permission to run. This screen will allow you to choose the setup type. I normally use a custom configuration, so just click Custom and hit Next. And then I only include the server, so I pick the 64-bit architecture, and then the MySQL Workbench. Once again, I want the 64-bit architecture, and then you also want MySQL connector, and we want the Java connector. This will be the driver for MySQL. So just pick those three and then click the Next button. And now it just asks us where to install the software. The default's normally fine, and then the data directory says, where do I put all of the information? So where do I put the tables and all the schemas? Well, I already have a MySQL Server 5.6 directory, so I'm just going to append a B to that directory and hit Next. And then I'm going to hit Execute to install all of this software. Once the installation is complete, hit the Next button, and now we can begin to configure our SQL Server. You can leave everything to the default options on this page except for the Open Firewall port for network access. Simply uncheck that and then click Next. And now we need to supply a password for our root user. I'm simply going to use password just to keep things simple, and then hit the Next button. And you can apply all of the defaults on this page as well. It's simply saying that it's going to create a service known as MySQL 5.6. That will be our MySQL server. The server will start automatically once your machine starts. That's what the Start the MySQL Server at System Startup checkbox does for you. So with those options in place, just hit Next, and then hit Execute to apply those configurations. It looks like everything has finished installing, so just hit the Finish button, and then you can click Next and hit Finish one more time. Now let's open MySQL Workbench, and we'll size the window up here. And the first thing we'll do is click on our local instance, and here just enter password, because that was the password we set. So just click on the Create a New Schema button, name this schema iFinances, and hit Apply. That will create our schema. Simply hit Finish. And now we're going to create a user that has access to that schema. So click on Users and Privileges, and then we need to add an account. We're going to name our new account Infinite, and we're going to give it a password of skills. And then we want to add the privileges for the account. So we're going to add an entry, and we'll hit the selected schema button. And we're going to give this account all of the privileges on the iFinances schema. Now we just give it permission for all of these different items. I won't give it the grant option though. Now hit Apply, and we've created our user with the permissions. So let's try to log in with that user. So we'll add a new connection, and I'm just going to call this iFinances. And then I'm going to change our username to Infinite. And then we can store our password in the vault, skills. We can test our connection. And now we can hit OK. So log in to that user account. And now within your working files directory, you will find a file named Infinite Finances Schema. And you just want to open that file with Notepad and copy everything within that file. This is going to build the schema that we will be using for our course. So paste all of that into an editor window, and then navigate to the top of the file, and then hit the Execute as Script option, and you'll see that our schema is built. If we were to navigate to the Finances schema, we can expand everything and see all of our tables were created. So this is the database that we will be working with. And anytime you need to reapply the schema, you can always come in and run this file against the iFinances schema. All right, so that ends the configuration of our MySQL relational database. In this lesson, we will download and set up the Eclipse IDE. We will use the Eclipse IDE as our Java editor throughout the course. In order to get started, navigate to the eclipse.org website. Once at the website, click the Downloads link. On the Downloads page, you will see several versions of Eclipse. I normally pick the Eclipse IDE for Java EE developers. This is a web-based version of Eclipse, and it comes with some very helpful tools such as Maven. Select the appropriate install for your architecture. I'm going to pick the 64-bit architecture, and this will take us to the download page. You can select a mirror close to your location to download the application quicker. I'm going to download from the Pennsylvania State University. So just click the mirror link, and you will see the Save dialog, and then just click Save File, hit OK, and then save your file wherever you would like. Now you can see that I have already downloaded this file to my desktop, so I'm just going to cancel, and now we will navigate to the desktop, and I'll show you how to install Eclipse. It's very simple. What will be downloaded is a zip folder. Simply extract that zip folder, and once it's extracted, that is our installation. All you need to do is simply navigate to the eclipse.exe folder within our extracted directory, and that will begin to open Eclipse. Eclipse will prompt you to select a workspace. Our workspace will contain all of the projects that we create. You can accept the default workspace, or you can specify another directory. For example, I'm going to place a directory on my desktop. So I'll just click my desktop and then hit Make New Folder, and I'm going to call it My Work. And then I'll select that folder, hit OK. And then I like to check the Use This as the default. That way you don't have to specify this every time you open the application. So once that's selected, Eclipse will begin to load. It appears our Eclipse installation was successful. And we can now begin to use Eclipse to develop Java EE applications. If you are comfortable in another editor, you could work through the course using that editor. This is a very exciting chapter because we're going to begin to look at Hibernate and object relational mapping. In this lesson, we're just going to introduce our chapter. We're going to look at what we'll be covering and what our learning objectives are. This chapter introduces the core concepts of Hibernate and object relational mapping. We introduce these and explain them because we don't assume that you have any background within these concepts. One of the objectives is to understand object relational mapping. This is a concept that is at Hibernate's core, and it basically boils down to taking an instance of an object in Java and persisting its state to a database so that you can access it beyond the lifetime of your application. The lessons in this chapter will reinforce this concept and will show you the value of object relational mapping. Another important objective for this chapter is just to learn how Hibernate works in general. So what are the basics that need to be in place for Hibernate to work? What does Hibernate do and how does it do it? And you'll see a lot of this boils down to three main principles. First, configuring Hibernate to connect to a database, providing Hibernate with metadata mappings so that it can construct SQL, and then using a session to persist objects. Another topic that we cover within this chapter is just the history, the benefits, and the availability of Hibernate. We're going to look at major releases of Hibernate and what that brought to the framework. We're going to look at the benefits of using Hibernate, and then we're just going to look at where you can obtain the code, so where the code is available. We're going to see the framework in action. We're actually going to look at a small example that actually persists an object, just so we can get an overview of how the framework works. These objectives are important because as you work with the framework, you will have to have a solid understanding of what is taught throughout the lessons in this chapter. So what are some important notes you should have before we begin? During this first chapter, pay attention to the big picture. You're going to see some code examples, and just take a look more at what the larger picture is. Don't get caught up in the details. We're just trying to give you a general overview so that when you begin moving into the finer parts of the framework and doing more detailed coding, you understand the larger framework that you're operating within. The second thing, make sure you understand what data persistence is. And data persistence refers to persisting the state of an application so that it can be obtained once the application has stopped. You should do a little bit of research just to make sure you have a solid foundation on this principle. And the same goes for JDBC. If you don't have any idea of what JDBC is, I would recommend you at least read an article to get up to speed. JDBC is really just the basic underlying API used in Java to persist information to a relational database. So if you just have a brief knowledge of those two concepts, you'll have no problem following along with the lessons in this chapter. I can't wait to begin this chapter. I'm really excited, and I hope you are too. This lesson will provide a high-level overview of the Hibernate ORM framework. This overview will help build a foundation that you can leverage when writing code that uses Hibernate. Let's begin by introducing Hibernate. Hibernate is an object relational mapping framework, and one of the neat things about Hibernate is that it implements the Java Persistence API specification. The JPA specification is part of the Java EE platform, and it defines a specification for persisting data. This is only a subset of the framework. There are other pieces of the framework that do not adhere to the specification, but they provide us with additional features in the Hibernate framework. The core of Hibernate is all about making persisting data easier. And the way we do that is by providing metadata. And that metadata is used to perform persistence operations which are automated. We no longer have to deal with JDBC, and we're no longer manually creating SQL statements. Another extremely useful feature of Hibernate is HQL, or Hibernate Query Language. Hibernate Query Language is similar to SQL. However, it allows us to query objects that are created within an object-oriented design. Now let's briefly take a look at how Hibernate works from a technical perspective. The first thing that you need with Hibernate is configuration. So you will create a Hibernate configuration file, and this file is used to specify your connection information to the database, along with a number of other Hibernate properties that instruct Hibernate how to perform. Once we have provided Hibernate with that connection information, there's another piece of configuration that must be provided. We must tell Hibernate how to map our entities to a relational database. So an entity is pretty much a plain old Java object. So we have a class with some fields and then getters and setters for each one of those fields. And normally the fields correspond with columns in our database, and the class itself corresponds with a table in our database. In the past, XML files were used heavily for this type of configuration. However, with JDK 5.0, annotations were now possible to be used for configuring our POJOs. Within this course, we will primarily focus on using annotations to describe the mapping metadata for our entities. And that's because it has become the predominant method for providing that mapping data. Once we have those pieces of configuration in place, so we've told Hibernate how to connect to our database, and we've given it some Hibernate-specific properties, and we've told Hibernate how to take each one of our entities, or POJOs, and how to persist that POJO to the database via our mapping metadata, we are then ready to create a session. And to do that, we use the session factory. The session factory holds all of our configuration and all of our mapping metadata. And with that information, it can produce a session object. And that session object is what we use to invoke persistence methods. And those are the methods that are going to perform all the CRUD operations for each of our entities. So you'll notice at the bottom of the slide, we've really displayed the recipe for a functional Hibernate application. The first thing you need to do is provide that configuration for Hibernate so it can connect to the database. Then you need to provide mapping metadata via annotations on your POJOs. And then once that is in place, you create your session and invoke the persistence methods. It's fairly simple, and as we work through our examples, you'll see each of these pieces in place, and we'll take a more in-depth look at them. Now let's take a look at some of the milestones in Hibernate's history. First, in 2001, Gavin King developed the framework as a replacement for EJB2. EJB2 was viewed as cumbersome, and Hibernate was viewed as a more lightweight alternative. With Hibernate 3.0, the release contained support for annotations, so it moved away from a primarily XML-based configuration to a more easy-to-use annotation-based system where classes actually contained that metadata that described how to configure mapping to a relational database. And then in release 3.5, we see the support for the Java Persistence API. And then the current stable release is 4.3.6. So if you're starting out a project, you definitely want to start with the most current release and work from there. So let's take a look at why we use Hibernate. Well, it takes all the SQL out of our code. It automates the creation of SQL so that data persistence is performed for us without us manually writing all of the code for that operation. That cuts down our development time, and that cuts down our line of code. That increases the maintainability of our application. There are less lines of code to maintain. Another great benefit about Hibernate is it really abstracts our code from the relational database management system. So you really don't know which database vendor you're working with, and that allows you to move between database vendors a little bit easier than if you wrote some SQL maybe that tied you to that database vendor. The final benefit, Hibernate is a well-documented and established framework. You'll find a lot of resources out there, a lot of tutorials out there, and also if you go to something like Stack Overflow and ask a question, you're going to find a large body of individuals that are willing to help you and have a good understanding of the framework. Chances are if you are encountering a problem with the framework, Somebody out there has already solved that problem and they're willing to help you usually. Now that we know all these great benefits, where do we go out and find Hibernate? If I want to put this library into my application, where can I obtain a copy of the code? Well, the preferred way is to get it through the Maven central repository, and that's how we're going to retrieve all the jar files for this course. You will see how Maven can be used to manage our dependencies and the dependencies of our dependencies. It's very handy. If you prefer a more traditional approach where you download the jars off the internet, Hibernate's website hosts the current version as well as archived versions. And then the framework is also built into the JBoss application server. It is actually packaged as part of their application server's persistence engine, and that can be used to perform your data persistence. So with the JBoss application server, you will already have those Hibernate libraries at your fingertips. So from this lesson, you should have obtained some basic information about Hibernate, how it works, its history, where to find the code, and why we're using it. And that's just to help you, so as we move into our actual code examples, you're not going into it blind and you have some background information about the framework. Object relational mapping is a crucial concept to understand when working with Hibernate. So in this lesson, we're going to take a look at what problem an ORM solves, and this will help us understand the need for a framework like Hibernate. So to introduce object relational mapping, let's think a little bit about how we develop applications. When we build an application, there is often code that appears throughout the application in almost every layer, and that code also appears in almost every application we develop. And we call those cross-cutting concerns. So can you think of any cross-cutting concerns within the applications that you have developed? Well, we have security, validation, error handling, logging, and then finally we have data persistence. And I really like this definition. It says persistence refers to the characteristic of state that outlives the process that created it. So what does that mean? Well, basically it means when we work with an application or a website, the information that we enter is stored in secondary storage, so that when we exit the application or the website and return to it, we can retrieve the information that we entered at a prior time. So for most developers, data persistence means working with a relational database. And we know that a relational database consists of a group of tables which are made up of groups of columns. And within those tables, we store records. And the records within tables can be associated together using primary and foreign keys. And with this structure in place, we can execute all sorts of queries. We can have queries with joins, we can have queries that aggregate data, and other queries can just perform simple data retrievals. But all this underlying storage basically supports our applications. So when we build an application, what do we normally do? We create a data model. And that data model is the structure in place in our relational database, and it's how we're going to store our information. So on the left side of our slide, we see an account table, and we see an account ID, which is a primary key, and then we see a bank ID and an account type ID, which are foreign keys. So this would represent the data model for, let's say, a simple banking application. After we have built our data model, we will usually move on and build an object model. An object model normally contains one class for each table within our data model. Within each one of those classes, sometimes referred to as entities, we will normally see a field that corresponds with each column within that table. So for example, we have the account ID field of type long on the account class, and that corresponds with the account ID field of type big int on the account table. However, if we look at our foreign keys, so the bank ID column of type big int on the account table, if we look over for the corresponding field on the account class, bank, we notice that they are represented differently. Within the account table, we use a foreign key to associate the account with a bank. However, within the account class, we actually used object composition to associate the account with the bank object that it is related to. So there are these discrepancies that exist between the object model and the data model. Let's examine a few of these discrepancies. The first one to take a look at is how we uniquely identify a record or an object. Within a database, we use a primary key to uniquely identify a record. However, within the object model, that concept really doesn't exist. So we use the equals method, or we use the equal operator to compare memory addresses. And we've already discussed associations. Within a database, we relate two records using foreign keys. And within the object model, we have object references because we use composition to place one object within another. So then how do we navigate those associations between records and objects? In our data model, we're going to use joins. So we're going to use our keys to join tables together. When we look at the object model, we have that reference. So we just use a getter method to retrieve that reference from our object. And then we have the concept of inheritance, which doesn't exist within the data model. However, in the object model, it can be used to create class hierarchies. So when we build persistence code in Java, we need to take into consideration the discrepancies between the data model and the object model. And what you'll find is as you write this code, these discrepancies will create problems that you need to solve almost every time you write persistence code. We're going to continue this lesson within our next video. Let's pick up in this lesson where we left off in our last video. We were discussing the discrepancies that exist between a data model and an object model. The discrepancies between these models are not the only challenges that we face when we attempt to persist information using Java. We have to work with the JDBC API to persist our information. So JDBC allows us to perform all of the CRUD operations. And here we see a snippet of JDBC code. We are simply inserting a record into the account table with this piece of code. We see a try-catch block where we catch any SQL exceptions, and then we have a finally block where we close our exception. All in all, this looks like it's about a little bit over 20 lines of code just to perform that insert. And what we see highlighted in this snippet is a lot of examples of the challenges that we actually face with JDBC. So let's talk about some of those. The first one is error handling. Whenever there is an exception, such as maybe when we have improper SQL that doesn't follow the right syntax, or maybe we have invalid data credentials, we will have an exception thrown, and we will need to handle that in a try-catch block, and sometimes they end up nested. And really, when we do encounter these errors, there's not much that we can do to correct them. So that's one of the frustrations of JDBC. Another issue is key management. Often we will use surrogate keys as the primary key for a table. And when we do that, we use a sequence or an auto number, and we need to get those keys back into our object model. So we have to do the work to take the key from the data model and place it back into the object model. This is a big one. The implementation of JDBC code often varies based upon the team, the developer, or the organization. So there's a lot of inconsistency when we write JDBC code. Another large one is the potential for errors, and I'm going to hold off on discussing this because we will go into this in more detail in a little bit. And then finally, as I alluded to in our last slide, the code is very verbose. It took over 20 lines of code to just insert one record. And as a developer, I would like to see that be a little bit more concise and a little bit more intuitive. So let's dive in and look at some of the potential errors that can arise when we use JDBC. Here you see one line of code. We are preparing a statement, and that statement is an insert statement that will insert a record into the account table. Do you see any problems with this statement? Well, we are using the form of the insert statement that requires us to specify a value for every column. So if we were to change our data model and add a column within the account table, we would break this statement. And anywhere this would be used in our application would be broken. So this really highlights one of the problems with JDBC. It does not protect us from writing bad SQL. A similar error would occur if you used the select star syntax from a table. And also, another thing that JDBC does not require us to do is to actually use prepared statements. So you could be opening up security issues if you do not properly write JDBC code. Let's take a look now at another problem. We have some code that inserts a record into the database. It looks very similar to that snippet we looked at earlier. So can you see the issue? Well, for anybody that's ever opened too many sessions on a database and was contacted by their DBA, you know exactly what's wrong here. We do not close our connection in a finally block. JDBC allows us to make these errors. And finally, I'd like to go into a little bit more detail about what I mean when I say implementation varies. When we assign work to developers, we can assign it in different ways. Under one method, we can give a developer a screen in an application. And we say, make sure everything on the screen is functional. And their responsibilities cut across multiple concerns. So they write the view, they write the controller, and then they write the model piece, which does the persistence. So if we have 3 developers and we assign them 3 different screens, they are responsible for writing the code that basically cuts across all those layers. So what's going to happen is we're going to have 3 developers working with JDBC code. And they can do that differently. Their knowledge may vary. So as we have multiple people writing JDBC code, that creates the potential for more errors because we have multiple people who have different varying levels of knowledge. And they may not know that they need to close their connections or that they should not use select star. And then as we build our application with JDBC, we find that SQL pretty much finds its way into our application logic. And queries can be repeated throughout an application in violation of the dry principle. And that creates a problem because when we need to change a query, we have to do it in multiple spots, and often that doesn't happen. And then just in general, using JDBC, if we don't take the time to really develop that persistence layer of our application, the code becomes very unorganized and very unstructured, so it makes it hard to work with. You can avoid this by writing your own persistence layer, but few people take the time to actually do that. So there's all these challenges with JDBC. How can we solve these problems? As I alluded to, you can create your own custom persistence layer. What this would include is a team of developers at your organization building a framework to persist data, and hopefully this would be used throughout your organization. What this buys you is some consistency. You can expect the same persistence code to appear in every application. Unfortunately, the key word is what this buys you, because it costs time and money to build one of these frameworks. And unfortunately, when you build them, they are not as thoroughly tested as something like a third-party ORM like Hibernate. You will also need to fix bugs, track bugs, and basically build out some documentation for teams within your organization so that they can work with the new framework that you've created. You may also have to do some training. This will add to that time and cost for the development of this framework. So what other solutions do we have? Well, we can use an object relational mapping framework such as Hibernate. So let's discuss that a little bit more. An ORM basically takes metadata about the objects within our object model, and it uses it to write persistence code for those objects. So we can persist our objects into a relational database using some metadata that we specify. So when we use an ORM, what does that buy us? Well, first, it reduces the amount of code we need to write because we're using a third-party framework. So we don't have that development time, and it reduces our code maintenance cost. ORMs are also designed to solve all of those discrepancy problems that arise between a data model and an object model. So all of those problems are handled for us. An ORM will also remove the SQL from our application, and this will allow our application to adhere better to the dry principle. An ORM such as Hibernate will also allow us to better build an application that has the appropriate layers, such as the data persistence layer. We will also find that ORMs provide us with different key management features, so it solves those problems. ORMs provide a very familiar solution to the problem of data persistence. Once you use an ORM in your organization, every application will be using that same persistence solution, and this makes it easier to move developers from one application to another. and this lowers the learning curve once we make those sorts of transfers. And finally, an ORM that is third-party, such as Hibernate, has an open source code base, so we know the solution is well tested. There's plenty of other people using it, and we get to learn from their mistakes and their bug reports. That will basically buy us maintenance. The main takeaway from this lesson is that an ORM such as Hibernate will address the challenges that we find in programming with JDBC. This will create data persistence code that is much more user-friendly for the developer. And throughout this course, we're going to look at how we put that code in place using our ORM of choice, Hibernate. This lesson is a product demonstration for Hibernate. We're going to show you Hibernate in action and inspect the pieces that make it work, such as the configuration, the mapping metadata, and the session. This will give you a better understanding of how Hibernate can improve your development experience and code. Let's begin by taking a quick look at our project. You'll see that I have created a project named Hibernate Course. And within Hibernate Course, I have followed the Maven standard directory structure, and this is a best practice when creating any Hibernate project. Within our source main Java folder, I have added two classes, account type, which is an entity that we will persist to the database, and application, which is a class that has a main method which will execute all of our logic. Here is our application class, and within it we will see how Hibernate is configured and how a session is used to perform persistence operations. As we stated before, there are three main items that must be in place for Hibernate to work properly. The first is the configuration. Hibernate configuration can be specified in three manners. One is via a properties file, another is through an XML file, and then there is also configuration through Java code or programmatic configuration. The most preferred method is through the XML file. In our example, however, I have done programmatic configuration. We will not see this configuration often throughout our course because it is rarely used by developers, but I wanted to include it so you are at least familiar with how to perform a programmatic configuration. In lines 18 through 31, you'll see a very simple Hibernate configuration. The main point of this configuration is to tell Hibernate how to connect to the database. You will see that most of the properties that we place into our new properties object are associated with that connection to the database. So here we specify a username, a password, the driver class we're using, so that corresponds with the MySQL driver, and then we supply the connection URL. This configuration is then used to create our session. But before we take a look at that code, I want to take a look at line number 20. Here is where we are registering one of our annotated classes. In Hibernate, we must register our mapping metadata with the configuration. Since our metadata is contained on a class and we are performing it via annotations, we have to register the account type with our configuration. So this leads us to our next piece of the Hibernate puzzle, and that is providing mapping metadata. So if we look at the account type class, we will notice that many of the fields and the class itself are annotated with these annotations that provide Hibernate with the information needed to basically construct SQL to persist this object within a database. The annotations on this class, such as the entity, table, and column annotation, can also be used to perform other types of operations such as selects or updates, or deletes. Another best practice when it comes to entities is following Java Bean naming conventions. So when we create this POJO, we will have these private fields, and then we will create the accessors for these fields. And the accessors reflect the field name. Normally we just add get or set in front of the field name, and then we camel case the field name. Now that we've taken a look at our annotated class, let's see the final piece of the puzzle, and that is building a session factory and obtaining a session, and then invoking persistence operations. So here within our application class, we see that piece of the puzzle. So you'll notice in line 34, we build our session factory using our configuration object. And then on line 39, we open a session. Line 40, we begin a transaction. And then we create an instance of our account type entity, and we set some fields on that entity. In line 49, we call session.save and we save our entity. And then in line 50, we commit our transaction. Finally, we close the session. What the result of this will be is that entity will be wrote into our relational database. Let's go ahead and run this example. And you'll notice that if we look at our log output, we see that Hibernate issued an insert statement to our database. So let's just flip over to our relational database. And after we run this query, we see that all of the information associated with our account type object has been persisted to our database. If we return to our code, we see the only code that was really needed to persist once our session had been established is line 49, where we call session.save. You could argue line 50 also, where we commit the transaction. One or two lines just to save that object into the database. I think it's pretty clear you could not do this with JDBC, not without doing a lot of work on your part. And that's really the selling point of Hibernate. It looks like a lot of code within this example application, but you need to remember the configuration is also in there, and we are also obtaining that session factory, and that would be done in a much more modular way if you were building this out in a real application. In order to persist, let's say, an account object, and we wanted to write that to the database, we would really just need to create that metadata information on that class, and it would be ready to go, and that is the value you get with Hibernate. You're writing very little code that deals with data persistence. So this is a very exciting chapter because it's our first real hands-on chapter. And during it, we're going to get started with Hibernate. We're going to start writing some code that uses Hibernate. So let's use this lesson to just take a look at what we're going to try to achieve within our chapter. So our first objective is for you to build your first simple Hibernate application. We will walk through all of the required steps to put a very small application together that persists information to the database. In order to do that, we're going to look at how to set up a project. So we will use Eclipse and we will pull in all of the required libraries using Maven, and eventually we will have a project where we can begin to build a Hibernate application. And then one of the next steps is configuring Hibernate. So we need to tell Hibernate the different settings that we would like in place and how to connect to our MySQL database. And we will use two approaches to specify that configuration, one being XML and another a properties file. After that, we're going to move on to actually providing mapping metadata for an entity. So we will use annotations to specify how Hibernate can persist our entities to the database. So we're going to be looking at things like the ID annotation, the column annotation, the table annotation, and the entity annotation. And finally, we'll look at how we can use a session within client code to perform persistence operations. We'll talk a little bit about transactions and how they play into persisting our entities. All of our objectives will support our main objective of building that first working example. So let's look at some important things that you need to know before we begin this chapter. First, we are building a very basic example. We will use these basic concepts from this chapter throughout the course to explain our more complex concepts that we're going to look at. So make sure you have these basics down. Pay close attention to the annotations we use. They are the basic metadata that we provide to Hibernate so it can write SQL for us that persists information to our database. And we need to know those annotations almost by heart to be able to use Hibernate effectively. So that sums up our chapter, and we'll get started. This lesson will teach us how to create a new project that will use Hibernate. As part of the project level configuration, we will need to import all of our libraries and configure logging in order to use Hibernate. To begin, we will create a new Maven project. If you hold the Control key in Eclipse and press N, you will pull up the new dialog. Within the new dialog, you can filter to a Maven project. Once you have selected a new Maven project, check the Create a Simple Project checkbox, and then hit the Next button. Now we must enter a group ID, so I'm going to use com.infiniteSkills, and for the artifact ID, I'm going to use Hibernate course. And then also for the name, I'm going to use Hibernate course. And here you can just click the Finish button, and Eclipse will begin to build out our new Maven project. There we see the Maven standard directory structure is put in place for us, and also the pom.xml file is included in our project. We will use the pom.xml file to specify our project's dependencies. Those dependencies will be pulled down from the Maven central repository. So let's open our POM file, and we will click on the Dependencies tab, and here we will add each of our libraries to the project. The first library we need to add is Hibernate Core. So here we find the org.hibernate Hibernate Core library, and we see it is the 4.3.6 version, which is the current version. Next, we'll add the Hibernate Annotations project. We will also add SLF4J. We'll add the API. So there is the API library. And we will also add the implementation for SLF4J, and that will be SLF4J-log4j12. So with our libraries in place, we will save the pom.xml file. And as you'll notice, we pulled in SLF4j, which is our logging framework. So we need to configure log4j because that is the implementation of SLF4j that we are using. So that means we need to create a log4j.properties file, and we make sure we put that in the source main resources folder. And once we have our log4j.properties file, we can grab some log4j configuration. Now I have cheated and I have grabbed the configuration beforehand. You can find this file within your working files directory. So I will just copy and paste that configuration into our log4j.properties file. At this point, our logging is configured. Log4j is really outside the scope of this course, so we're not going to go into detail about this configuration. Hopefully you have experience with log4j and understand how to configure it to meet your logging needs. So since we have our libraries imported and our logging configured, the next thing we're going to do is create a package to hold some of the code we're going to create for our entities. So we're just going to highlight the source main Java folder and press Ctrl-N once again, and this time we will filter to package. And I'm going to create a new package, com.infiniteskills.data, and then within that package, I'm going to add another package just named entities. And inside that entities package, I'm going to add a new class. And this class will actually correspond with one of our tables. And the table is finances user. So I'm just going to call it user. Let's take a look at the finances user table within our data model. So I'm going to switch over to MySQL Workbench, and here we're looking at an ER diagram. And we see that the finances user table has a few columns there. There's a user ID, first name, last name, a birth date, and an email, and then some columns that track when this table was updated. So we're just going to build a POJO based upon those columns in that table. So we'll switch back over to Eclipse and begin to build our POJO. So I will just begin to add each of these columns as a field within our class. The first one was the user ID field. Then we had a first name field. We also had a last name field of type string. We had a field which was birth date, an email address field, and then there was a field for the last updated date, as well as a string for the last updated by column. And then we had our created date, and finally our created by column. Okay, and we'll import date. And that is all of our fields that we have associated with the columns in the finances user table. So we just place those on our class. So the next thing we will need to do is create getters and setters, also known as accessors, for each of these fields. To quickly do that, just tap Alt, Shift, and S, and then press R, and it will bring up a list of the fields and we can generate getters and setters. So just hit Alt A to select each one of them, and then press Enter. And you will have accessors built for each one of your fields. And at this point, we have built our POJO for the table. Now, what we would normally do is go to our data model and build one of these POJOs for each of the tables within the data model. The next time you see this project, it will include each one of these objects, and there will be a class created for each table. So that was the basic setup of a Hibernate application. We saw how to import our libraries using Maven and our pom.xml file. We configured logging so that we can get some detailed information about how Hibernate is executing. And then we built one entity within our com.infiniteskills.data.entities package. So this is how you would create a new Hibernate project. In this lesson, we will map our user entity to the underlying domain model using annotations. Annotations provide mapping metadata that is required to transform the types within our object-oriented application to the relational representations that will be stored in the database. To get started, we will open our user class. And within this class is where we will place our mapping metadata. And that's one really nice thing about annotations. It places the metadata used to map this object to the relational database right inside this class. So as we're looking at the class, we see all that information. Now, most of the annotations that we will be placing in the user object will describe the physical mapping. So we will be looking at the schema, table, and columns that this object is associated with. When we do this, it's often best to use JPA2 style annotations. The first annotation we will put in place is the entity annotation. And when I import the annotation, I want to be sure to use the javax.persistence.entity type. And when we pull in any annotation, be sure to use the javax.persistence package. So an entity is a lightweight persistence domain object, which represents a table within a database. The state of an entity is represented through its fields. The fields are also mapped to the underlying database using annotations. The entity annotation signals to Hibernate that the current type may participate in a session and be persisted to the underlying relational database. The next annotation we must put in place is the table annotation. And once again, we'll use the javax.persistence package. And the table annotation has a name element, and within that element, we specify our table name. It's important to note that the table annotation is not required in certain circumstances, and we'll talk about those a little bit later in this lesson. So now we will move on to our field annotations. And one annotation that must always be in place within an entity is the ID annotation. And this annotation will denote the field that corresponds with the primary key in the table that this object is associated with. And this brings us to a related annotation, the generated value annotation. The generated value annotation is used to specify how we obtain the value of the primary key for a particular field. So some databases use auto numbers, some use sequences. There's also the option to have Hibernate provide this value, and we can use the generated value annotation to specify that. And for this case, we're just going to use an identity strategy. We will discuss the other strategies in detail later in this course. And now we'll move on to the column annotation. And this is a pretty simple annotation. It has a name element, and it allows us to specify the corresponding column for this field. This is also an optional annotation because under certain circumstances, Hibernate can intuitively decide what the column that corresponds with the field is. And the way it does that is by using a naming strategy. So by default, Hibernate will look at a field, so in our case, user ID, and it will just take that field name and try to use it as the column name. Now, in our case, that's going to create a problem because we have an underscore within our column name, and Hibernate's default strategy would not add that underscore between user and ID. It would simply try to use the column name user ID, and that would give us a SQL syntax error. To work around that, we can use the column annotation. There are other workarounds that can be used, such as providing your own naming strategy, and we can look at that later within the course. It's also important to mention that Hibernate would attempt to use the same naming strategy for our table. So if we did not provide the table annotation, which is optional, Hibernate would look at the name of our class. So it would try to use user as the table name that corresponds with this entity, and that would also be a syntax error because our table name is finances_user, so that would not be a match. And the rest of these fields are pretty easy to annotate. We just use the column annotation, and we pay close attention to the table names that we type in. And these are so much more simpler than something like our ID field, because these columns are using simple types, so we just see the wrapper types, as well as you can use primitive types, and there's a number of other objects that Hibernate will easily map to without us providing any other configuration. And all of these just happen to be of those types, so there's not much extra work that we need to do at this point. So that would complete the mapping of our entity. And one thing I just want to point out is that even if we did not have the situation where we must supply the column annotation or the table annotation, let's say our class name or our field name would meet Hibernate's default strategy, I still recommend providing the table and column annotations for every class or field because I think this provides a form of self-documenting code, and it's a little bit more intuitive when you look at the entity just to see where everything maps to within that relational database. So that's just one of my best practices. And now our user entity is all wired up with metadata, and Hibernate would be able to scan this metadata using reflection, and with that it's going to be able to build a SQL statement. In this lesson, we will create a Hibernate util helper class that will provide access to a single implementation of a session factory to our application. When our application needs to perform a persistence operation, it will obtain a singleton session factory from the Hibernate util class we're going to build. Using that singleton session factory, it can obtain a session, and a session is basically the interface between our application and Hibernate. It is what we use to perform the different persistence operations. So let's begin building our Hibernate util class. I'm going to create a new class, and I'm going to place this class within the data package. I will name this class Hibernate util. And I'll just click finish, and our new class will be built. So let's think a little bit about this class. We need to basically provide a single instance of a session factory, so we need to apply the singleton pattern. The first thing we'll do is create a session factory field, and that field will be instantiated by a static method named buildSessionFactory. So we're just going to create that method, and now we'll provide the implementation of that method. Since there are a number of exceptions that can be thrown by creating a session factory, I'm going to start out by making a try block, and we will catch any exception. Will be really vague here. And if we have an exception, we'll just print the stack trace. The next thing we're going to do is create a configuration object. And we can simply do that using the constructor for the configuration object. Here you see I'm using the noArgument constructor. The configuration object will hold all of our Hibernate-specific properties, so it's going to know how we want Hibernate to perform. Another purpose of the configuration is to hold all of our mapping information. So we're going to add an annotated class to our configuration that corresponds with the user class that we have provided the mapping metadata for. So I will import the user class, and it will now be registered with our configuration. Now we will begin to build our session factory using the configuration object. So on the configuration object, we will call the build session factory method that accepts a service registry object as an argument. Do not call the build session factory method that doesn't accept any arguments because that is deprecated. Now we need to pass in an implementation of the service registry. So we will use a standard service registry builder. And since this is a builder, we will need to call the build method. And this statement will return a session factory. So I'm just going to return that from our method. So I'm going to format our code. And now we see we have this return null, and we want to remove that. And we can just have our method throw a new runtime exception, and that will alert us to any issues. And now to finish our Hibernate util class, we just need to provide access to the singleton session factory. So we actually create a public method, getSessionFactory, and we just return the session factory. And that will provide our application with access to our singleton. The way the singleton pattern works, this field and this method are both private, so we cannot access them. However, our public method within that singleton can access the private fields of this class, so it can return our singleton implementation of the session factory. So I will save our Hibernate util, and we will actually close that class. And now we're going to build our hibernate.properties file. This will provide all of the properties which specify our configuration for Hibernate. So it's going to help us set up our connection to the database. We're going to specify our JDBC driver, which actually that's a good point. Let's go ahead and include the JDBC driver in our Maven dependencies. So we are using MySQL, so it's MySQL connector, and then you want MySQL connector Java, and we'll add that dependency to our project. And now we'll begin to build our hibernate.properties file. So just create a new file and name it hibernate.properties. And Hibernate is configured to look for this properties file on the root of your class path. So if it's there, there's really no other configuration you need to specify. You don't need to tell Hibernate where to look for this file. And now we can begin to specify our connection details. So we want to use the hibernate.connection.username property, and this is the username for the database, so that's infinite, and then hibernate.connection.password, and that's skills. Then we need to specify the connection URL, and that's always the protocol, so JDBC, MySQL, then the server, the port, which is 3306 by default for MySQL, and then your schema. So we want to access the iFinances schema. And then we also need to specify the driver class, and this one's a little bit trickier. You notice we have the underscore between driver and class, and that will be com.mysql.jdbc.driver. And then we also want to specify the Hibernate dialect. And for MySQL, it is org.hibernate.dialect.mysql5 dialect. Those are the bare bones properties we need to supply to configure Hibernate. Let's create a quick application to test out our configuration and our Hibernate util class. So I'm just going to come into our data package and create a new class. And I'm going to call it application. And within this class, I'm going to add a main method. And then I'm going to create a session using our Hibernate util. So we'll grab the session factory, and then we'll open a session. I'm going to import the session class. And now I'm going to begin a transaction. And now I'm going to close that session. Let's see if all of our configuration works properly. Okay, if we look at our console output, we can see that we connected to the relational database and then we disconnected. There we see that all of our attributes are getting mapped, so it looks like it read our user class. That's excellent. It looks like we have successfully tested our configuration. That is basically, as I said before, the interface between our application and Hibernate. You'll see here we begin a transaction. Well, we would also have to commit that transaction, but when we work with a session, we normally perform all of our persistence operations within that transaction. And the persistence operations are being, save, persist. Also, we can select information from our relational database. In this lesson, we will learn how to use XML to configure Hibernate. When using XML to configure Hibernate, we create a hibernate.cfg.xml file. This file allows us to use XML configuration to describe the Hibernate settings that we would like to run within our application. The hibernate.cfg.xml file is the most commonly used approach to configuring Hibernate. So to begin, we will create a new XML file within our source main resources directory. And as I mentioned, we will name this file hibernate.cfg.xml. And we'll just click the Finish button. What we get is a blank XML file. Now, I'm not intimately familiar with Hibernate's DTD, so I'm going to go out to their website to pull in just a base template for the hibernate.cfg.xml file. This is very helpful because you don't have to memorize a lot of really useless details. So if you just go to the documentation page for the Hibernate ORM framework, you can go to the HTML view, and in here just type in hibernate.cfg.xml. If you search for that string, it will take you to this section of the page. What we get is a sample configuration file. So just copy the configuration from this website, return to the IDE, and paste that within the IDE. So I'm just going to save that file for now. And then what we'll want to do is return to the top of the file. And the first thing we see is the DTD. And that describes what is permissible within this XML configuration file. And we see our parent tag, which is Hibernate configuration, and then nested within that tag is a session factory tag. And within this session factory tag is where we will place all of our Hibernate properties. Here you see some properties that look familiar and maybe some that don't. So we're just going to focus on pretty much the connection properties as well as the dialect property. So I'm going to remove this connection pull setting, and I'll also take out these two settings. We'll leave the show SQL property. That just says show the SQL that Hibernate's going to generate. We'll take out the auto DDL property, and we'll just work with this set for now. So once again, we need to specify our driver class, and that is com.mysql.jdbc.driver. And now we need to give that connection URL. So once again, the protocol, followed by the server name, which is localhost in our case, the port number 3306, and then our schema name, which is iFinances, our username, which is infinite, and our password, which is skills. We want to use the MySQL 5 dialect. And this property just gives Hibernate a clue about which database we are using, so it knows how to generate SQL. And as I mentioned, the show SQL property will just log the SQL output to the console. So once Hibernate executes a persistence operation, let's say it's a select statement, it will spit that out to the console, and that property just says that's what we want to display. And now we'll notice this final tag, and it's a mapping tag. And that's actually pointing to an XML mapping file. Since we are using annotated classes, since we're annotating our entities, we will use the class attribute to specify the user class. And that fully qualified name is com.infiniteskills.data.entities.user. So there is our hibernate.cfg.xml file. And that's just an alternative way to configure Hibernate using XML. It is, as I mentioned, the most common way. And the nice thing about this approach is it allows us to specify our mapping classes along with our connection information and other Hibernate settings. If you remember when we used the hibernate.properties file, we could not specify the mapping classes. We actually had to do that within code. So this is a nice feature of the XML configuration. Hibernate has many properties that you can set. We will not cover all of them, but if there is a certain setting that you are looking for, you can always come to the documentation and it will display all of Hibernate's properties. Here we see all the data source properties. So you see we've used some of those. And if we look further down, here's other optional configuration properties. There's the show SQL property we looked at. There's also a format SQL, so you can specify if you'd like it to be pretty print, which will just make it in a more readable fashion. You can specify default schemas. There's all sorts of properties. So if there's something you need Hibernate to do, this is an area where you can come look and see if there's an appropriate property that you can turn on or off. Okay, so let's return back to the IDE. And now we need to modify our Hibernate util class. And that needs to get changed because we are using XML configuration. So there are two major changes that need to take place within this class. We need to remove the addition of the annotated class to our configuration. Here you see we invoke the add annotated class method. Well, we've already specified the annotated class in the XML configuration, so this line is no longer necessary. The second change we need to make is we need to pass in the configuration to the standard service registry builder. In order to do that, we call the apply settings method, and then we just grab our configuration and we call the get properties method, and I'll format that. That will pass in our configuration to the standard service registry builder, and then that builder pattern will invoke the build method and pass the service registry into the build session factory method, and eventually we'll end up with a session factory. One thing I should warn you about with this configuration for building our session factory, if you were to go to Hibernate's documentation, it would actually provide you with an incorrect snippet of code. It's actually going to misdirect you on how to build your session factory. You would receive an error if you did not follow this approach using the XML configuration. So we're going to save that, and now we're going to move over to our application class, and we're just going to test this out and make sure everything is working properly. Okay, it looked like that was good. I didn't see any red in our console output. It looked like everything connected properly. So our hibernate.cfg.xml file is working properly, and we have now learned how to configure Hibernate using XML. In today's lesson, we will learn to work with Hibernate in our client code. Once Hibernate has been configured and our entities have been mapped, all we need to do is retrieve a session from our session factory and then call persistence operations on that session. So to get started, I will declare a variable of type session, and I will name it session. And then I will use our Hibernate util class to get the session factory, and I will call the open session method on the session factory. We'll import our session type, and that is how we obtain a session. So the next thing we'll want to do is open a transaction on the session. So we will invoke the get transaction method, and then we will call begin on the transaction. And that will open a transaction so we can perform a unit of work. And every time we open a transaction, we need to close it. And to do that, we just call session.close, and that will close both the session and the transaction. And now we must create our entity, and that will be the object that we are persisting to the database. So we will work with the user object, So I'm just going to use the new operator and the constructor to create a new instance of user. And now we got to set some fields. So we'll set the birth date, when it was created. We'll import date, who it was created by, the email address, the first name, as well as the last name, who last updated it, and when it was last updated. Okay, so we have all the fields set on our user object, and here we see I put the wrong type in for the set created by call, and actually I duplicated that. So we should have all of our fields set now on the user object. To insert this object, we call session.save, and we pass in the user object, and we will persist that entity. And we need to do one final thing to make sure this writes to the database. So let me just scroll down here. We need to get the transaction one more time and call the commit method on the transaction. So here we see what it would take to invoke the save operation within our client code. Now normally this will actually be wrapped up in a nice persistence layer, so you wouldn't use this often within your actual client code. This would be more encapsulated in something like a DAO pattern. So before we run this example, there's one thing we need to add. I notice we did not set the created date field, so we'll just put that in there. Okay, and now we're ready to run our example. So we'll save our application. And if we look at our console output, here we see that our insert was performed, and we see Hibernate logs the insert statement here. We see that the transaction gets committed, and then we release our JDBC connection. So if we go and check out our database, we should see our record in place. Excellent. Now let's return to Eclipse, and we'll close our console. And now I'm going to head back into the application class. And now I'd just like to run through one more demo. I just want to show you how important it is to have that commit in place. If we were to remove our commit, we can save our application and run it, and we'll see almost the same output. Here we see our inserts in place, but you'll notice we don't have that commit. So what has happened is we've never actually wrote that line to the database. You'll see we still have one record in there. So that's just a common bug to look out for. So that completes our lesson on how to work with Hibernate's session to perform persistence operations within client code. In this upcoming chapter, we're going to dive into looking at basic mapping annotations. So we have seen a few annotations during our demonstrations, but now we're going to take a closer look at the annotations we will use to provide mapping metadata for our entities. So let's see what our chapter objectives are. The first one is pretty obvious. We want to learn how to use the most common mapping annotations. Hibernate and JPA have a wide array of annotations. Some of these annotations you will use more frequently than others, and in this chapter we're going to look at those that are going to be showing up most within your work, and we're going to teach you how to use those annotations. We will not cover every annotation within JPA and Hibernate. It simply wouldn't be worth your time because some of them we use so infrequently and they are so well documented that it just doesn't justify covering them with their own separate lesson. In this chapter, we're also going to introduce some important terminology, and one is this idea of types in Hibernate, and in this chapter we will particularly look at value types. So when we talk about types in Hibernate, we are looking at pretty much the fields that are contained within our persistence classes. So we have this class, and it has a number of fields, and each of those fields has a type. Depending upon that type, it's going to really determine how we provide mapping metadata for that type. For instance, if we have a string type, and we also have an address type, those are going to be mapped a little bit differently. Now imagine if we had a user class and the user class had a referrals collection, and it pointed to a collection of other users that this user has referred. That's also going to be mapped differently than something like a basic string. So we have different terms to describe the type of that field. And depending upon that type of field, we are going to use different annotations to map that field. It's important that we have a foundation of terminology that we can use to discuss these fields and to understand exactly what they mean when we're mapping them. And our final goal is to understand the difference between JPA and Hibernate and how to look at different JPA annotations and different Hibernate annotations. There is a lot of confusion between JPA and Hibernate. A lot of people think that JPA is an ORM for Java that's kind of built into the framework when it's not really. We're going to talk about this right now a little bit, but people really mix up JPA and Hibernate, and we're going to really clarify that picture for you. The first way I like to kind of introduce this concept is to talk about the idea of an interface and an implementation. Because when it boils down to it, that's kind of how things work between JPA and Hibernate. When we have an interface in Java, what does that mean? Well, it means that we have this type that really doesn't exist as an implementation, but this type will follow a certain standard. We're setting some roles. So we see our dog interface, and we know that anything that implements the dog interface is going to have a bark method. And then we look over at our implementation of that interface, and it's the class Boxer that is implementing the dog interface. And we see that Boxer has implemented the bark method defined on the dog interface. And that means that the Boxer class honors the contract that is specified in the dog interface. So we can use these types interchangeably. Now, how does this apply to JPA and Hibernate? It's this concept just on a larger level. JPA is a specification. So while it's not just this simple interface where we have to define one method, it's a little bit larger than that. We need to define a whole set of annotations, and we need to provide implementations for all these different interfaces that a JPA compliant implementation works with. So JPA just says, this is what needs to be in place. This is the contract. And then Hibernate comes along and provides the implementation of JPA. So it will provide implementations of all the interfaces that are required to comply with JPA. So we would say that Hibernate is compliant with the JPA specification. Now, there's a little bit more than that because Hibernate actually goes beyond the JPA specification to provide additional functionality. And that's where you can really get locked in to Hibernate by going outside of what is specified in JPA and using some of those additional features. So now that we have the big picture, let's take a look at some small details. First, the JPA specification, and that was specified within JSR 3.17. So that was introduced for Java persistence. And as we mentioned, it provides a standard API which ORM vendors will base their implementations. So JPA being that interface and the ORM vendors creating the implementation for that interface. And what that allows us to do, supposedly in theory, is that we could swap out our implementation with another. So let's say we follow strictly JPA standards and we only use JPA annotations within our project. In theory, we should be able to rip out our ORM provider, let's say it's Hibernate, and replace it with something else like Eclipse Link, and it should be a seamless transition. That doesn't always occur, but it's the theory behind it. We will find all of our JPA annotations in the javax.persistence package. If you see that imported within your class, that means that you are using JPA annotations. Now let's talk a little bit about Hibernate annotations. As we mentioned, they provide those features beyond JPA. When we're looking at JPA annotations, we're talking about a lot of the base ones. So we're talking about like the table annotation, the entity annotation, the column annotation. So a lot of the basic ones. Hibernate's going to provide you with more of the complex ones. For example, they have like a calculated value annotation, and we'll see that in action. Once we use Hibernate annotations in that functionality, we are coupling our application to Hibernate. It is okay to mix these annotations. Actually, it's required in some instances when JPA doesn't provide the functionality you need. But just do know that once you go beyond JPA, you are no longer able to supposedly swap that implementation. And then finally, our Hibernate annotations are in the org.hibernate.annotations package. So when you see that import, you know you're using Hibernate annotations. And just to wrap this all up, I just want to give you a real simple visual that I kind of think of in my mind when I think about Hibernate and JPA. And that visual is that within Hibernate, JPA is a subset of Hibernate. So Hibernate contains all the functionality to implement the JPA specification, but if we look beyond that box, when we move out into that goldish color, then we're using Hibernate-specific functionality and we are actually coupling to Hibernate. But anything that you can do with JPA, you can do with Hibernate. The inverse is not true in this case. You cannot do everything in JPA that you can do in Hibernate. In this lesson, we will discuss field versus property access. So when we use Hibernate, we must decide how we want Hibernate to set and retrieve the values of our entities. We have two options. The first option is through the fields of the class. When we use field access, Hibernate directly accesses each field within the class to set a value for the field or to retrieve the value of the field. So for example, in this class we are using field access. When Hibernate attempts to obtain the value of the user ID, it will do so by just accessing the value of this user ID field. It would be very similar to how we access the value of this field within our class itself. It's almost as if Hibernate has access to that private encapsulation scope. So the other option is property access. And when we use property access, that means that Hibernate will use the get and set methods for a field to set or retrieve its value. There are two ways that we can tell Hibernate which type of access to use. The first way is to put the ID annotation on the get method of our primary key. So for this class, user, the primary key field that is associated with the primary key in the table is the getUserID method. So we annotate that getUserID method with the ID annotation. And that is a flag to Hibernate that I'm going to use property access. So to complete our mapping, we will need to move each of our annotations from the field to the property. So here I'm just moving all of the annotations that were on the user ID field to the user ID get method. And we'll do this for each of our fields. Instead of you watching me move each annotation, I'm going to go ahead and make these changes, and then we'll return to our lesson. And we'll format our class. That shortcut that I was using is Control-O, and that's the outline shortcut. It will provide an outline of your class. So you can see that we have removed all of the annotations from the fields within our class, and we have placed them on the get method. So now let's switch over to our application, and the application simply inserts a user into the database. We're just going to use this to run a demo of property access. And if we look at our console, we see that we inserted the user into the database and we closed our connection. So we have successfully used property access to insert a record into the database. And now we're going to head back to our user class. And there's one other annotation I'd like to show you, the access annotation. And that is just another way to specify the type of access you would like Hibernate to use. So here with the access annotation, we can specify an access type which is an enum, and that has field or property access. So we're just going to say that we're using property access. And if we run our application, we will see that we get the same results once we add that annotation. I like using that type of annotation at the top of the class because I think it's nice to have that information as soon as you first begin. Now, of course, you will see that your fields are not annotated and you can pretty much assume. But actually, if we didn't have that annotation in place, we really wouldn't see all of our column annotations, and it might be a little bit harder to discern that. So when do you use field access and when do you use property access? Well, the argument for property access is that within a get or set method, I can place other additional business logic. So for example, in my set method, I could place some validation, and then when Hibernate tries to call that method, that validation can happen. Other arguments for using accessors is that you do not break encapsulation, because what we're actually doing is allowing Hibernate to access our fields that have a private access modifier specified on them when we use field access. And many will argue that we shouldn't allow that encapsulation violation to occur. Personal preference, I really like using fields. I normally do not include any sort of business logic within my get and set methods or my accessors. So I really don't have a need to use property level access, and I prefer field level access. This lesson will take a more detailed look at the column annotation and some of the elements that are present on the annotation. We will be particularly interested in how the elements and their values affect Hibernate's execution. So if we navigate down to one of our column annotations, we can dive into the annotation and we see all of these different elements on it. There are a few we are particularly interested in, and one is the insertable element and the other is the updatable element. And basically what these two elements decide is whether Hibernate includes a column during an insert or an update. So why would that be valuable to us? Well, certain columns may not need to be included in every update or every insert. So, for example, we have the created date and the created by date. And these are usually stamps that we place just to have that kind of metadata about when a record was created. Well, we would not need to include these columns when we perform an update because they should not be changing. In fact, it would be bad if they were. We can use the updatable element and set it to false. So I'm going to specify that for both of these fields. And now we can run a quick demonstration. So here we see that we are inserting an element. And what we'll do is we will pull that entity from the database after we have inserted it. So I can just use the get method on the session. And then I will grab our existing user that we've inserted. And I will get its user ID. And we will obtain that from the database using session. And then we just need to cast that to the user type. Now we will modify the user. I'm just going to set the first name to something different. And what we'll do is we will commit our transaction when we perform the insert. And then we'll need to begin a new transaction. And we can actually just call begin transaction instead of session.getTransaction.begin. So that's another way to start a transaction. And then once we have that transaction open, we can use our session to update our user entity. Okay, so we have that in place. Now let's run our application. And here we see our console output, and we're looking for our update statement, and here it is. And you'll notice when we look at that update statement, we no longer see the created date or the created by columns being set. And that's because we set the updatable element on the column annotation to false. So we will no longer include those columns when we update our entity. So now let's return to the user entity. And now we'll take a look at another element on the column annotation, and that's the nullable element. And the nullable element simply specifies that the field cannot be null at the Java object level. So all we have to do is set nullable to false, and we will prevent nulls from being attempted to be persisted to the database. Now, by default, if you do not specify a nullable element, the option is set to true, so you would allow null elements. Now, what we can see, though, is if we do not specify this element, and we have a not null constraint in place in our database, we will receive an error. So I'm just going to set our birth date field to null, and let's see what happens when we run our application. Well, you can see that here we received an exception, and it's actually coming from our database. So it's complaining that we're violating a null constraint. Our birth date column cannot be null. Well, one nice thing would be if we can actually prevent that exception from being thrown by our database, so we could prevent it from ever reaching that point where we violate that null constraint. So if we set the nullable element to false, we will notice that this exception will actually be thrown by Hibernate instead of our database. So let's head back over to our application. And here you see that instead of receiving an exception from MySQL, which was our database provider, we received the exception from Hibernate instead. So our ORM has provided us with information about a constraint that we were going to violate. So that is one of the benefits of using the nullable element. Another way this can be specified is by using the basic annotation, and that will have pretty much the same effect. The only difference is that the basic annotation will not specify that we need a not null constraint if we are using Hibernate to generate our DDL. Hibernate can basically build our schema for us based upon the mapping metadata that we provide it. However, the basic annotation will not provide any information to Hibernate when it creates that schema for us. Just know that the basic annotation can also be used to specify not null. However, when you use the annotation or the element type, it's best to just use one, and I normally prefer to use the nullable element as opposed to the basic annotation. So those were just a few more of the elements on the column annotation that you could use, and they can be helpful just to tell Hibernate to perform in a little bit different of a manner when it persists our entities. In this lesson, we're going to discuss identity and how it relates to the Hibernate framework. When we discuss identity, what we're talking about is how we uniquely identify entities within our domain model. So we know our entities are in Java. We create them using POJOs. And when we have instances of an object in Java, we have a few ways of comparing them. The first is using the equal operator, and that pretty much compares two objects to see if they are the same object in memory. We're saying, are these two objects the same instance? We also use the equals method. And the equals method is more the idea of equivalence. These two objects don't need to particularly be the same instance, but are the values of these objects the same? And we talk about this a lot when we think about strings. Have you ever tried to compare a string using the equality operator, so the double equal sign? Well, we know that's not the correct way to compare the values of strings. We know that we use the equals method because we don't really care if our strings that we're comparing are the same instance. We care more about if they have the same group of characters. What we need to keep in mind in regards to Hibernate is that it's persisting information to a relational database. And within a relational database, keys really determine whether a record is equal to another record. I mean, think about a where clause. A lot of times we'll have where user ID is equal to some value. So in order to determine the identity of a record, we are using its primary key. This brings us to primary keys. How are they created? Well, we know there are two methods. There's surrogate keys and natural keys. And surrogate keys are just a unique identifier that we generate with our database. There's different methods of doing that. Some will use a sequence, others will use an auto number. And then when we look at natural keys, that is some column within our database that is unique, that has some business meaning we use to uniquely identify a record. And that's really the foundation of a relational database is those keys and relating them together. So what we're going to do is we're going to focus on surrogate keys because they are the preferred method of keying our tables when we are using Hibernate. You always want to use surrogates if possible. The only time you should really be using natural keys is if you are inheriting a database. At that point, Hibernate provides us with additional mappings so that we can key using natural keys and composite keys. But for this lesson, we're going to be focusing on surrogate keys and how do we generate those keys using the annotations we are provided through Hibernate and JPA. So we've already seen this in play. We use the ID annotation to denote our field that corresponds with the primary key within the table. And then we add the generated value annotation, and this tells Hibernate that we are going to generate this value somehow. Now, how do we do it? We specify a strategy, and we saw that using our MySQL database, we could use the generation type identity. And the identity generation type relies upon the underlying database column to generate the primary key. So if we go over to our MySQL database, and we look at our table for the finances user, here we see that the auto increment checkbox is checked for our primary key user ID, so the database is providing that value. Now, there are other methods of generating our identifiers. So let's assume we were using the Oracle database. Well, we know that Oracle generates primary keys using a sequence. So in that case, we would switch our generation type to a sequence. And when we use generation type sequence, we need to add an additional annotation, and that is the sequence generator annotation. So we will import that annotation, and we must specify a few elements on that annotation. The first is a name. So we'll just call this user sequence. And then we need to specify the sequence name. So this would be the name of the sequence in the underlying database. Now we're using MySQL, so this doesn't really exist, but let's just say we would call it user ID sequence. And what we need to do at that point is return back to our generated value annotation, and we need to specify the generator that we're using to generate these keys. And we simply refer to the name we gave to our sequence generator that we created, and that was user sequence. Now, I can't run through this example because we have not set up Oracle, but if we were connected to an Oracle database and it had a user ID sequence, this would auto-generate our keys. So when we perform the insert, it would reference that sequence to get the key for the user ID. So at this point, I'd like to take a break, and we will pick up our discussion in the next video. So let's pick up our discussion where we left off in the last lesson. We were discussing how we can generate primary keys and how we can use those keys to be identifiers for our entities. So we left off discussing creating a sequence. Now we're going to look at another type of generation strategy for primary keys, and that is the table generation strategy. So we're going to switch our generation type, remove our sequence generator, and for now we'll leave the generator value as an empty string. So how does the generation type table work? Well, you have a table within your database, and when Hibernate needs to obtain the primary key for an entity, it searches that table to find the associated record that stores the next value for the key. We're going to see this in action. So let's start by creating a table generator. So we just add that annotation, and when we create a table generator, we need to provide a name. So we'll call this user underscore table underscore generator. And we need to provide a few other pieces of metadata in order for this to work. The first thing we'll need to provide is the name of the table. Well, we have to have a table in place that can assist Hibernate in getting these keys. So if we head over to MySQL we will see the iFinances Keys table. If we take a closer look at that table, we see that it has two columns. One is PK name and one is PK value. So what gets stored in here? Well, the primary key name will get stored in the primary key name column, obviously, and that name will relate to what we specify within our entity. And then the primary key value will be the next number that we will use as the primary key. This is a table that I've created. You can name the table anything you'd like, as well as the columns, but you just have to make sure you marry that up with your mapping metadata. So let's go add the iFinances Keys table. And now we need to specify the primary key column name, PK name. And then we also need to specify the value column name, PK value. Format that and see if we can drop that to 2 lines and make it more readable. What we need to do now is take the name of our generator and we supply that to the generator element as its value. And at this point, we are configured to use our table generator. So let's switch to our application class. And here we have a simple example that will insert a record into the database. So I'm just going to execute this example. And there we see our insert statement, all of our console output. It looks like everything worked properly. So let's just head to the database. And we will pull everything from the finances user column. And there we see that we have inserted that record into the database. And we will also see that we now have an entry within our table that is holding the primary key values for Hibernate. Now we'll return to our IDE and we'll begin to discuss our final generation type. And this is a very simple one. The final generation type does not require a generator, and it is actually the default type, so it is auto. And we wouldn't even need to specify this. We could just have the generated value annotation in place. And at this point, you would be using the auto strategy. And the auto strategy just has Hibernate pick the appropriate strategy based upon the database provider. So example, for Oracle, it would pick a sequence. For MySQL, it would pick the identity generation type. So why do we use auto? Well, auto is very compatible because then we don't need to change our generated value annotation if we were to change our database vendor. What about the other strategies we looked at, such as the sequence or the table or the identity generation types? Well, the sequence, it's dependent upon your database vendor. Do they support a sequence? And also, it's good to use because it is actually pretty fast. So there's some pluses and minuses there. It's fast, but it may not be available. Looking at the identity generation type, it's kind of the same deal. Not every database vendor will support identity. However, identity seems to be a little bit slower depending on the database vendor. And then the table generation type is nice because that can be used pretty much in any database vendor because we're just creating that table and it's a database and that holds the value. So you can implement that on any database and it is relatively fast. If you have the option, the best case is to go with the auto generation type and let the persistence provider pick. In this lesson, we will take a look at the transient annotation. So first, let's look at the purpose for the transient annotation. Let's imagine we were working with our user class and we decided we wanted to add a Boolean field to track whether the entity was valid or not. So we're just going to add a private Boolean valid in our list of fields. And then I will generate getters and setters for this field. Okay, pretty simple, right? So we'll just call the isValid method. We can check to see if the entity is valid. If we need to set whether it's valid, we can just use the set method. So let's run over and we'll save everything and we'll run our simple application to insert our user into the database. And what happens? Uh-oh, there's some red. Well, we look at our exception and we see that there is an unknown column valid in the field list. Well, why was Hibernate trying to pull the value for the valid column? We don't have that in the database. We don't want to store that information. Well, by default, Hibernate checks the different fields within the class and it applies defaults to them. So, although we haven't annotated it with the column annotation, by default, Hibernate tries to add a valid column into all of our inserts, our updates, and our deletes. So, how do we tell Hibernate to ignore this field? It's just add the transient annotation to this field. And once that is in place, we can head back to our application and we'll see that this time when we run it, we successfully execute our insert statement. So when you do not want to include a field in Hibernate's mapping metadata, yet you want to put it within the entity class, annotate it with the transient annotation so that Hibernate does not try to attempt to treat that field as a column when it starts to create the different SQL statements. Dates and times have always been a somewhat quirky part of Java. They've always presented challenges to developers because they haven't always been the most intuitive objects to work with. Well, some of these challenges carry over into Hibernate and our mapping of date and time columns to a relational database. So in this lesson, we're going to look at how to handle some of the issues with date and time using the temporal annotation. To help us learn about how Hibernate handles dates and times, I've created a time test entity. With this entity, we're going to run a few experiments that will show us the different methods and quirks of time and dates in Java and Hibernate. On this entity, I have placed a number of fields, and most of these fields are of some sort of time or date type. So for example, we have javautil.date types for 4 of our fields, and that is the date time column field, the timestamp column field, the date column, and the time column. And then looking below those, we see that we have some java.sql types, so some types from that java.sql package. We have 2 timestamp type fields, and then we have a java.sql.date type field, and we also have a java.sql.time type field. For each of these fields, I have created a column within our MySQL database. And those columns are of different date or time types in the database. Usually a database provides you with 3 types of date or time data types. One being like a date time, so you get the date and the time. That's pretty self-explanatory. The other is just the date, and the other is just the time. MySQL provides the timestamp column, which is a little bit different than date time, but that's more a MySQL type of conversation as opposed to a JPA or Hibernate conversation. But you'll just see that each one of our fields corresponds with a column that pretty much its name matches the data type in the database. And we're just going to insert some values into this table, and we're going to see what we get. So let's head back over to Eclipse. One other thing I should point out is that just to help us out, I've created a nice constructor, and with this constructor we just pass in a regular java.util.date, and then it pulls that date and assigns it to the different fields within our class. And with some of those, we need to pass milliseconds into a different constructor, mainly the java.sql.timestamp and date and time types. So all those from that java.sql package need to use the actual milliseconds. But this allows us to set all those fields using the constructor. Let's head over to our application, and we're going to run a quick test. We're just going to insert a time test into the database using the current date. So we create a new javautil.date, which will contain today's date and our exact time. And that will set all of those fields within time test. We'll persist it to the database. We will then refresh the entity with the database, and we will print out the time test using the toString method, which I have modified to show it in a nicer format. So let's run our demo. And within our console, I have disabled the debugging logging I have just set it to show errors and other output that I choose to print out, so we get a slightly cleaned up console. But you'll notice that we do call the toString method and print it to the console. So here we see that with our date time column, so that is one using java.util.date, we get the date and the time, and the same is for timestamp. And then we get down to the date column. Once again, this is using java.util.date. We see that we get both the date and the time. We kind of get the inverse when we look at the time column, which is also using java.util.date. It's mapped to that data type in Java. We get the epoch pretty much, and then the actual time that we specified. However, when we move down and look at the columns or fields that were corresponding with the java.SQL data types, you'll notice the date column, we only get the date, and that's really what we want, because when our database has a data type of date, we don't care about the time information. And looking at the SQL time column, once again, this time we only get a time, and that's appropriate. So actually, the date and time column that correspond with java.util.date fields are not displaying appropriately. And that's one of the issues we're going to look to solve using the temporal annotation. So let's return back to our time test class. And now we'll navigate back to the fields, the java.util.date time. So what is provided by the standard JPA annotations is the temporal annotation. And you'll notice that for the temporal annotation, we specify a temporal type. And that type is either date, time, or timestamp. As we discussed, a timestamp contains both the date and the time, so I will select the temporal type timestamp for our date time column, and I will do the same for our next column because we want the date and the time. You can also set the temporal type by just calling that annotation and then picking the type you'd like. So there's timestamp again. And now for this date column, we need to pick a different type because we only want the date. And then finally, for our next field, we only want the time. So this provides Hibernate with some additional information to tell it how we want to store and retrieve these different fields, which are using a pretty abstract type, java.util.date, because all of the SQL types extend dates. So when we use those, this more detailed typing information can be implied. However, when we use java.util.date, Hibernate really doesn't know what we expect, so it can't provide us with that specific type. Let's run our application with those temporal annotations in place and see what our results are. So here we see, after running the application, that now the fields that were using the java.util.date class are actually giving more of a specific data type that more closely matches what we are storing in the database. So here we see that our date column is only providing us with the date, while our time column is only providing us with the time. And that matches what is being returned by the more specific java.SQL data types. And that's what we would like. Now, it's important to set the temporal annotation for any java.util.date classes or any calendar classes that we use. So in this example, I've only used date, but if you were using calendar as the data type of the field, you would also want to use the temporal annotation. Another reason to specify the temporal annotation is to avoid any casting issues within the actual database itself. There have been instances where there are casts between different data types that are corresponding with date and time columns, and that just crushes any indexing that's going on in your database. So it's always important to specify the temporal type on your java.util.date fields.
Within SQL, we often use calculated columns to dynamically assign the value of a column. Within Hibernate, we can use the formula annotation to derive a property based upon a calculation that is performed at runtime. Similar to a calculated column, the formula annotation allows us to provide a SQL expression that will be executed to obtain the value for a property. Let's run through a demonstration to better understand the formula annotation. So to begin, I'm just going to add a new field to our user class, and this field will be of type int, and I'm just going to call it age. And then I'm going to generate getters and setters for that field. And now we're going to add the formula annotation to the field. And you'll note that this is a Hibernate annotation, so we are moving outside of the JPA specification. And when we use the formula annotation, we need to provide a value. So what I'm going to do is just put in a simple calculation to determine the age of a user based upon the current date and their birth date. So we'll perform a date diff, and then we'll divide by 365, and then we will take the lower of that calculation. Okay, so we have our formula in place. So let's talk a little bit about what this does. When we run a select statement for the user entity, when the columns are listed in the SQL statement, instead of just having the normal column name, this calculation will be inserted into that select clause. We will not see this calculation appear for inserts or updates, and it's important to note that this is only after a select has been executed against the database. If we were to say insert a record into the database, it would not have the age value populated because we have not ran a select. We'll see that in a little bit when we run our demonstration. Another important thing to consider is that if we were to, let's say, run the select statement and we get the age back, and then we were to change the birth date, at that point the age property would be out of sync because we have not ran the select. So you really need to refresh the entity with the persistence context before you can get an accurate value on a calculated column. So let's navigate to our application class, and we will try out this demo. So our application simply creates a user and inserts it into the database. We'll notice that the setBirthday method accepts the return value of invoking the getMyBirthday method. And if we explore that, we'll see that it just returns my birthday. So we will find out how old I am. Now, if you remember correctly, I said that we need to refresh our entity against the database in order for the calculation to take effect. So here we insert the user and then we commit the transaction. So after that, we need to call session.refresh and then pass in our user entity. And then at that point, we should get a refreshed user entity with the calculation in place. Let's grab my age at that point. So let's run our application. And if we expand our console, we'll see that we insert the record into the user table, and then through the refresh operation, we run a select query against the database. And if we scroll to the right, you'll notice that our calculation is used to retrieve an alias of formula, and that is what is set for our age property. And then we look and we see that my age of 30 is printed out to the console. So let's head back to our user class. You'll notice that for the value of the formula annotation, we are specifying SQL. One word of caution about this. When we specify native SQL, we have the ability to tie ourselves to the underlying database. For example, if we were using Oracle, I could use the NVL function or some other function that is specific to Oracle. At that point, I can't transfer easily over to another database vendor. So it's important to be careful to stick to standard SQL when writing these formula annotations, or to at least be aware that we may be coupling ourselves to the database.
In this lesson, we will begin to discuss Hibernate types, and we will pay close attention to the basic value type. We're going to discuss how the different types within Hibernate impact the types of mappings we use when we annotate our entities. So let's first talk about how Hibernate works. When Hibernate starts up, it looks at every entity, so it would see our user entity, and then it would begin to inspect the fields on that entity. And when it inspects the fields, it pays close attention to the data type of the field. So for example, it would encounter the user ID field and see it is of type long. So it's going to denote that about this entity. So it will look down through and find our different data types. You see we have a string, a user, a list, and an address class. And what happens when it persists to the database is that it needs to know how to convert these Java data types to the appropriate type in the underlying database table. So if we are persisting this user entity to the user table, Hibernate needs to know how to convert a Java type of long to a database type of big integer. The way Hibernate does this is by having its own internal types that provide that translation. Now, it's not just enough to define things like a long gets persisted as a big int, because we have more complex data types within Java. For example, Hibernate cannot provide us a type that is going to map a user to a database table. So we need to define something like that type. It's more complex. The same with a collection and an address. We need to provide more information to Hibernate for those more complex types. And that's really the importance of this lesson. These types are going to fall into different categories, and depending upon the category that they fall into, it's going to determine how we map that field's type using Hibernate or JPA annotations. So let's talk about some of these types. The first one is an entity type. And an entity type basically corresponds with a record within a relational database. And we know that records in a relational database have their own identity, and that's defined by a primary key. So in Java, our entities normally will have an ID annotation, and they will be annotated with the entity annotation. That's because they correspond with that database row and they have their own identity. They also have their own life cycle. So when we're working with a persistence provider, the entities will fall into different states. For example, if I use the new operator and create a user instance, that entity has not been persisted to our database. We would call that transient. And if we persist it, then it moves more into a persisted state, and that's its life cycle. The entity types have that. As we saw earlier, our entity type user had other fields within it, and those fields are often value types. And what's special about a value type is that it doesn't have any database identity. So think about a string on our user entity, the first name string. We don't write that to its own table. That string doesn't get its own primary key. We only write that first name string to that database column when we persist the user entity. That's the only time it gets persisted. So our string first name doesn't have its own life cycle. It doesn't have some unique ID that identifies it. It is basically owned by that user entity. Now, a string is a basic value type, and that falls in the category with all the primitive types. They're considered basic. They map to one database column, and that's it. There are also composite value types, and those are classes like address. They don't have their own identity, but they are a type that is aggregated, so it contains other fields within it. They are a little bit more complex to map than something like a basic string, but they don't have their own corresponding database table. They don't have their own identity. They don't have their own life cycle. And then finally, there is a collection value type. And the collection value types can hold other value types, so you can have a list of strings, or they can hold entity types, so you can have a list of users. So those are our three value types. We're going to mainly focus on the basic value type. we are going to use this terminology as we talk about additional mappings. So in our last video, we were talking about the different types in Hibernate, and we talked about entity types and value types, and we're going to pick up that discussion now. We're going to take a look at a class, and we are going to label some of the fields within it. So let's take a look at a class, and we will categorize the fields within this class or entity. So we have the user entity, and the first thing we see is the user ID field, and we look at that long data type. Well, a long data type is owned by the user entity. Its lifecycle is dependent upon user, and it's not an aggregate data type, so a long doesn't contain other fields within it. So it is a basic value type. It corresponds with one column in the relational database. If we look at our first name and last name strings, they would also meet the characteristics of a basic value type. And then our next field is rather interesting. It is of type user. And if we look at our class, we see that user is marked as an entity. It has an ID annotation. So we know that this is an entity type that is composed within another entity type. Moving on, we see a list of strings. So that is a collection value type. It holds many value types, or it could also hold many entity types. Now, the important thing to note is the field itself, the collection itself, is a value type. It doesn't matter really what it contains. The thing that determines whether it is a value type or an entity type is the fact that it's a collection. Now, there are different mappings for a collection value type that contains other value types and a collection value type that contains entity types. And then finally, we move on and we see a composite type address. The address does not have its own life cycle. We wouldn't have a table to hold just all addresses. It is owned by the user entity. What we would see in the database is all of the fields within our address class, such as line 1, line 2, city, state, and zip, within the user table. That address class does not stand upon its own. We can't form relationships to it outside of the user class, and that makes it a composite value type. So there's some important things that you should have picked up on from that analysis about value types. The first is they do not have a database identity, so there's no ID annotation. String doesn't have an ID annotation within it. They are embedded within an entity. They're composed within an entity. So that's composition. There is a string last name within user. It doesn't have its own life cycle. We can't just persist that string by itself. We need to persist the owning entity, which would have been the user, and that's how that field gets persisted into the database, not on its own, but as part of an entity. That's really what distinguishes a value type and an entity type. There are these three subcategories. There's a basic type, a composite type, and a collection. We really want to take a look at basic types. Up until this point, our demonstrations have all used basic types. A basic type is mapped to a single database value. So it's mapped to a column, and it is a non-aggregated Java type. Non-aggregated means that it is a type that doesn't contain other fields. There are no other fields composed within it. Here's just a list of some of the basic Hibernate types. Now, what's interesting is you see kind of things you would expect: the integer type, the long type, short. So there's a lot of the primitives. But then you see yes underscore no, true underscore false. Those are different mappings for booleans. Think about how a boolean could be mapped in a database. Well, there may be a data type boolean within the database itself, and Hibernate could map that. Or maybe you use a Y or an N indicator within a single char1 column. Well, Hibernate provides a type to map that. And it also provides a type to map like a single bit that's flipped on 1 or 0. So there's different ways to map some of our data types, and you can specify that using a Hibernate data type. You need to remember that Hibernate data types are that translation between a Java type and a database type. Now, if you're curious about what all data types exist, you can go to the Hibernate documentation, and it's going to list all the basic value types. And if you look down through, you will see all of the types that Hibernate maps. And remember, we're looking at basic value types. So here we see all of the types that are defined within the JDK. And here's the Boolean types. Those are interesting because that has the yes, no that we have. If you look at the last one, org.hibernate.type.true false type, there you can map it with a T or an F, and it looks like case doesn't matter. So you can specify those types. Once again, these are Hibernate types, so you would be coupling to Hibernate when using these types. So let's return back to our PowerPoint. As we move along and we learn different types of mappings and different annotations, we're going to cover the other types that we kind of just glanced over in this lesson. But it's very important that you're able to identify them because it's going to discern what type of mapping you use. In this chapter, we will learn how to provide mapping metadata for composite and collection value types. We will learn about a set of annotations that are used specifically when mapping these value types. The first one we'll look at is the composite value type, and you'll see that this is pretty straightforward. It's not as difficult to map as a collection type. We will also learn how to map a collection of basic value types. So this would be like mapping something like a list of strings or maybe a list of integers. And then we will also learn how to map a collection of composite value types. So this would be like mapping a list of addresses. So our last two objectives deal with mapping the collection type, and it points out an important note about collections. The collections can hold basic value types or composite value types. In either circumstance, we are still dealing with a value type because we are working with a collection. So let's spend a minute discussing composite value types. On this slide, we see the basics of how a composite value type works. On our user entity, we have a field named address of type address. Now, address is represented by a class address, and it has several fields of its own. These fields map to columns within the user table. So if we look at our user table on the right, we see address line 1, address line 2, city, state, and zip. A composite type is kind of like a group of fields stored together in one class that we then embed within an entity. So as we just mentioned, a group of values in a single Java type. So we saw address line 1, address line 2, city, state, and zip within that address type. Now, one thing I need to point out is that when we are using JPA terminology, we call them embeddables or embedded types. And when we're talking about Hibernate, we're talking about composite types. These two terms are interchangeable, and you might hear me use them that way. One thing I'd like to point out, these are not entities. They don't have their own life cycle. The only time that we will persist an embeddable or a composite type is when the owning entity is persisted. So it doesn't have its own unique identifier, its own primary key. These are not associated with their own table. There's no surrogate key defining this object. Its identity is tied solely to its containing entity. And then, as I've already alluded to, it does not have its own life cycle, so it can only be saved or retrieved as part of its parent entity. And we saw how the data for each of the fields in that Java type are embedded within the parent entities table. Now let's turn to collection value types. In our bank entity here, we see that there are a list of strings, and that list is called contacts. So that contacts field represents a collection of strings. That's how we get the collection value type. So here this collection is holding a basic value type. And when we map these collection types to the database, they need to have their own table. we saw how the embeddable or the composite type was stored within the parent entity. Once we have multiple items that we're storing in a collection, then we need to break out into a separate table. Now, you'll notice that in the bank contact table displayed on the right, we don't have really a unique identifier for bank contact. It's more keyed based upon the bank ID value. And that really defines the identity of the bank contact table. So it borrows that from the actual entity it's stored within. As I've already mentioned, a collection type can hold basic or composite value types. It gets a little bit more involved when we store composite value types as opposed to basic value types, but we will see the annotations required to map those. And we've already covered this too, that once we have multiple records that we're storing, once we have a collection, we need to branch out into a separate table. We can no longer store our records within the parent entity. Just like embeddables or composite types, collection value types do not have their own life cycle. They're reliant upon the parent object, and they don't have their own unique identity. It's dependent upon that parent entity's identity. So that's an overview of our chapter. Let's get started with our lessons. In this lesson, we will learn how to map a composite value type. So we have this bank class, and within the bank class, we basically specify an address. Since that information is going to be reusable throughout our application, we would like to move this to its own class. Let's select all of our fields that correspond with address, and we can use the format dialog to create a new class named address, and we will just simply pull the fields that correspond with an address, and we will uncheck the others. Eclipse will pull all of those fields into a new class named address that we can then pull our column annotations in for. Format that a little. So we have a new address class. That address class is used as one of the field types within our bank entity. So this is exactly what we mean when we say a composite value type. We have a type that is kind of a custom class that we have created. And within that class, there are other fields that are going to correspond with our database columns in the database. Another thing that you'll remember about a composite value type is that this type does not have its own life cycle because it is not an entity, and it also doesn't define its own identity. Notice how none of our fields are annotated with the ID annotation? That's because in the database, this object will not have its own representation as a record in a table. It will actually be part of a record, and that will be the bank record. So it's just a piece of that bank record. We have pulled it into its own object because we're working in an object model as opposed to a relational database model. So once we have the class that we have extracted, then we just add the embeddable annotation onto it. As you can see, that's a JPA annotation, and that just indicates that this class is a composite value type and it can be embedded within an entity. So we return to the bank class, and we just specify that the address field is an embedded type. So it's saying we're pointing at an embeddable type. You do not have to have the embedded annotation by default. What Hibernate will do is it will go to the address type, and it will see that it has that embeddable annotation. At that point, it knows it is a composite value type. But I like to put it there just so, as a programmer, you can see that and recognize what's occurring. So let's save our bank class, and we will run a quick demonstration. So this simple application just builds a new instance of bank, and then it inserts that entity into the database. So we will run this application, and there we see that our record was inserted. Let's go query the database, and there we see that the bank entity was inserted into the database. And you'll notice that address line 1, address line 2, city, state, zip code, all of those fields that we mapped within the address class, they actually sit within the bank table. It's not like we have a separate table for address, and that's the whole point of a composite value type, because it sits actually within the entity. It's owned by the bank entity, and although it's abstracted out into an object, all of the database columns are sitting within the bank table, which the bank entity is mapped to. So now we're going to return back to Eclipse, and we're going to run through one more demonstration. Let's imagine that we wanted to add an address to the user entity. So come down here, and we're going to add a field of type address to the entity, and then we're going to add getters and setters, and we're going to mark that field as embedded. And now we're going to go to our database, grab the fields from the address in our bank entity. We'll just copy those. We're going to go to our finances user and alter this table. We will paste these in, and we're going to prefix all of these with user. So we're going to change the name of these fields. And I'm just going to do the first two fields. I'm just going to add user address line 1 and user address line 2. You can pretty much imagine all those fields being prefixed with user. Well, how would we handle that within our mapping? Because when we look at the address class, we see that we're using address line 1 and address line 2, whereas in user, we may have those different column names. Well, there is an annotation that we can use to handle this situation. The annotation that we would use is the attribute overrides annotation. And within this annotation, we specify an array of attribute overrides. And for this annotation, there is a name element. And this is just the name of the field on the embeddable class we'd like to override. So address line 1. And then we specify a new column. So we actually use the column annotation, and then we give that column its new name, which was user address line 1. And now I'm just going to copy our first attribute override. We will specify our second one. So I just need to change those 1s to 2s because we also changed the name of that second column. So you could use the single attribute override annotation if it were only one field that we needed to override, but since we are specifying multiple overrides, we need to use the attribute overrides annotation. Now let's run through a quick demonstration. We'll need to remove our bank type, and now we need to create a new user, and we will actually need to create an address object also. So we will import the address. And now we will begin to set the fields on our user instance. So the first field we'll set is the age. I'll set the age to 22 and set the birth date of the user. We'll just set that to today's date. Next, we will set the created by field. I'll just say that I have created this record. And now we'll set the created date field. We'll say I created it today. The next field I will set is the email address, and any string works here. It doesn't need to be a valid email. And then I will set the first name, which will be my first name, then the last name, which is Bowersocks. Now we'll set the last updated by field, and we'll follow that by setting the last updated date field, which we will set to today. Now we need to set the fields on our address instance. So I'll set the address line 1 field to line 1. Next, we'll move on and set the address line 2 field to line 2. And now we need to set the city. I'll actually set that to Philadelphia. And now we set the state field. And we know that Philadelphia is in Pennsylvania. And then finally, we'll set our zip code. 12345, anything works. And now we'll set the address field on the user object. We'll just pass in the address. And now we will save our user. And we see that we inserted into the finances user table. So let's just go verify that. We should have a record with all of our address information populated. There we just used attribute overrides. So in this lesson, we took a look at the embeddable annotation and the embedded annotation so that we could map a composite value type. In this lesson, we will learn to map a collection of basic value types. So we're going to learn how to place a collection on an entity and then how to store that collection within the database. So when we talk about a collection of basic value types, we're talking about like a list of strings or a collection of strings, maybe a set of strings, or it could be integers. We're talking about how to map that sort of information to the database using Hibernate. And to learn more about these mappings, we're going to work through an example with our bank entity, and we're going to provide a list of contacts for the bank. So in order to accommodate that, we're going to add a new field to the bank class, and it's going to be of type collection. We'll give it a generic type of string, and we'll just call it contacts. And then we will initiate this as an array list that holds strings, and we'll import those two types. So there's our collection that's going to hold all of these string values. Let's think a little bit about how this will be stored within our database. If you remember when we worked with an embeddable type, the embeddable type and its associated fields were stored within the table that owned that embeddable type. So if we have a bank entity and it has a field that is of type address, and address is an embeddable, all of the columns associated with address are going to be stored in that table for bank. In this case, it's not going to work like that because we're going to have multiple names, and we can't just insert multiple records into the bank table because then we're not going to have unique rows for one bank record. What we need to do, if we look at our database, is create another table. So I have created a bank contact table that will hold the bank ID and the name of our contact. And you'll notice that both of these fields are concatenated together to make our primary key. That's important so we don't have duplicate keys for this table. So this is the table that will hold our list of contacts. So how do we map to that table? Well, the first thing we must do is add the element collection annotation to our field. And this annotation says that we are trying to map a collection of instances that are a basic or embeddable class. So that is their type. They're either a basic type or they're a composite type or an embeddable, which is basically the same as composite. Once we have this annotation in place, we need to provide more mapping information. And to do that, we create the collection table annotation. And this is how we are going to provide Hibernate the mapping metadata for the table that we created to hold these bank and contact pieces of information. So here we'll define that mapping. First thing that we need to define is the name of the table. And we knew that was bank contact. And the second piece of information we need to define is our join column. You'll notice that we had the bank ID within the bank table, and we had the bank ID within the bank contact table. So if we were to join those two tables together, we would use the bank ID column within our on clause. So that's just what we're saying here. This is that column that we would put within the on clause. And we need to specify that using a join column annotation. And then we just put the name of that column. So we'll import the join column annotation. And then the last thing we need to do is we need to specify the column that will actually hold the name of our contacts. And this is the column within the bank contact table. And if you remember correctly, that was named name. So here was our join column. And then here is the column that we actually want to pull the value from. And given that information, Hibernate can successfully perform the mapping. So we're going to now go down to the bottom of our class, and we will add accessors for the contacts field. Let's run a demonstration. Here I have a simple application that just inserts a bank class, and we just need to modify it to add some contacts. So we'll get the contacts and we'll add a new one. Let's put in Joe, and now we'll get another contact, Mary, and we'll run our application. And there we see that our statements executed. So we inserted 2 records into the bank contact table, 1 into the bank table. So let's just head over to the database. We'll select our rows. There we see that we have Joe and Mary in our database. We'll head back. The last thing I just want to discuss is that this would not need to be a collection. We could actually turn this to a list. And with that list in place, we'll see that our application, after a few type changes, will also persist this information to the database. So we'll just put that list in place, run our application. There we see that we inserted to the bank contact table with a list. We can also switch this field type to a set. The only thing this mapping will not work for as far as the collections go is pretty much a map, but you can use the list, the collection, or the set with this type of mapping metadata. In this lesson, we will learn to map a map of basic value types. What we're basically looking at is having a hash map and storing that hash map within the database and associating it with an entity. So we're going to work with the bank class, and we're going to modify one of our existing fields, our contacts field. Currently, this collection is of type list, but we're going to turn it into a map. And holding with the idea of using basic value types, we're going to give this map a key of type string and a value of type string. So we will change our implementation to use a hash map here. And at this point, our application would be able to use this map. However, we wouldn't be correctly mapped to our database using our existing annotations. We would still use the element collection annotation, the collection table annotation, and the column annotation. However, we need to add one more annotation to this mapping, and that is the map key column annotation. And all we need to do for this annotation is specify a name. So we're going to call this position type, and that will be the name of the column that holds our key for the map, and then name will be the name of the column that holds our value for the map. Much like when we stored a regular list, we needed to have a table to hold the map because there's going to be multiple values within the map. So that justifies our use of a collection table and also the element collection annotation. Now, one thing you'll notice is that if we look at the database, we did not have for our bank contact table a row to hold the map key. So we're just going to add our map key column here, and we'll make it a varchar, and we'll say that it's not null, and I'll increase the width to 100. Now we have a column to hold our map's key, and then when we look at our mapping, we see that we have specified our join column, which is bank ID. Once we adjust our get and set methods, this mapping is ready to go. So I'll just add the map type here, and we'll specify the generics of string and string for the key and values. And now we'll head over to our application, and let's add some values into our map. Here I'm going to put the manager as a key, and the manager's name will be Joe. And then we're going to add a teller, and that will be Mary. Now we should have the mappings in place in order to store a hash map within the database. So this is a collection of basic value types, and our collection happens to be a map. So we'll save everything, and now let's run through our example. And there we see that we inserted 2 records into the bank contact table, and we put 1 into the bank table. Let's go back to the database, and we'll query the bank contact table, and it should look different this time. You can see we have listings from when we were using a basic collection before, but now we have these 2 entries that correspond with using a map. So if we wanted to know who our teller was at the bank, we could pass that into our hash map and get Mary back. So in this lesson, we looked at how we can map a hash map or any old map to the database using the map key annotation in combination with our element collection and collection table annotations. And with all those annotations in place, we can persist a map of basic value types to the database. In this lesson, we will learn how to map a collection of composite value types to the database using Hibernate. You'll remember that when we work with a composite value type, we are talking about something such as the address class here that we see annotated with the embeddable annotation. It doesn't have its own identity, and it has to have an owning entity to provide it with that identity. When we head back to the user class, we see the user entity, and within the user class is an address field, and that is our embeddable type. So we annotate this field with the embedded annotation so that Hibernate knows we are using an embeddable. And what will happen when the address class is persisted as part of the user entity is that the values within the address class will map to columns that are contained within the user table that the user entity is associated with. So we're putting all of those values into the same table, although they are in different objects within our object model. So this is a single address, and for our purposes, we're interested in a collection of addresses. So we're just going to turn this into a list. And we're going to instantiate our list with an array list, and we'll specify the generic type of address, and we'll import those types. We went from having one address that was owned by this entity to having many addresses that are owned by this entity. We're going to need to change our relational database to handle this structure. So now let's navigate to the database, and we will see that we have our finances user table. So let's open that guy up, and here we see all of the fields that correspond with the address that we're setting on that user entity. So I'm just going to cut those fields because we're going to remove them, and I'll apply those changes, and we'll finish that. And now we're going to create a new table. We're going to call this table user address. And within this table, we're going to create a field, user ID, of type big int, and that's going to be part of our primary key. And now I'm going to paste our remaining columns. And we're going to make each one of these a part of the primary key. So this table holds all of the columns associated with our address. Now, it doesn't have its own identity because we don't see an address ID, where it would provide it with its own unique identity. Its lifecycle and its identity are still tied to the finances user table as well as the user entity in our object model. So this is still a value type. Let's apply our changes here. And now let's head back to Eclipse to map this. And now let's look at the changes we need to make to our mapping metadata. The first thing we'll do is remove the embedded annotation, and in its place, we're going to put the element collection annotation. So this signals to Hibernate that we have a collection of value type or composite type elements. And now we're going to add the collection table annotation, and we need to provide the value for the name element, and we know that that was user address. And then we need to provide a join column. So then we add the join column annotation,
and we need to provide a name, and we know that that was user ID. The next thing we see is all these attribute overrides that we had in place when we were using the single address type. Those attribute overrides allowed us to change some column mappings that were contained on the address embeddable. We still want that to happen, and these attribute overrides will still get applied to each object within the collection. The last thing I'm going to do is clean up some of our getters and setters and add the accessors for the new address field. And let's go to our application now to run a demonstration. Previously, we were creating a single address, associating that with a user, and then saving that within our database. So now we need to create two addresses. So I'm going to create address 2. And I had created a method that would just populate the fields on the address. So I'm just going to duplicate this because they can't be the same since we have them marked as primary keys. And I'm just going to change this information a little. And we'll just make this set address fields 2. I'm just trying to make a unique address here. Set address fields 2 on our second address. Get the address list from the user and add our first address, and then we'll add our second address. Okay, so we populate the address list with two addresses that are unique, and then we set those on the user, and then we set our user fields, and then we save our user in the database. So this example is ready to run. We'll kick it off here. And we see we put one record into the finances user table and two into the user address table. So let's go query our database. And I'm going to refresh. And we'll select everything from our user address table. And there we see our values. So we associated two addresses with a single user using a collection of composite value types. We'll return to the user table and just check out that mapping as we discuss this a little bit. One thing that's very important that you recognize is that address is not an entity. It is a composite value type or an embeddable, so it doesn't have its own identity. We haven't associated entities with each other yet. So don't mistake an element collection and this mapping with a one-to-many association between entities. We'll see that at a later time. This chapter will teach us about entity associations. And entity associations are how the different objects within our system are connected. So let's take a look at our chapter objectives. The first is to learn how to map many different associations between entities. This is what you normally think of when you think of Hibernate. So looking at like a one-to-one relationship, a one-to-many relationship, and then a many-to-one relationship. It's learning about how to put those annotations in place to map an association between two entities so that Hibernate may persist it to our database. And when we're talking about associations, it's important to realize that we're talking about entity types. So these are types with their own identifier and their own life cycle. We're no longer talking about value or collection types. These are strictly for entities. And our final objective is to understand a bidirectional and a unidirectional relationship. As we'll see, a bidirectional relationship actually establishes two associations, where a unidirectional relationship only establishes one. Now let's cover some important lesson notes, things you need to know as we work through these lessons. First is very simple. I'm going to use the term relationship and association interchangeably. Both terms are simply talking about how entities are connected within our application. And then finally, we're going to talk about owning entities and non-owning entities a lot. You'll see to annotate some of these associations, we'll need to use a join column or a join table. And depending upon which entity that join column or join table falls on, will determine whether it is the owning entity or the non-owning entity. With each association, there's going to be two entities. And if we place the join column on one, that becomes the owning entity, and then the other entity is the non-owning entity. You'll often see that the owning entity corresponds with the entity whose associated table contains the foreign key column.
This is almost always true in bidirectional relationships. Unfortunately, it is not always true in unidirectional relationships. That just gives us a quick overview of what we're going to look at within this chapter, and we'll cover these topics in much more detail within our lessons. In this lesson, we're going to have an important discussion about entity associations. Entity associations are important because when we build applications, we're not writing data to simply a single table. Within our data model, we often have different entities, and those entities are related to each other in different ways. The classic example is the one-to-many or the parent-child relationship. So here we see a data model, and we have an account table, and it is related to a transaction table. You'll see that within the transaction table, we have a column that denotes the account ID, and that column has a foreign key constraint to the account table and its account ID column, so its primary key. And that defines our one-to-many association. We know that an account can be a part of multiple transactions, while a transaction can only be linked to one account. This is the type of information that we need to store when we develop applications, because what we often see is these types of relationships will find their way into our object model. For example, here we see the transaction entity on the left side of our slide has a field of type account. So that's establishing the association between transaction and account. Our goal is to learn how to model these associations using mapping metadata. So let's talk a little bit about entity associations and what separates them from something like a collection of value types or a collection of embeddables. The first important point is that an entity association is a reference from one entity to another. Now remember, an entity is usually one object that is mapped to a single class that has its own identity, so it has a primary key within the database, and it has its own life cycle. In essence, an entity association is a link between one of those entities to another. Entity associations are supported by an underlying data model or a data structure that's in place usually between tables. So in our example we looked at earlier, we saw that we had that foreign key constraint on the account ID column that was in the transaction table. So we will see those types of constraints in place to support our entity associations within the database. When we talk about entity associations, there is a source object and a target object. So returning back to our transaction and our account example, the account was the target for the transaction. So since we had the account specified on the transaction object, we say that the account is the target because it is that field type within the entity. And also when we look at the data model, we see that the account ID is the foreign key on the transaction table. So that makes it the target object and the transaction the source object. Another important concept when discussing entity associations is the direction of the association. We say that we can have bidirectional and unidirectional associations. So I'd like to just dive into that a little bit more. So when we looked at account and transaction before, you noticed that on the account entity, we didn't have any association with transactions. Now looking at the two entities again, you'll see that on the account entity, I have added a list of transactions. Before that field was in place, we only would have been able to reference the account on the transaction entity. The account could not reach back and grab all of its transactions. We look at this as actually two associations. We have the association from the transaction to the account, and then we also look at it the other way. This is always optional. We can look at it from the perspective of the account, where one account is mapped to many transactions. And those two associations can be defined using JPA and Hibernate annotations. However, we don't always need to put both associations in place. If you do not need to reference all of the transactions within an account, you can forego that mapping. If you do need to reference those transactions, you can put the collection in place within the one side of the relationship and reference that many side, so reference the transactions. Because we are able to reference either side of the relationship from either entity, we refer to this as bidirectional. So in Hibernate, when we deal with entity associations, there are several different types. The first one is a one-to-one association. And here's an example. One account is associated with one set of credentials. And what we're talking about when we say one-to-one is actually the cardinality of the relationship. So the source and target object, what does the numbers look like on each side? And here we're saying one account can have one set of credentials. Now compare that to a one-to-many, which we've already looked at. One account can have many transactions. So we have a different cardinality with this relationship where we are associating one entity with multiple entities. And then we can have the inverse, which is many to one. And this would be looking at it from the transaction side. So many transactions are associated with one account. And then finally, we can have a many-to-many association. And this is when we actually have to use a junction table. So if we have users and there's multiple users that can be associated with multiple accounts. So maybe a husband and wife could be accessing the same account and there's multiple accounts that they can access. Then we have that many-to-many situation. We need to put a junction table in place. So we're going to learn how to map all of these entity associations with JPA annotations. In this lesson, we will learn to model a one-to-one entity association using annotations. So to begin, we're just going to look at our ER diagram and discuss the relationship between the finances user table and the credential table. You'll notice that the credential table has a user ID column, and that is a foreign key to the user ID primary key within the finances user table. So this establishes a one-to-one relationship because what you can't see is that we have a unique constraint placed upon the user ID column on the credential table. So that makes our relationship within the data model a one-to-one relationship. What we need to do is model that relationship within our entities. In order to do that, we're going to add our credential entity to our hibernate.cfg.xml file. We need to define that mapping so that Hibernate will inspect the entity and pick up the mapping metadata. Once we add our entity in, we can close our hibernate.cfg.xml file. And now we can turn to our credential.java file. And here is our entity. So how do we begin building our entity association within our domain model, within our entities? Well, the first thing we need to do is work within our source entity, which is credential. We're going to place a new field on the source entity credential, and it's going to be of type user, and we're just going to name it user. Now we've performed some composition. So we have this field within credential, and the field is of type user. Now, what's important to know is that user is our target entity. So we've talked about source and target entities. In this case, the credential entity is the source because it actually holds the foreign key within the credential table. So that makes it the source entity in this case. To continue with the mapping, we need to use the one-to-one annotation. And this is a JPA annotation, and it's basically specifying the cardinality of the association. So we're saying it's a one-to-one. Well, once we have the one-to-one, we're going to add the cascade element.
and we're going to specify a cascade type of all. What this means is that when we persist the credential, we also want to persist the user that is stored within this field. This will cause both entities to be persisted at the same time. Next, we must place another annotation on our field, and that is the join column annotation, which is also a JPA annotation. What the join column specifies is the column that should be used to join the tables. So it is that foreign key column within the credential. That was the user ID column. One way to think of this is if you were going to write a join between these two tables, what would be the field mentioned in the on clause? And we're particularly paying attention to the credentials field that would be put in that on clause. In this case, the name is going to be user ID. Now, it just so happens that on the user entity, we also have user ID as the primary key column. It's not a problem in this case because both of our key columns have the same name. Let's imagine that the user entity had a different column name for its primary key that we are pointing this foreign key to. Well, in that case, we could specify the referenced column name, and we would just set that to whatever that primary key column name is on the user table. And that would allow us to perform that join. So you can imagine performing a join between two tables where the keys match up, but maybe the columns are named differently on each table. So the name always corresponds with the source entity, and then the referenced column name would always correspond with the target entity. And our source entity would have the actual foreign key column within it. So we don't need to specify that referenced column name, but I just wanted to introduce you to that in case you encounter that situation. If you're ever wondering about some of these elements on the annotations, simply hover over the annotation and hit F3, and that will take you into the source for the annotation. So here you can see each of the elements defined. So here's the name element, and we get some great Java docs with it. And then here is the reference column name. So you could find out that type of information I just provided you by inspecting the annotation. So this is all the mapping metadata that we need to create a one-to-one association between our entities. Now, one thing I want to point out is this is a unidirectional association. So we are only able to access the user from the credential. We are not able to access the credential from the user. So we only have one relationship defined, and it's unidirectional. Now let's run through an example. We'll run this demonstration. So we're going to save our work and head to the application class. In this example, you can see that we build a user object, and what I'm going to do is just add a credential. I'll just use the new operator and the constructor, build our credential. We're going to set the password on this credential. And now we're going to set the username on this credential. And now we're going to head back to the credential class so that we can generate getters and setters for our user field. Once those are in place, we'll head back to the application. And now we can set our user. Instead of persisting the user here and saving that, I'm just going to persist the credential. And because we have that cascade in place, we will end up persisting both the credential and the user. So let's run our example. And there we see that we inserted into the finances user as well as the credential table. So let's go inspect that within our database. I'm going to head into iFinances and we'll query the credential table. We see we have a user ID of 32809. Let's take a look here, 32809. So we just successfully modeled a one-to-one entity association. Let's just head back and take a quick look at that modeling one more time.
We learned how to use the one-to-one annotation, as well as specifying a cascade type. And we also learned how to use our join column annotation. With the combination of those two annotations, we successfully performed a one-to-one unidirectional entity association. In this lesson, we will learn how to map a bidirectional one-to-one entity association. Looking at our credential entity, we see that it has a field of type user, and that field is annotated with the one-to-one annotation and the join column annotation. This effectively establishes our entity association from the credential source entity to the target user entity. Now, when we look at the annotations for the user field, we see that join column annotation. And what that indicates is that the credential entity is the owning entity. And that basically means that the foreign key that establishes that relationship is stored within the table associated with the credential entity. In this lesson, what we're trying to do is establish the inverse of that relationship. We're going to head over to the non-owning entity, which is user, and put some annotations in place that will map a bidirectional association. And that will allow us to retrieve the source entity from our target entity user. So how do we get started building this entity association? The first thing we need to do is add a credential field to the user entity. And that's the whole point of a bidirectional relationship. Being able to reference the owning entity within the non-owning entity. So we're going to be able to retrieve the credential associated with this user, even though that association is mapped over within the credential entity. With that field in place, we're going to add our accessors, and Eclipse makes that easy. So we'll head back to the field, and now we're going to add our annotations. All we need to add here is the one-to-one annotation, and then we need to use the mapped by attribute on that annotation. And this simply specifies the field on the owning entity that maps the relationship. Basically, we are looking for the field that contains the join column. And we know that is our field of type user with a name of user. So I'm just going to copy that, and we'll place that within our mapped by attribute. Some important things about mapping the inverse side. We will never specify a join column on the inverse side, and we will also never specify cascade on both sides, because what happens is if both sides have a cascade present, when you persist an entity, you're basically going to go into a loop where they just keep persisting each other. So it's important not to specify the join column or the cascade on the inverse side of this association. That's all it takes to map a bidirectional association. So let's head over to our application class, and we're going to run our demonstration. Here we see in our demonstration, we are creating a new user as well as a new credential, and then we are persisting the credential. One of the things that we need to do when dealing with a bidirectional association is we need to manage both sides of the relationship. So what does that mean? Well, here you see that we add the user to the credential. We set the user field on the credential. Well, that's going to place that instance of user on the credential instance. So it's going to set that field on the credential. What we don't have occurring is the credential being set on the user. So we need to specify that field's value for the user instance. So we're going to call user.set credential, and then we're going to pass in the credential. And you'll hear this being referred to as managing both sides of the relationship. And the reason being is we can't just set the user on the credential and then expect Hibernate to build a new instance of a credential and set it on the user instance. We have to do that work. Hibernate cannot do that for us. So at this point, we'd be ready to persist, but I just want to add a little bit more code here just to show you that the bidirectional relationship is working. We're going to pull a user from the database, and I'm just going to grab the user from the credential that we're persisting, and then I'm going to get the user ID. I need to cast that, and then I'm just going to print out the name of our user. What that's demonstrating is we are grabbing the user and proving that we are able to access that other side of the relationship, so we can access the source entity from the target and print some information out. Okay, so let's run this demonstration. I'll kick off our application. And there we see that we inserted into the finances user table as well as the credential table, and then leveraged our bidirectional relationship to retrieve the name of our user. That demonstration is successful, and we have established our first bidirectional entity association. So just to recap, when we establish a bidirectional association, we establish that association in the non-owning entity, and that's the entity that does not contain the foreign key. So the table associated with that entity doesn't have the foreign key within it. What we'll do for the one-to-one is put that annotation in place and then specify our mapped by attribute. And that points at the field on the owning entity that has the join column. And that tells Hibernate how to map this relationship. We want to avoid placing a join column annotation on the non-owning side of the relationship. And those are the key points when establishing a bidirectional relationship. In this lesson, we will learn to model a unidirectional one-to-many relationship using annotations. The one-to-many relationship is where most people start out with Hibernate. They dive right in and try to map these entity associations. So this is one of the most popular tasks in Hibernate or in any ORM provider. The first thing we're going to do is take a look at our data model. This is the entity association that we will be trying to model. We know we have an account entity, and that corresponds with our account table. And then we have a transaction entity, and that corresponds with our transaction table. Between these two entities, we see that there is a one-to-many relationship between account and transaction. An account can have many transactions, and a transaction refers to one account. You'll notice that on our transaction table, we have provided an account ID column, and that column will serve as the foreign key back to the account. So let's take a look at how we model this relationship within our entity model. The first thing we would need to do is place both of these entities, account and transaction, within our hibernate.cfg.xml file. Now, I'm not going to walk us through that because we've already seen that numerous times. We're just going to dive right into adding the collection of transactions to our account object. So I'm just going to add the transactions, and we'll instantiate a new array list, and I'll use the Java 7 diamond operator. And I spelled transaction wrong here. We'll fix that. So we have our field in place, and now we need to provide some mapping metadata through annotations. We're going to use the one-to-many annotation. And we'll import that, and that's a JPA annotation. The other annotation we need to put in place is the join column annotation. Now, at this point, you should have a question. We said before that the join column is placed on the owning entity, and the owning entity is associated with the table that contains the column with the foreign key constraint. So what I'm saying is, in this case, the column with the foreign key constraint is account ID, and that sits within the transaction table, And that would technically make transaction the owning entity. And that's where we would supposedly place our join column. Well, we need to remember that this is a one-to-many unidirectional annotation, which means there is no inverse association from transaction to account. So we would not have an account field on transaction in a unidirectional relationship. We need some place to specify that join column. So in this case, the join column would go on the transaction field, and we would point to the account ID on the transaction table. So Hibernate is smart enough to know that we need to inspect the transaction entity to find out what table we will be joining to, and then determine that we need to use the account ID column within our join clause. So let's finish up our work in the account class by adding the cascade type, and we're going to specify a cascade type of all because we want every persistence operation to be cascaded to the target entity, which is the transaction. So I'll import that. And then we need to add our getters and setters. And we'll return to the top of the class. And at this point, I think we are ready to run a demonstration. Now, this demonstration is going to fail, but I want to prove a point to give you a little bit more insight into how Hibernate works. We have this account, and we're going to persist that account to the database. And what I've done is just created two helper methods that are going to build different transactions. One's going to be for a belt, and the other's going to be for a shoe. And we're just going to add those to our account. So I'm going to run account.getTransactions.add, and then I'm going to call our create methods. So we'll create a new belt purchase. We're going to get our transactions, and then we're going to add our shoe purchase. At this point, we have enough code in place to run our demonstration, and it's going to fail, and we'll take a look at what the console output says. So here it says that we haven't provided a value for the account ID. Why is that? Well, if we look at the data model, we see the account ID, and that's part of a foreign key relationship. And we have actually specified that the account ID is not null. So that means for every transaction, we need to have an account ID, and that makes sense. Because we are using a unidirectional relationship, we have not mapped the inverse side of the relationship, and that causes that foreign key column account ID not to get populated. And then Hibernate's constraints kick in and throw an error. So we need to know how to work around that within JPA annotations. Let's take a look at the join column annotation, and what we'll do is add the nullable attribute, and we're just going to say that it is not nullable. By default, when you map a unidirectional one-to-many association, the nullable attribute on the join column is set to true, and we don't want that to occur. So we set it to false. Let's see what the effect is of that. So we'll head back to our demonstration. And once again, we're going to run through. And look at this. This is kind of interesting. Here we see we insert into account. That's great. Exactly what we want. And then we insert our two transaction records. Right what we want. And then after that, we update those records setting their account ID. And that's Hibernate at work right there because we've specified that nullable attribute. So it's going to update that foreign key column with the appropriate value to map it to the appropriate account record. So I thought that was neat just to see an annotation that's pretty important, and setting that nullable attribute on it is also very important. However, it is not well documented. You could also work around that by just mapping the other side of the relationship. For now, we're just going to use the nullable attribute. This lesson will focus on mapping a bidirectional one-to-many association using JPA annotations. Looking at our account entity, we see that we have mapped a list of transactions, and we use the one-to-many annotation. So what we're going to do is establish the inverse side of this relationship so that within our transaction class, we can reference the account. So let's head over there. The first thing that we need to do is add a field of type account. So we'll put that field in place, and then similar to how we map other entity associations, we need to rely upon another annotation, and that's the many-to-one annotation. Here's an easy way to read this. Think about your source in this relationship, and the source entity is the transaction. That's always on the left side, so that's the many. And then the second part, the one side, is always the target entity. So in this case, our target entity is account. So I would read that as many transactions to one account. And since we are now having this inverse relationship set up, we now put the join column on the owning side of the relationship, and that is the transaction because its table contains the foreign key column. So we will specify that it is account ID, and we'll import our join column annotation. And now we need to create some accessors for that account field, and we'll head back up to the account field. So let's navigate to our application class. And here we'll see that we are creating a new account through a helper method. And then we are creating two transactions using helper methods. Now, looking at these helper methods, you see that they accept a parameter of type account. And the reason they have that parameter is because when working with a bidirectional association, we need to manage both sides of the relationship. So what does that mean? Well, that means that on our transaction, we need to set the account. I'll just go ahead and do that in our first transaction, and then we'll head down to the second transaction, and we'll do the same. So on our shoe purchase, we'll set the account, and everything's great there. Now let's head back up, and here you see that I am adding the transactions to the transaction list on account. So the transactions are getting set on the account, and the account is getting set on the transaction. And that's what we mean by managing both sides of the relationship. It's important to do that. This is one area where you'll probably hit this exception at least one time, and it can be difficult to debug at first. So let's proceed and let's run this demonstration. We see one record go into the account table, and then we see two into the transaction table. Well, let's just test out now our bidirectional association. We're going to grab a transaction, call it DB transaction, and we'll grab the session, get. So we're just telling Hibernate to fetch us a transaction, and now we need to provide the ID of one of our transactions. So I'm just going to grab the first one out of the list and get the transaction ID. Then we will cast this object, return to a transaction. Now I'm just going to print the transaction by grabbing the account. We're going to print out the account name. So what we're doing is we're just grabbing a transaction from the database and pulling out the account, printing the name, just to prove that our bidirectional association is working. So we'll run this again, and there we see we get the savings account. So proof that our demonstration is working. And we can also go to the database, pull out those accounts, pull out the transactions, and we see everything is working. That concludes our lesson on mapping a bidirectional one-to-many association. And we saw we do that by using the many-to-one annotation on the inverse side of the relationship. And that allows us to access that one side from the many side. In this lesson, we will learn how to use a join table annotation as an alternative method of mapping a one-to-many relationship. So let's dive right in and take a look at our data model. Within our data model, you can see that we have added a budget table as well as a budget transaction table. And there are foreign keys between the budget table and budget transaction table, as well as the transaction table and the budget transaction table. So those relationships establish what is essentially a one-to-many relationship using a junction table or a join table. You'll hear those terms used interchangeably. What this is mapping in our application is something where we can attach a transaction to a budget. So maybe we want to say that a certain purchase was part of a planned budget. Well, not every transaction could be part of a budget. And if we have millions of transactions in our transaction table, we may not want to include a budget ID for every record in the transaction table, because we could map this one-to-many by putting a budget ID column within the transaction table and then establishing a foreign key relationship to the budget ID column in the budget table. Well, we don't want to have all those null values if there were large amounts of transactions and few of those associated with a budget. What we do is we create a join table. So you see a one-to-one relationship between transaction and budget transaction, and then you see a one-to-many relationship between budget and budget transaction. Essentially, that maps a one-to-many relationship between transaction and budget, but it allows it to be optional. We're only going to have budget transaction records for transaction items that are tied to a budget. So our challenge for this lesson is to map that relationship within our entity model. So let's head back to Eclipse, and here we see the budget entity. And what we would like to do is get all of the transactions within a particular budget. Budget would be our source entity, and within that source entity, we need to add a new field. We'll make it of type list transaction, and we'll call it transactions. Then we will initialize our list as an array list, and once again, the Java 7 diamond operator, and we'll import the list. And now we're ready to annotate this field. Now we must put our mapping annotations in place. So the first one we'll need is the one-to-many annotation. And we are going to import that annotation and then specify a cascade type. And we're just going to use all for this. And then the second annotation we're going to put in place is our join table annotation. So this is a new annotation for us, and we'll import it. It's a JPA annotation. And the first thing we specify is the name of our join table. And the join table's name was budget transaction. And now we need to specify the join columns. So we start with specifying the join column of the owning entity. And in the case of a one-to-many relationship, the owning entity is the entity with the join table annotation. So in this case, the budget entity is our owning entity. You can choose which side of the relationship you place the join table annotation. So now we're going to specify the join column for our owning side. And we just use the join column annotation, so I'll import that. And now we need to specify that it is pointing at the budget ID column. So the column within the join table that corresponds with the primary key of our budget entity is the budget ID column. So therefore it goes first in our join columns that we specify. And then we specify the inverse join column. So now we are talking about the other side, which is the transaction. I'm just going to move that to a new line. Once again, we use the join column annotation, and we specify a name, and this will be the transaction ID. So we have that mapping in place. Let's save this entity, and we will add getters and setters for the transactions field. We'll save once again. And now we'll actually navigate to the transaction entity. Because we will now need to create a transaction and set an account, we need to specify that we're going to cascade the account class when we persist the transaction. So I'm just going to set the cascade type to all. And that will come into play when we run our demonstration, because we're going to create a new budget entity, and then we're going to add transactions to the budget entity's list of transactions. And since transaction relies upon account, we also need to cascade to account when we persist a transaction that is getting persisted by a budget. So there's actually two cascades happening. Okay, so at this point, we're ready to run our demonstration. Let's head over to the application class. And within our application class, I have simply created a new account and also a new budget. we're just going to use some helper methods that I've established. One that creates a shoe purchase, the other that creates a belt purchase. And we're going to put those two transactions into our budget. So we're going to call budget.getTransactions.add, and then create new belt purchase. Notice we're passing in the account there. And then budget.getTransactions.add, and create shoe purchase. So let's just make sure we have everything set. Our helper methods are managing both sides of that relationship. And then we are going to persist the budget. So what's happening here is we're creating an account, and then we're using that account to create two transactions, and we're putting those transactions within the transactions composed within the budget entity. So all this should persist. Okay, so let's run our demonstration. And in our console window, we see that we inserted a record into budget, one into account, two into transaction, and then two into budget transaction. So it looks like everything worked. Let's go check it out in the database. So I'll just navigate to our iFinances schema, and we'll just select everything from budget. And there we see our emergency fund budget. Looks like we're trying to get $10,000 by the end of the year. Then we're going to look at our budget transaction, and we see that two transactions were tied to our budget. It looks like our mappings worked properly, and we'll just take one final look at this mapping. So using the join table annotation, we were able to create an optional one-to-many relationship. And this can be used when you have a one-to-many relationship that might not be wise to use because of issues like performance. So you can kind of abstract that one-to-many relationship out from the foreign key in the owning entity to a join table and get some performance gains. In this lesson, we're going to learn how to map a unidirectional many-to-many relationship. So let's head over to the data model, and we're going to take a look at the underlying table structure for the association we're about to map. Here we see the finances user table and the account table, and those tables are joined together within a join table named user account. And that is because we can have many finances users associated with many accounts and many accounts associated with many finances users. What would the real life scenario be here? Maybe there is a husband and a wife, and they share one account. They both want to have visibility over that account. That is a realistic scenario that we could possibly have to map within our entity model. So let's return back to Eclipse and set up our annotations to model this association. When we model a unidirectional many-to-many relationship, we have to pick which side will be the owning side, and it can be either side. It's at our discretion. I'm actually going to choose the account entity to be the owning side. Within the account entity, what we'll do is create a private set of users, and I'll name it users. We will use the hash set implementation. And now we have our field set up. We will import the set, and we're ready to provide our mapping annotations. Now, one thing you'll notice differently, we used a set here instead of a list. You can use a set, or you can use a list or a map. That's pretty much true with any collection you're mapping. Now, a map is mapped a little bit differently using annotations, but a set and a list, there's not much difference between those two. Just know that you can't have duplicates within a set as you can within a list. Let's get to the mapping annotations. And the first one we need is the many-to-many annotation. So we will pull in that annotation. It's a JPA annotation. And we're going to specify the cascade type as all. And then we're going to add the join table annotation. And within the join table annotation, we need to provide the name of our join table. So let's just head back over to the data model, and we see that is user account. Then we need to fill out our join column attribute. So we use a join column annotation, and we need to specify the name of this join column. This is within the account entity. That makes it the owning entity. So we need to specify the account ID column on our database as our join column. Now we define an inverse join column, and I'm going to drop that down to a second line. We just specify the join column annotation, and now we need to point to the user ID. With these annotations in place, we can now add our accessors. So we'll add those, navigate to the top of our class. Within our application class, we're going to run a demonstration that has 2 accounts and 2 users, and we're going to associate all of these objects together. So you see that I have created helper methods to create the accounts and create the users, and if we take a look at those, you'll see the create user method actually calls other helper methods because we need to fulfill those objects because the user has associations to those entities. You'll see a hierarchy of calls to these helper methods to help us build our user. So what we're going to do is we're going to add both of these users to the accounts. To the first account, our first user, and then our second user. Now we're going to get our second account, get the users, add our first user, get the users, and finally add our second user. Save account 2. So we're putting what we need to establish that many-to-many relationship in place. And then I have some debug code here. And what this does is it simply pulls our first account from the database and then iterates through the set using the iterator. It grabs the email address and prints it just to show that we can grab that information. One note, using the set is a little bit awkward here because a set doesn't have a get method like a list does. So you have to use the iterator, you're forced to use it. So it's really not nice for these examples, but I wanted to show you a different collection. So let's run this example. And you see that we have inserted into the account, then we put into finances users, we insert into the account again, and then we insert 2 more records into the user account, then 2 more into user address, and then 2 more into user account. So if we go to the database, we can make sure that everything is working properly by querying our user account table. There we see 4 associations made, so 1 for each user to the other account. And it looks like we persisted everything correctly, and our many-to-many unidirectional relationship was a success. So let's just head back to look at this mapping. You'll see that we use the many-to-many annotation in combination with the join table to specify the unidirectional many-to-many mapping. This lesson will teach us to map a bidirectional many-to-many association. Looking at our account entity, we see there is a set of users, and that field has our many-to-many annotations on it. It also has the join table annotation, which makes it our owning entity. What we're going to do in this lesson is move over to the non-owning entity, user, and we're going to establish an association back to account, essentially establishing the inverse association, making the relationship bidirectional. Creating this association is very similar to mapping the inverse in a one-to-many. We need a field, and that field is going to be a set, and the set is going to contain accounts. So that will be our field name, and then we're going to implement a hash set, and its generic type will be account, and we'll call the constructor. So we'll import the set, and now we need to add the many-to-many annotation. On that many-to-many annotation, the first thing we're going to do is specify the cascade type, and it's going to be cascade type all. So we'll import that. And we're also going to specify the mapped by attribute. And this just says what field on the owning entity maps this relationship. So we head back to account, and we see that that field with all those many-to-many annotations on it is users. So we'll grab that field name and we'll paste that into the value for our mapped by attribute. So at this point, we have our mapping in place. We just need to add some accessors. We'll use our shortcut in Eclipse, which is Alt-Shift-S, then R, and we select the accounts field, and we generate our accessors. Format the class and navigate back to the top. At this point, we're ready to run a demonstration. So let's head over to the application class. And here you see that we have 2 accounts, we're creating 2 users, and then we're adding those users to account 1 and account 2. That's establishing the relationship from account to user, but you need to ask yourself, what do we do when we have a bidirectional mapping? The answer is we need to manage both sides of the relationship. If you do not do this, you will hit errors. The first thing we'll need to do is grab our user, we'll get the accounts, and we're going to add the first account, and then we're going to grab user 2, get the accounts, and add the second account. Okay, so we need to manage the association to account 2 from our users. So grab the user, and we'll get the accounts, add account 2. One more time, putting account 2 in place. Okay, so having made these changes, we will save the application, and then we're going to uncomment some debug logic here. This just simply reaches in, grabs a user from the database, pulls it back through the session, and then we just test out our inverse association by grabbing the accounts from the user and spitting out an account name to the console. Let's run this test. We inserted into the finances user, into the accounts, and we did that again for the second user and the second account. We threw the 2 addresses into the database, as well as established the links within our join table, the user account table, so we established that association there. I'm not going to look at the database. Those records are there. We do see that we get the savings account then, so we got our debug output going out from that inverse association that we mapped. We'll go back and we'll just take a quick look at this association one more time. This is the inverse association in a bidirectional many-to-many relationship. And the main thing we need to remember to do is specify that mapped by attribute. Very similar to a one-to-many bidirectional relationship. There are 3 major pillars that make up a working Hibernate application. The first is our Hibernate configuration. The second is our mapping metadata on our entities. And the final pillar is invoking persistence operations. That's what this chapter is all about, learning to use the Hibernate API to perform the operations that will persist our entity state into a relational database. So let's discuss some of the contents of this chapter and our chapter objectives. The Hibernate API is known as a Persistence Manager API. It allows us to invoke methods that will perform things like the basic CRUD operations or execute queries against the database, or to control the persistence context and manage transactions. So it allows us to do all these different things, and we invoke all these methods on these interfaces within that API. And it's pretty much how we control persistence. That's the point of a persistence manager. Within Hibernate, the main interface we'll be looking at is the session interface. And that's going to provide us with a bunch of methods that can allow us to perform those database operations, such as your updates, your selects, your inserts. But it's also going to allow us to manage the persistence lifecycle. And the persistence lifecycle is the different states our entities transition into and out of. And depending upon where they sit within that life cycle, will determine whether or not we can sync their state with the database. During this chapter, we'll learn about that life cycle and its interaction with the Hibernate API and the interfaces within it, particularly the session interface. And that's our final objective, to learn those interfaces. So to learn that session interface, to learn about transactions, and to work with them in order to perform the CRUD operations our application needs. So, what are some important things we need to know for this chapter? We are focusing mainly on the Hibernate session and some of the other interfaces within the Hibernate API. And that would be opposed to the JPA Entity Manager. What you'll find is that the session contains all of these methods, such as get, load, save, update, and it has counterpart methods on the JPA Entity Manager. So the Entity Manager is going to have things like persist, merge. Well, in this lesson, we're going to focus only on those methods that are specific to Hibernate. Through much of our course, we have kind of intertwined our JPA and Hibernate topics because they are so closely related and used so interchangeably. But for this chapter, we really need to divide out these methods and learn them separately. We will be focusing on the Hibernate specific methods. Another thing you need to know is that there is going to be a populate.sql file that is provided with most of our lessons. And during these lessons, you'll hear me say to run this file against your database. So just copy the contents and put it into an editor within MySQL and run it as a script. What this file will do is it will truncate all of your tables, so you will lose all data. That's a forewarning. But then it will insert a few records into the bank table that we can work against. And this is just to ensure that your database is in sync with mine. So if I run a demonstration and you run the same demonstration, you don't wind up receiving like no records found for a particular get if we retrieve some records from the database. So this is an exciting chapter, and let's dig in. When working with the Hibernate API, we're going to invoke a bunch of methods on different entities. And when we invoke those methods, those entities are going to transition into different states. The methods and states that an entity are in make up the persistence lifecycle. So in order to understand the Hibernate API, we need to have a good grasp on this lifecycle and what it means when we invoke a particular operation. That's what this lesson is all about, learning about this lifecycle and what the operations we're performing actually do. So let's move on to just take a look at these life cycles. I want to start by just kind of drawing an analogy. And this is basically how we get and spend money. On the left side of our screen, we see that we have some money, and that's money we've earned. So we could say that is an earned state. And if we deposit that money, we can say that money is saved, and we deposit that into an account. Then if we were to purchase something, we would say the money has been spent. Or if we were to withdraw the money, we would say it's available for our use. Let's take a look at what really composes that life cycle. First, we have states, so earned, saved, available, spent. Those are the different states that our money can be in. And how does it get to those different states? Well, we invoke an action. So when we deposit money that's in the earned state, it then becomes saved money. So we perform those different actions to transition into another state. And the things that we perform the actions on are our objects. You can see that also depending upon whether the money is in the account or outside of the account, it has an impact on our state. For example, we can't have money that's spent that was not in the account. We're assuming that all the money is spent from the account. So that account, although it's not the object we're controlling the state upon, it does impact our other states. So what does all this mean? Well, we're just trying to take a look at a life cycle so you have a real life example to apply to JPA and Hibernate and entities and these different operations we're going to invoke. So let's just move on and we'll take a look at Hibernate's life cycle. And it's a lot simpler. I haven't put all the operations on here because there'd be too many to list. But basically with Hibernate and our persistence life cycle, we have a transient state, or sometimes called a new state. And then we also have a detached state. And you'll notice those two are outside of our persistence context box. So anytime we're in those two states, we're saying that we're not dealing with entities that are in the persistence context. When we have entities that are contained within it, we have two other states, persistent and removed. So we're going to take a look at all these states and see how invoking a method on the Hibernate API actually transitions our entities from one state to another. So at this point, let's take a break from this lesson and we'll pick it up in the next video. Let's pick this lesson up where we left off in our last video. We were talking about life cycles and how they are composed of objects, states, and actions that we perform. We're going to take a look at the entity states and discuss what states can be contained within that persistence lifecycle. The first one we mention is the transient state, and that's when we create a new object using the new operator and a constructor. And at that point, the object does not have any identity within the database. It's not associated with a row. There's no primary key assigned to it. And if we were actually to run garbage collection in our application, and that object was not referenced by anything, it would be lost, and we wouldn't have that state retained. It would not be stored in secondary storage anywhere. The second state we talk about is the persistent state. And this is when that entity has an associated database row, it has a primary key associated with it, and once it's in that state, we can perform all sorts of manipulation on that entity. And that manipulation on the entity, such as setting different fields, will be tracked, and its state can then be sent to the database and recorded there. Now, in order to get an object into the persistent state, we have three ways of doing that. First, we can save a transient object and make it persistent. We can also query our database to pull back an object, and it will be considered persistent. Or we can refer to a transient object from another persistent object. So maybe we could add a transient object to a collection contained within an object that's in the persistent state. Another state we have is the removed state, and that's when an object is scheduled to be deleted. So it is initially in that persistent state, and then we invoke an action on the entity that says we want to remove it from our persistence context. And that remove will get staged, eventually corresponding with a delete operation. And once we sync up our persistence context with the database, that row will get removed. And then finally, we have the detached state. The detached state is what happens when we have an object that is in a persistent state. However, we close the persistence context containing that object. So the persistence context has been closed, but we still have a reference to this object that was once persistent, but is no longer considered in that state. And in that instance, we refer to that state as detached. We've been talking a lot about a persistence context. Let's discuss a little bit more about what it is and what it does for us. The persistence context is one of the objects within the lifecycle that we have to consider. Entities would be the other object, but we have a pretty clear idea of what they are right now. So a persistence context pretty much provides us with a cache for all of the entities. When we put entities into a persistent state, all of the changes made to those entities are held within the persistence context. Now, a persistence context is usually created with a session. So here we see that we invoke the open session operation, and at that point we would get a new persistence context. Then we begin to invoke these different operations from the Hibernate API on our entities. Maybe we build a new object with the new operator and the constructor, and then we invoke the save method on that object. Well, at that point, that object gets placed into our persistence context. Or now maybe we query for some objects from the database. Hibernate goes, fetches some rows in the database, changes them into objects, and now those objects are stored within the persistence context. And if we make changes to them, the persistence context will be aware of those changes. And it is able to perform all these operations that basically synchronize our object model with the database model. So how do we control the synchronization of our object model with the database model, Or how do we control whether we transition an entity from one state to another? Well, to do that, we use a persistence manager. And in this case, it is our session. We invoke those operations on the session that will manipulate our persistence context and the entities stored within it. So let's take a look at the Hibernate API and some of the actions that we can perform using it. Well, our actions basically equate to methods on the API. And as I mentioned before, they allow us to perform the different state changes. So here we see if there is an initial state and it's none. So this is when we're actually just pulling an object from the database. We would use the get or load method, or we'd invoke that action. And the end state of those entities returned by get or load, which queries entities from the database, would be persistent. We also see that we can take a transient entity and make it persistent by calling the save or update methods from the Hibernate API. We can remove persistent entities from the persistence context by calling the delete method, and then they will move to that removed state. We can also take detached entities. So if the persistence context has been closed for an entity and we still have that reference to it, we can reattach that entity by calling the update or save or update methods, and that will make that entity persistent. We can also evict entities from the persistence context. So we have an entity that is contained within the persistence context, so it has a state of persistent. We invoke the evict method on the entity, and the entity is subsequently in the detached state. These are the main methods on the Hibernate API that we'll be working with. And we're going to explore each of these methods in detail and look at how they impact our synchronization with the database, and then how they modify an entity's state within the lifecycle. Let's take a quick look at a code example. Here we see that we create a bank object, we create an instance of a bank, and then I just have that comment there. We set all the properties on the bank. We open a session using our Hibernate util and calling the open session method. At that point, we are opening our first persistence context. And then we're going to start a transaction. Then we're going to save the bank instance. So at first, when we called the new operator in the constructor, the bank was transient. Now we're going to invoke that save operation on the bank entity, and we're going to make it persistent. And then we're going to commit our transaction, which will cause our persistence context to synchronize with the database. So all of our changes will be flushed out to the database, and we'll have that new bank record. And then we are actually going to close our session, and that closes our persistence context. Now, at this point, the bank entity is detached. We can now open another session. So we do the same thing. We use our factory and we open a session, and we have created a new persistence context. And then I'm actually deleting that bank instance, which will cause it to be removed. Now, remember, it's still in that detached state. This is something Hibernate will allow you to do. JPA will frown upon this. But here we have placed bank into that removed state. And then we simply commit our transaction and we close our second persistence context. So this is just a nice example to show each of the states and some of the actions that can make those transitions between our entity states. We'll see the lifecycle appear in much of our work with the Hibernate API. In this lesson, we will learn to use the save method on the Hibernate API to transition an entity from the transient state to the persistent state. Now, this will subsequently cause the entity to be persisted to the database via an insert statement. So we have this example here, and the first thing you see is that we create a session, and that creates a new persistence context. Now we need to create a transient entity. I'm going to make an account, and I actually have a helper method to build an account object. So here it instantiates that new instance of an account and then sets all of the fields. We're also going to build two transactions. So here we're talking about purchases, and I have similar methods built to construct these transactions. There's a belt purchase and a shoe purchase. And now we're going to get the transactions on the account, and we will add the first transaction as well as the second. Now, just for debugging purposes, what I'm going to do is actually print out whether the session contains each of these entities. So does the session contain the account? Does it also contain the first and second transactions? So we have our entity being created and some fields being set, and then we print out some debugging information. The next thing we need to do is create an actual Hibernate transaction, and we do that using the session, and we call the begin transaction method. We'll need to fully qualify that type since we have two objects named transaction. On our transaction, we're going to eventually commit everything, and that's after we call the save operation on the account. Now, one thing we should know about account is that the transactions field has been set up so that the save operation will cascade to the transactions that are associated with the account. And since we're saving our entity, what I'd like to do is now print our debugging information after that save so we can see if our objects get transitioned over to that persistent state. So here we're starting in a transient state. We're calling the save operation, and we should be moving into a persistent state. These objects should now be managed by the persistence context. Let's run the demonstration. So we'll save the application. At first, those three objects were not associated with the persistence context, and then we perform our save operation, and then once we check, they are now contained within our persistence context and associated with our session. We can also go to our database, and we see that our account has been stored. It was a savings account, and we have $50 initially. This was Hibernate's save method on its API, and it is how we transition a transient entity into a persistent entity. In this lesson, we will use two methods on the Hibernate API to retrieve entity instances from the database. What we're going to be doing is pulling back some entities that maybe we persisted at another time. So they are not part of our persistence context yet, but we're going to use the Hibernate API to pull them out of the database and cause them to become entities in a persistent state within our persistence context. To get started, we're going to head over to our database. We're going to run the populate.sql file, and this file will actually truncate all of our database tables, and then it will insert some records into the bank table. This will allow us to work with the same database. You'll be able to find the populate.sql file within the working files for this chapter. I'm just going to run that script, and our database has pretty much been synced. And now we're going to begin working with the different methods on the Hibernate API. Now let's run our first demonstration using the get method. You see we have began a transaction after we've opened a session. And when we opened a session, we created a persistence context. Now we're going to retrieve some saved entities from the database. So Hibernate will read the records, translate the records into objects, and then insert those objects into our persistence context with a persistent state. In order to do that, we're going to first create a variable of type bank, and we'll name it bank. And then I'm going to call Hibernate's get method on the session. This method takes two arguments. The first one is the class of the entity we would like to retrieve, so that's bank. And then the second argument is the identifier for that entity that we would like to retrieve. So I'm going to retrieve the bank entity with the ID of 1. When using the get method, we need to cast to the type of our entity. I'm also going to put a little debugging in place, and I'm just going to say method executed so we can see when our method has been called. And then I'm also going to print out the bank name. Okay, so let's run this simple example. Hibernate issues a select statement. We get our debug output that the method has been executed, and then it says the name of the bank. So let's look at another characteristic of the get method. What I'm going to do is supply an identifier that does not exist within our database. And what will happen here is that the get method will return a null reference. And then when we try to reference the name property on bank, we're going to get a null pointer exception because bank is null. So we'll just run through that demonstration. And there we see the null pointer exception being thrown. Another thing I'd like to point out about the get method is that it will reference Hibernate's cache. So what I'm going to do now is try to retrieve the bank with the ID of 1. You see I'm actually performing that operation twice. And when we see Hibernate's output, we see that only one select statement was issued. So what happened here? The first time Hibernate issues the select statement, it puts the entity into the persistence context, and then we operate our second call to get. Well, instead of going back to the database, Hibernate consults its persistence context before issuing the database command. It finds that we have a bank entity with the same identifier, and then it simply returns that entity from its persistence context. So it keeps us from issuing an unnecessary database call. Now let's take a look at our second method, the load method. It's pretty similar to the get method. We specify the type of the entity as well as the value of the identifier. Here we see the load method being called, and we retrieve a bank entity with the ID of 1. And then we'll just print out our debug statement, and then we will print out the bank name. So let's save our application and run this example. Looking at our output, you should notice something different. When we used the get method, we issued the select statement, then we printed out method executed, and then we printed out our bank name. Well, what has happened is we've actually printed out the method executed debug statement, and then we ran our select, and then we printed out our bank name. So what's going on here? Well, when we use the load method, Hibernate always attempts to return a proxy. So a proxy just kind of stands in place of the actual entity. And then once we actually need to reference something on the entity, say the name of the bank, like we do in our printout statement, then we will perform the select statement to grab the object from the database, and then we can reference that name field upon the entity. So it tries to delay the actual execution of the database operation as much as possible. One of the questions you may have is, why is this valuable? You think you would always want to pull back an entity and then work with its fields or adjust some of its state. Well, sometimes you don't really want to do that. For example, if you have one entity that has an association to another entity, and you just want to establish that association, well, you can use the load method to load that entity and then set the field on that other entity, and you would actually never have to issue a select statement to the database. So you can achieve some performance gains there. Another difference with the load method is that if we query for an object that does not exist within our database, so if there is no bank entity with the ID 123, we will then throw an object not found exception when we attempt to reference a field on that object, or we attempt to use that object in some way, shape, or form. So I will save our application and we'll run it. There we see we get our debug statement method executed, and then once Hibernate attempts to run that query, we get object not found exception. So that's different from the get method, where we would actually receive a null reference once we executed the query. So these are two methods that you can use to retrieve persistent objects from a database using Hibernate's API. In this lesson, we will focus on persisting changes that we have made to a persistent entity. When we retrieve an entity from the database, it comes back in a persistent state, and we may want to make some changes to that entity. So maybe we change some fields, and then we want to save those state changes to our database. That's our goal for this lesson, and that's what we're going to learn how to do. So looking at our example, we have the session, so that's going to open a persistence context, and then we start our transaction, and now we're going to pull back a bank entity from the session. I'll use the get method, and I'm going to get the entity with the ID of 1. Now we're just going to make some changes to the bank entity. So I'm going to set the name of the bank to New Hope Bank. We'll also set the last updated by field to Kevin Bowersox, and we'll also change the last updated date. Okay, so we have those changes in place. Hibernate will track those changes to the entity, and when we commit our transaction, which we have opened in line 22, those changes will be updated on that entity. So let's just go through and run this application. And there we see, first Hibernate issues our select statement, so we retrieve the entity and put it into a persistent state. Then we modify some fields on the entity, and then once we call commit, Hibernate realizes that changes have been made to the entity, and it is no longer in sync with the database. So then Hibernate issues an update statement to sync up the object model changes with the database. Now we can head to our database. We will run a select statement. And here we see that the bank with the ID of 1 is now New Hope Bank. And we have persisted the changes from our entity to our database. So it's as simple as that when you want to make some modifications to an entity that is in a persistent state. You just retrieve it, make your changes, and then commit your changes through the transaction. The important part being all of this is done within a transaction. This lesson will focus on the delete method on the Hibernate API. When we invoke the delete method and pass in an entity, Hibernate will change the entity's state to removed, which removes the entity from the persistence context, and then the entity will be subsequently removed from the database when we commit our transaction or flush our session. To begin, we're going to sync up our data model. So we're just going to run the populate script, and this will truncate all of our tables and insert some data into the bank table. We can then select some records from the bank table, and this is what you should see in your database. Now we're going to work on deleting some of these records by using the remove method on the Hibernate API. So let's get started. The first thing you'll notice is that we open a new session, and this will create a new persistence context. Once we have opened our session, we then create a transaction. Within this transaction, we will perform all of our work. The first thing we'll need to do is grab an entity from the database. We're going to use the session.get method, and we're going to supply the class as well as the value of the identifier, and then we're going to cast the bank entity. So at this point, this entity would be in the persistent state. What we want to do is take the session and invoke the delete operation, and we pass in our entity to the delete method. Just to show some of the internals of Hibernate, I'm going to print out method invoked. So after we delete our bank entity, we're going to log some output to the console, and we're also going to show that the session at one point contained the bank entity, and then at another point, it no longer contains the bank entity. Here we have the basics of performing a delete. And this will cause the entity to move from the persistent state into the removed state. So let's go ahead and run this example. Let's see our output. So first we see this select, and that's because we invoked the get operation. And then we see that the entity is part of the session, so it's within the persistence context. And then you'll notice that we have invoked the delete method. However, we do not see the delete operation being invoked at this time, so it's not sending a delete operation to the database. Then we move on to our debugging output that says the bank entity is no longer part of the session. However, it still hasn't been removed from the database. Finally, once we commit our transaction, then Hibernate syncs up the entity model and data model, and we actually issue the delete statement to the database. And we also see that Hibernate is deleting a bank contact record as well as the bank record. So there must have been an association there that we had to destroy before we could delete the bank record. Let's return to our application, and I just want to make one more quick point. Once we have deleted the bank entity, we should no longer be working with that entity within our code. The entity has been removed and it no longer has an identity within the database. So once you have removed that bank object, it's best to let garbage collection kick in and basically remove that object from your application. In this lesson, we will use the update method on the Hibernate API to reattach a detached entity to a persistence context. We're going to head to our database, and we're going to execute our populate script, and then we'll just make sure that all of our banks have been inserted into the database. So we have these 4 bank records. We'll be working with one of those during our example. Looking at what we have, we create a session, so that's creating a new persistence context, and then we load a bank entity into the persistence context. So now it has a persistent state. And then we close our session, also closing the persistence context. At this point, our bank entity is detached. It is not attached to any persistence context. We then create a new session, creating another persistence context. Within this new transaction for this persistence context, we're going to work with our bank entity and we're going to reattach it to our second session. Just to demonstrate, I'm going to point out that the bank entity is currently not contained within our second session or persistence context. And then what we're going to do is call the update method on the second session, and we're going to pass in the bank entity. And this will cause that entity to be reattached to the persistence context, causing it to go from a detached state to a persistent state. So I'm just going to print out that we have invoked our method, and then we're also going to see whether that entity is now attached. What I'm also going to do is set one of the fields on the bank entity after we have reattached it. So I'll set the name of the bank to test bank. What will happen is Hibernate just automatically assumes that when we reattach an entity, that it has been dirtied. So in other words, that one of its fields have been set. Hibernate will always perform an update statement when we invoke the update operation to reattach a detached entity to a session. So let's see this in action. We issue our select statement to retrieve the entity during our first session, and then we check to see whether or not that entity is attached to our second session. We see that in line 29, and we get a printout of false, so we know it's not attached at that point. Then we see that we have invoked our update method, and once we check to see whether it's attached now, we get a true response, meaning it is attached. And then finally, when we commit our transaction, Hibernate will sync our entity model and our database, issuing that update statement that we've talked about. So this example showed you how to reattach a detached entity to a persistence context. an update statement is subsequently fired to the database to ensure that if the entity were dirtied, meaning it has a different state or some of the fields have been changed, the database is synced with that new state. In this lesson, we will introduce a flexible method on the Hibernate API that is capable of either persisting a transient entity or reattaching a detached entity. The first thing we'll need to do is run our populate.sql script, which can be found within our working files for this lesson. Run that script on the database so we're both working with the same records in our underlying database. Once we had that script ran, we're going to take a look at our example. And here we see the basic script for a detached entity. We have opened a persistence context, and we have retrieved a bank entity, and then we close our persistence context when we close our session. Now our bank entity is detached. You'll also notice that we have a transient bank entity. So this is a new entity that was created using the new operator and the constructor. Here we see that helper method, and we see it's invoking the constructor for bank, so we get a new instance. So at this point, we have a detached entity and a transient entity. And what we're going to see is a method that is flexible enough to handle both of these situations. What I'm going to do is on our detached bank, I'm going to set the name. What I'll do then is use our second session. So here we have a new persistence context, and I'm going to call the save or update method. The name is pretty intuitive because when we save an entity, we are making it persistent, so we're firing off an insert statement to the database. But we also have the option to update, and when we update, we're reattaching an entity to our persistence context, and we're making it persistent, so we fire off an update statement. The first thing I'll do is pass in the transient bank entity, and then the second thing I will do is pass in the detached bank entity. And when we execute this demonstration, we see that the same method is capable of performing an insert or an update. So how did that work? Well, Hibernate looks at the identifier properties for the entity, and using either the presence or lack of an identifier, the API is smart enough to route the method invocation to the appropriate method, save or update. Pretty simple, but it's a nice method to know about because it provides some flexibility that you can incorporate into your application. In this lesson, we will discuss the flush method on the Hibernate API. We find the flush method on the session interface. And when we call flush, what we're telling Hibernate is to take all of the changes within our persistence context and sync them with our underlying database. In order to understand flush, we need to take a look at another interface used by Hibernate, the transaction interface. When working in Hibernate, we create a session, and when we create that session, we know that a persistence context is also created. Within that persistence context, we keep track of all of our changes to entities. Well, when we want to write those entities to the database, we need a connection, and a transaction houses that connection. One of the interesting things about a transaction is that we try to perform all the work as one atomic unit. So all of those changes that we make to the persistence context need to be persisted to the database in one fell swoop. If one of the operations that we have performed fails, let's say we have two inserts and one update, if one of the inserts fails, we need to roll back everything. And that's the whole point of a transaction. So anytime we are working with a session, we are also building a transaction. When we work with a transaction, one of the ways we cause all of the changes to be made on the database, so when we sync up our persistence context with the database, when we're performing our updates, our inserts, our deletes, one of the ways we do that is by calling the commit method on our transaction. Well, what is happening underneath the covers is this commit is forcing a flush on the session. There are 3 times when a flush will be called on the session. First, if we were to call flush explicitly. Second is when a commit is called on a transaction. And third, sometimes when we run a select operation, a flush will occur before it. So we're just going to run a quick demonstration to show how flush behaves when we have multiple changes within our persistence context. First, be sure that you have ran the populate.sql file against your database so that we are working with a similar database. We're going to retrieve an entity from our database, and it's going to be a bank entity. So I'll use the get method, we'll specify the class, and we'll provide the ID. So we return this bank instance. It's now persistent within our persistence context, and we're just going to make a change. So we're going to set the name to something different. You'll notice now we're going to call the flush operation, and I'm just going to put some debugging in here. So we are now calling flush. And then we're also going to set the first address line, another address line, and then put some debugging output that says we are calling commit. So we're making 2 changes to our bank entity. After making one change, we call flush, and then we make another change, and then we invoke the commit operation on the transaction. Now, another thing that's important to do is to make sure if there are any exceptions that you roll back the transaction. So for instance, if our first flush causes some database constraint violation, or let's say it's a unique constraint violation, we don't want to proceed and execute the next flush when we commit the transaction. We want all of those changes to be rolled back. By specifying transaction.rollback within our catch block, we would essentially roll back any changes that have been posted to the database when our persistence context is attempted to be synchronized. Let's just run through this example. And here we see that we select our bank entity from the database, and then we call flush. And when we call flush, we see that we update with that first change. Then we move on and we have set another field on the bank entity, and then we call commit. Another update is ran on the database to synchronize it with the persistence context. Now, if we did not invoke that flush operation manually, so I'm talking about line 25, what we would have seen is both of our changes would have just been made when we had committed. So this is just showing how you can use flush to force your persistence context to be synchronized with the underlying database. This chapter will teach us to work with JPA to invoke persistence methods against our entities. Just like the Hibernate session was used to trigger different state transitions on our entities and to invoke different persistence operations against our entities, the JPA API has similar interfaces that we use to interact with our entities. So let's take a look at our chapter objectives. The first objective is pretty simple. We want to learn how to configure a JPA application. There are some things that we have to do differently than a regular Hibernate application. The main thing is a persistence.xml file, which is a configuration file that we will put in place. So we will learn how to build that file and where to place it, and all of the different properties that we can specify within that file. JPA has a bunch of different interfaces that we work with to perform different persistence operations. So we're going to learn those interfaces and how to interact with them in order to perform persistence. And our third objective is pretty simple. We're going to learn how to perform CRUD operations and use transactions to basically write the state of our entities to the database. And then finally, we're going to take a look at the similarities and differences between the session and entity manager. So we know the session is associated with Hibernate, and the entity manager is established with the JPA standard. So there are some commonalities between these two, and there's some differences. So we just want to be able to distinguish between them and especially know when we're using the appropriate method on each one. So what I've done is I have listed all of the different methods on the entity manager and on the session. These aren't all the methods, but they're some of the most important ones, and these are the methods that kind of correlate. So we see the save method on the session is correlated with the persist method on the entity manager. And since we know the save method on the session will take a transient entity and make it persistent, as well as fire off that insert statement to the database, we can assume that the persist method is going to perform very similarly. You'll also notice that some of these methods are the same. So we have merge on both the session and the entity manager, as well as flush is contained on both the session and the entity manager. So hopefully this table just kind of gives you a little bit of a way to relate some of the things we know about session, and you can imply some different things about the entity manager. Okay, so what are the important things we need to know when working through the lessons in this chapter? As we know, JPA is a subset of Hibernate. JPA is a standard that the Java community has developed. It is actually a subset of Hibernate, so Hibernate has more functionality, but it does not all adhere to that standard. You're going to hear me kind of use JPA and Hibernate interchangeably because Hibernate is our underlying JPA implementation. I'm referring to the underlying JPA implementation when I'm discussing Hibernate throughout this chapter. Another important thing to keep in mind is that the persistence lifecycle applies to JPA. So, Hibernate has a persistence lifecycle, and that same persistence lifecycle is in effect for JPA. So, when you have a transient entity in Hibernate, it is a transient entity in JPA, and the same goes with all of our transitions to the different states, such as persistent and detached and removed. So, they're all in play here. When we use JPA, we have an entity manager. I've alluded to that, and we'll learn more about it during this chapter. But those entity managers can be either application managed or container managed. And in this chapter, we're only looking at application managed entity managers. So you say, well, what does that mean? Well, when we have an application managed entity manager, it means we are responsible for creating that entity manager and destroying that entity manager. Now, if we were using a container managed entity manager, we would be working in a full-blown Java EE environment. So we're going to have a full-blown application server. So we're not talking Tomcat. We'd be talking something like JBoss or, Oracle's WebLogic. And that would actually provide us with some different things. First, it would allow us to inject our entity manager via dependency injection, and it would also perform our transaction management so we could declaratively manage transactions. But in this chapter, we're going to focus on the application managed entity manager, and we're going to focus on resource local transactions. And that means we will determine when a transaction begins and ends. Okay, and finally, there is a populate.sql file, and you should run that prior to each of our lessons. This will sync up our databases, and then we'll be on the same page. So if I query for a record with an ID of 1, you will also query for a record with the ID of 1, and you will find it within your database. It just syncs us up. All right, this is going to be a great chapter. I'm ready to begin. In this lesson, we will learn how to configure a JPA application. So looking at our application class, I have created a small example of using JPA. This example creates an entity manager factory, and then retrieves an entity manager, which is kind of like a session, and then it persists a new instance of a bank entity into our database. So right now, this application does not have any configuration. So that's what we're going to learn how to put in place within this lesson. When working with Hibernate and JPA, you'll need to add a new dependency to your pom.xml file. So we'll open that file and go to the Dependencies tab and then click the Add button. And we're going to look for the Hibernate Entity Manager. Now, when you select this dependency, be sure to select the org.hibernate group ID as opposed to just the Hibernate group ID. You'll notice the version is 3.4 for this dependency, whereas it is 4.37 for the dependency with the group ID of org.hibernate. We want the latest version, so we'll select that, save our POM file, and now we can close it. Okay, so our next piece of configuration is the persistence.xml file. And this is a configuration file that will tell JPA and the underlying persistence provider how to do certain things. So how to connect to the database, and we can also specify some properties that will determine different behavior within this configuration file. So by default, the persistence.xml file is located within a folder named meta-inf. And this folder must reside at the base of the class path. So I'm going to put it within our source main resources source directory, and we'll create that folder. And then within that folder, we're going to create an XML file. And we will name this file persistence.xml. Okay, so here is our new XML file. And the first thing we'll do is delete the XML line. And now we need to provide our configuration for JPA. All of our configuration must be within a persistence tag. That's the root tag for this file. That tag will also specify an XML namespace. And if you're familiar with those, you know they're not something you remember. So what I have done is I've went out and found JSR 338, and that is the specification for JPA 2.1. And I'm just going to copy that root persistence tag from the specification. So we'll go back over to our persistence.xml file, and we'll paste that XML snippet. And I'm just going to arrange this a little bit. Now, within this tag, the first thing we need is a persistence unit tag. And here we define the name of our persistence unit. So I'm going to name ours Infinite Finances. And we'll add some space there so we can put some other tags within here. And the first tag we'll need now is the provider tag. And this specifies the class that is going to provide our entity managers. So this is a Hibernate class that we need to specify since Hibernate is our underlying persistence provider. The class is org.hibernate.ejb.hibernate persistence. Okay, so that takes care of our provider. And now we're going to specify our properties that will instruct our persistence provider, which is Hibernate, how to connect to our database. So the first property is javux.persistence.jdbc.user. And so this is simply our username, and that's going to be infinite. Okay, now we're going to add 3 more properties that are very similar to the last one. The second will be the password, the third will be the URL, and the fourth will be the driver. So our password is going to be skills. Our URL is always the protocol, followed by the server name, and then the port, and then the schema name. And now we need to specify our driver name. Those properties will tell JPA, or our underlying persistence provider Hibernate, how to connect to the database. What you need to remember is that JPA is just the specification, and we're using Hibernate as our persistence provider. So it does all of the work. It adheres to the JPA specification, and it actually does our persistence. The specification acts more like an interface, and Hibernate would be an implementation of that interface. So we're also going to specify some Hibernate specific properties. You'll notice all of our properties up above use javax.persistence.jdbc.url. Well, that is common across any persistence provider that implements the JPA interface. So if we were using something like Eclipse link, it would be the same property names to specify those particular properties. But now we're going to use some Hibernate specific ones. The first is our dialect, and we're going to specify a value of org.hibernate.dialect.mysql inno dialect. And that tells Hibernate which version of MySQL we're using and the underlying database engine we're using. Our final property is hibernate.showSQL, and we're just going to set that to true. So hopefully I don't have any spelling errors within this configuration, but that does complete our configuration of the persistence.xml file and our JPA application. Now, one thing you'll notice is that I have not specified each individual entity within this file like I did in the hibernate.cfg.xml file, and that's because we no longer need to do that with JPA. Once our entity manager factory is built, it will go and scan our class path for any classes that are annotated with entity. So we don't need to explicitly provide those classes to our persistence provider. They are detected. That's one nice feature of JPA. So let's head over to our application and let's run through and see if our configuration works. So there we see that we inserted one bank entity into the database. So that's great. That was our first JPA application. In this lesson, we will learn how to save a new entity using the JPA API. One of the most basic tasks we can perform when using any persistence provider is creating a new object and saving that object into the database. With Hibernate, we used the save method on the session class that was within the Hibernate API, and that was able to insert a transient entity into the database and make it transition into that persistent state. So now we're going to see the same operation with JPA. So let's put the code in place for this demonstration. The first thing we will need is an entity manager factory, and I'm just going to name it factory, and we'll set it to null. You can think of the entity manager factory much like the session factory. So the session factory creates sessions, and the entity manager factory creates entity managers. And I'll just name that EM, and we'll set that to null. The entity manager is much like the session. We can use the entity manager to invoke persistence operations, such as inserts, updates, deletes, on our entities. We can also use it to retrieve our entities from the database. And when we invoke these operations, we're also transitioning the states of our entities. So it's very similar to the session. You're just going to see methods with different names on each of these interfaces. The next thing we'll need to create is an entity transaction. And this is very similar to the transaction interface in Hibernate. We see this a lot. There are many interfaces within the Hibernate API that have a corresponding interface within the JPA API. And a lot of this is because Hibernate had a very big influence on JPA. So now that we have those objects in place and we've declared those variables, we're going to create a try catch block, and I'll just generically catch any exception, and then we need to add a finally block. Okay, so what's the first thing we need to do now? Well, we got to get that factory. So we're going to use the persistence class, and it has a static method named createEntityManagerFactory. And all we need to do is supply the name of our persistence unit. So I'm just going to head over to the persistence.xml file, and I'm going to copy the name of our persistence unit. So we put that in place, and we get our factory. And what do we create with our factory? entity managers. And to do that, we just call the create entity manager method. And then with our entity manager, we can get the transaction. And then we begin our transaction. So what do we do after we do our work in our transaction? Well, we commit the transaction. So that will cause our persistence manager to flush all of the changes to the database, and it will synchronize our entity model and our database. And if we were to encounter any errors, we would want to roll back our transaction. And then within our finally block, we always want to close all of our resources so we don't leave any database connections hanging. Okay, so you're looking at pretty much the basic idiom for how to use JPA. Much of the code you'll write using JPA will pretty much be surrounded by this code you see here. Within our transaction, here's where we do our work. So what are we trying to do? We're trying to create a new bank entity, and we want to save that in the database. Well, luckily we have our handy create bank method, which creates a new transient instance of a bank. And then we just need to use our entity manager to save this entity. And the way we do that is we call persist. And this will cause an insert to be fired against the database at some point. Now, because we are using the auto increment option within MySQL, it's going to happen very quickly because we need to get that ID for our entity. When you think of the persist method on the JPA entity manager, think of the save method on the Hibernate session. Very similar in what they do. There are a few slight differences. All right, so with our example in place, let's run the demonstration. And there we see that we have successfully used JPA to insert an entity into the database. Now, you'll notice in our logging it says Hibernate. Well, you got to remember, JPA is kind of like the interface, and then Hibernate implements that interface. So we are using JPA, but we're using the Hibernate JPA implementation. In this lesson, we will explore two methods for retrieving entities using JPA. So prior to running our example, you should execute the populate.sql script against your database. That way we are in sync as we work through our example. So when we're working with any sort of ORM or persistence framework, we always need to return entities from the database. So we are executing a select against the database and having that result set turned into either a list of entities or a single entity. And we're going to look at how we do that with the JPA entity manager. What we're going to return from the database is a bank. We're going to reach in there and grab a bank entity. And to do that with the entity manager, we use the find method. This is very similar to the Hibernate get method. It accepts a class, which should be the type of an entity. So we want the bank class. And then we provide the primary key for the entity that we would like to retrieve. We'll just return the first bank. And then what we can do is we can check that our bank is within the persistence context. So there I'm using the contains method on the entity manager, which is much like Hibernate's contain method. So it just checks to see if an entity is part of the persistence context. We will also print out the bank name. So let's just quickly run through this example. And there we see that we issue a select statement against the database. We get our entity back, and we print out its name, and we see that the entity is part of our persistence context. So much like the get method on session, if we were to provide the ID of an entity that does not exist, we will also get a null pointer exception when using find. So in our console, we see that we looked for an entity with an ID of 12. We could not find that within our database, so it returned a null reference. And then when we tried to access the name field on the bank, then we got a null pointer exception. The next method we'll look at, and it's another way of retrieving an entity, is the getReference method. Very similar to the load method within Hibernate. This method will not return a null reference, but it will throw an object not found exception if the entity does not exist. And that's because Hibernate actually always tries to return a proxy. So when we use find, Hibernate as the JPA persistence manager will always return a null reference. But when we use getReference, it's trying to return a proxy. And then when we try to access a field on that proxy and it's not there, then we're going to get an object not found exception. So let's run through here. We should get an exception using the getReference method. And there we see our entity not found exception. And it says it can't find a bank with the ID of 12. So that's what we expected. Now let's search for one that we know does exist. So we'll go back to 1, and this time we should get our familiar console output. So once Hibernate realized it needed to access a field on that entity, then it went and executed our select query. You'll notice that it was not executed prior to our check that the persistence context contained the actual bank entity. It was only executed once we needed to retrieve a field from that entity. Now, one nice thing about JPA, when we use the getReference or the find method, the methods are generic methods, so we don't have to cast the result of those methods to the type of our entity. So that's one of the advantages of using the JPA standard as opposed to just Hibernate. In this lesson, we will learn to use JPA to modify a persistent entity instance. This demonstration is going to be fairly short because modifying a persistent entity instance within JPA is very similar to Hibernate. The only difference is we're using the different JPA interfaces as opposed to the Hibernate interfaces. So instead of working with a session factory in a session, we're going to work with the entity manager factory and the entity manager. So here you can see that I have grabbed our persistence unit and we use that to create our factory. And then we build an entity manager. So here we are creating our persistence context. We start a transaction and then we search for and find a bank entity with the ID of 1. Now, with that entity stored within the persistence context in that persistent state, all we need to do now is to make some changes to that entity. So I'll just set its name to another demonstration. And with that change in place, Hibernate will recognize that the entity has been dirtied. And then when we commit our transaction, Hibernate will sync our entity model with the database. So we will issue that update statement against the database. So let's just run through this example. And there we see we select the entity from the database. So we're loading it into the persistence context. And then we fire off our update statement because the entity has been dirtied. Pretty simple, almost a mirror of Hibernate, except we are using the JPA interfaces in this case. In this lesson, we will use the JPA Entity Manager to remove an entity from our persistence context. This will cause the entity to then be deleted once our persistence context is synced with our underlying database. So if you remember on the Hibernate API, we had the delete method. Well, in JPA, on the Entity Manager, we have the remove method. And this will cause an entity that is in a persistent state to be transitioned into a removed state. And then once we commit our transaction, a delete operation will be sent to the database to remove the corresponding record within the database for our entity. So you'll see I have called the remove method on the entity manager, and I have passed the bank entity as an argument. And what I'm going to do, just for some debugging, I'm going to call the contains method, and we'll pass in bank. So this will tell us whether or not the entity is part of our persistence context at the time. And then you see I am also calling the contains method after we have removed the entity. So I'm going to save our application. Also, prior to running this example, you'll want to execute the populate.sql script against your database so we have our records in sync. Once that's all in place, we can execute our query and take a look at our console output. Okay, so we see that the find statement is executed, and we get that select issued against the database, so that pulls back an entity and puts it into a persistent state. And that's echoed by calling the contains method on the entity manager and passing in that entity. So it says that this persistence context does contain the bank entity. Then we execute our remove method and we pass in the bank. And at this point, nothing happens. You'll see that we move on to our next contain statement, but we notice that that entity is now in the removed state. So when we call the contains method, we are told that it is no longer part of our persistence context. Once we commit our transaction, we see the deletes occurring. That is syncing our entity model with our database. So it's pretty simple. It's a lot like the delete method on the Hibernate API. Once again, we're just using the entity manager as well as the other interfaces involved with that, the JPA transaction and the entity manager factory. In this lesson, we will learn to merge a detached entity back into a persistence context. In order to merge the entity back into a persistence context, we're going to use the merge method on the entity manager class. But before we do that, let's talk a little bit about how entities get detached. We know that if a persistence context closes, the entities within it automatically become detached. But let's look at some other ways that an entity may become detached. One that I'd like to show you is the clear method contained on the entity manager. If we invoke this method, all entities within the persistence context will become detached. So I can demonstrate this by invoking the contains method on the bank entity, which we have loaded into our persistence context using the find method. So once we execute this statement, we have one bank entity in our persistence context. This clear method will evict that entity from our persistence context, and we should receive false. So there we see that example in place. And remember, the clear operation evicts every entity within the persistence context. If we wanted to be more specific, we can use the detach method. So this will just detach a single entity, and we can take a look at this. And there we see that we have detached just the bank entity, whereas clear would have detached every entity. Okay, so we have this detached entity. Now, how do we reattach it to our persistence context? Well, that is where the merge operation comes in. So I can call merge on the entity manager and pass in the bank. So let's make a quick change to bank. We'll set the name to something else, just some different data to force an update. So what we'll see happen when we execute this is that Hibernate is going to act as the persistence provider. And when we invoke that merge operation on the entity manager, it goes back to Hibernate, invokes Hibernate's merge operation, and it by default tries to look in the persistence context to say, do I already have this entity within the persistence context? If it doesn't, then it's going to query the database to retrieve that entity. If it finds that entity, it's going to overwrite any changes, such as our change to the set name field. it's going to take that change and overwrite it on the entity that it just pulled from the database. Now, if it does not find the entity within the database, then it's basically going to invoke a persist operation, and it's going to treat it like a new entity, make it transient, and we're going to fire off an insert statement to the database. So if the entity exists, it's going to either get it from the persistence context or the database, and then fire off an update to write any changes. If it doesn't exist, we're going to invoke persist and fire off an insert. Now, one thing that you'll notice is that the merge operation returns an entity. So it's going to return an entity of type bank. And that is the entity that is now in the persistent state. So it is now managed by our persistence context. So what we need to be careful not to do is something like this. So I'm going to set the name of the old bank entity, which is detached, something else too. So there you see that I'm setting a field on the detached entity, and that will not get persisted to the database. So when we sync our changes, the database will not get this new something else to name associated with that bank entity. So that entity is detached, and we should not perform any modifications to it that we would like to see happen within our database. We should be working with this bank2 instance from this point on because it is the managed instance within our persistence context. So let's just go ahead and run this example. Okay, the first select statement we see in our console is from our find statement, so we're loading that entity into our persistence context. Then it gets detached. We see the false output when we check to see if it's contained within our persistence context. And then here is that select. Hibernate could not find the bank entity within the persistence context, so it goes to the database and pulls back the entity and loads it. And then we apply our changes to that new entity, and that fires off our update statement, and Hibernate then returns our new instance from the merge method. So one thing that I want to emphasize is that the changes to our detached bank entity, so here this set name call, that did not get persisted. If we head to our database, we can select everything from the bank table, and you'll notice that we only have something else there for the bank record with the bank ID of 1, as opposed to something else 2. So those changes were ignored because that entity was detached. I wanted to take the time to point out the similarities between the JPA Entity Manager and the Hibernate session. On those two interfaces, you'll find methods that are the same. So where we may not have covered a method on the session, we have actually covered it on the Entity Manager, and you can invoke that method on the session and expect the same results. So to illustrate that point, I'm going to actually dig into the Hibernate source code. So if you expand the Maven dependencies folder, you can scroll down to the Entity Manager jar, so Hibernate-Entity Manager, and we'll expand that. And where you find the real meat of the Entity Manager is within this JPA package. There's an SPI package, and then you have the Abstract Entity Manager impl. And if we open that guy up and maximize it, here you'll see many operations that really overlap between the two. So here we are calling persist on the Entity Manager, and within that you see we get an internal session, and that's actually a Hibernate session. And here you see we invoke the persist operation on the Hibernate session. So there is a method persist on Hibernate's session. So you could also use that to persist an entity. Another example of this is the clear method. So this would evict all of the entities from a persistence context. And here we see that once again, we're grabbing a session from Hibernate and we're calling the clear method on that session. Another good example of this is merge. On the session interface, there is a merge method that we can invoke. So once again, they're sharing the same implementation. And flush is another good example of this. Here you see we're calling session on flush. So if you were to call the flush method on the entity manager, it's pretty much going to in turn rely upon the session's implementation of the flush method. Looking at this code, it's a good illustration of how JPA is the specification. So JPA says we need to have something like a merge method, and then in turn, this is the Hibernate implementation. So here we agree with the JPA specification because we are providing an entity manager.merge class. Now, granted, it's within the abstract class, but then you're getting a session and actually having that implementation and invoking it with Hibernate. So a lot of Hibernate's entity manager implementation really relies upon its actual Hibernate core, so the session and all of those interfaces defined within Hibernate. And it's a really good illustration, too, of how JPA is just a subset of Hibernate. Hibernate core would have many more features than its actual Hibernate entity manager implementation. So our upcoming chapter is Advanced Mappings and Configuration. And this chapter consists of an assortment of topics that kind of are outside the norm when we work with Hibernate or JPA. So we're looking at things that you may run across when working with the library. Let's just take a look at some of these things that we're going to cover. So the first one, we're going to take a look at composite keys. We know not every database uses surrogate keys. Some use natural keys, and sometimes in order to make a unique key for a table, we need to use multiple columns. Well, we haven't looked at how to map that within our entities at the moment. So in this chapter, we're going to explore how to map composite keys and how to map associations that rely upon composite keys. Another thing we're going to take a look at is enumerations. So we know that we can create an enum in Java, and it basically consists of a predefined set of types. Well, it's pretty easy to map them in Hibernate, but we'll find that the default mapping for them isn't sufficient, and we're going to take a look and explore how we can map enumerations better. Next, we'll take a look at inheritance. This is one of my favorite topics. I always like to use polymorphism in my code, and polymorphism creates a bit of an issue when we are using an ORM. There's just not a one-to-one mapping between a database and a Java entity model that uses inheritance. So there's a number of techniques that we can use to try to bridge that gap. So we're going to explore those and see how we can leverage inheritance within our entity model, yet still be able to persist our entities. This is also a great topic, persistence layers. So maybe you've worked on some applications and the code that handles persistence. So maybe there's JDBC code that inserts everything to the database or updates, selects. That code often ends up scattered all over the application. Things are just not organized. Well, I'm going to recommend an approach for organizing your persistence layer and show you how to incorporate Hibernate and JPA into that layer. We're also going to take a look at how you can handle really complex queries. Sometimes we write queries that have some features that we cannot replicate within Hibernate or JPA. So we're going to take a look at how we can leverage native SQL and have it still maintained within that organized persistence layer. And the final thing we'll take a look at is schema generation. A lot of people really like how Hibernate can build out their table structure, and they like to take advantage of that feature. So we'll take a look at how to configure Hibernate to perform auto-generation of our DDL. And there's only one important note for this lesson, and that's that we will need to make some schema changes within our inheritance lessons. And these are very small changes. It's just renaming a column. But I just wanted to point this out. That way you can change the column names back to correspond with whatever approach you're going to be working with. All right, so this is going to be a great chapter. We're going to take a look at some of the more advanced things that we need to do with Hibernate. Sometimes we will encounter a data model that does not use surrogate keys. Instead, it uses natural keys. Now, I'm always an advocate for using surrogates,
Anytime you are creating a new application, I would recommend working with surrogate keys within your data model. However, we don't always have that choice. Sometimes we are handed a legacy application and it uses natural keys. And sometimes, in order to create primary keys for a table, the data model will use compound natural keys. So we're going to have more than one column that comprises the primary key for that table. In this lesson, we're going to learn how to map that situation using annotations. So let's take a quick look at our data model. Here we see a currency table, and as you can see, this table has three fields: name, country name, and symbol. The name and country name columns make up the concatenated primary key. So the name would be the name of the currency, and the country name would be the name of the country. So for example, you can have dollars, and dollars can be both American dollars and Canadian dollars. And the country name helps us distinguish that. And when we concatenate the name column and the country name column, we get a unique primary key. So how would we model that within our entity model? Well, the first thing you'll notice is that we have supplied many of our common annotations, such as the entity annotation, the column annotation, and we've put those in place. Now we need to add some other annotations. The first is we need to look at the entity and determine which two fields are associated with our primary key. So that's name and country name. And then we simply put the ID annotation onto both of those fields. Notice once again, we're using JPA annotations because that is what Hibernate will work off of. And then with these in place, what we're going to do is copy these two fields so that we have them exactly. You don't have to worry about getting all of the annotations. And then we're going to create a new package first. And I'm going to call this entities.ids. And then within that package, add a new class. And we're going to name this class currency ID. So what we're doing is we're building a class to actually hold the two IDs for our currency class. We'll have two fields on this class. Each one will be associated with one of the columns that make up our primary key. So once we have these two fields in place, we can create getter methods for these two fields. So there we see our getters. And it's important that these two fields have their name match the currency field classes exactly. So we have the name field on currency and the country name field on currency. We need to match those identically on the currency ID class. Another thing we'll need to do is generate a constructor for both of these fields because we need a way to set the fields within this class because we've only specified getters. So here we are specifying getters and then a constructor where we can supply values for our two fields. And then we will also need a default constructor since we have provided that constructor that takes all of the fields. And we can clean up our imports at this point. And then one final thing that we need to do is we need to implement the serializable interface. And that's just a marker for JPA when we are using a class to hold an ID. And I'm just going to suppress those warnings. All right. So with that class in place, what we can do is return to our currency class, and now we add an additional annotation to the class level, and that is the ID class annotation. And what we need to specify for that ID class annotation is the class that we just created. So the currency ID.class, and we'll import that class, and now we'll save our entity. So with these annotations in place, we have successfully mapped a concatenated natural primary key. Let's run through a demonstration with this entity. So what I have done is I have built our session factory, grabbed a session, started a transaction, and then we get into the real meat of our demo. I build a currency instance, and then we persist that instance into the database.
And then what we're going to do is we're actually going to pull that instance back from the database through our second session that we're creating. So we will create a new variable with a type of currency, and we'll name it DB currency. And since we're using Hibernate session, we're going to be calling the get method. So we'll need to cast that. And then we supply our currency class because it's the type of our entity. And now here's where that ID class comes in. So we need to specify an ID for the currency class so we can retrieve it. Well, here's where we create an instance of that currency ID class and we use the constructor. So as you can see, the country name for our currency was United States and the currency name was dollar. So I believe the currency name was first and then we specify the country. And we put our semicolon at the end. We'll import the currency ID, see if we can format that. And then let's give ourselves some debug output. So let's print the name of the currency. Okay, so we have our example in place. Let's run through the demonstration. And there we see that we inserted our currency entity into the database, so we made it persistent. And then we open our second session and we executed our select statement. If we inspect that select statement, you'll see that we are using two columns when we issue our where clause. So that where clause has a column for each of our primary keys, which it should because we're executing a query against a table with a concatenated primary key. And then you see that we print out dollar. So let's just take a look at that mapping one more time. We annotate each field with the ID annotation, and then we create a new class that contains fields for each of those IDs that we have specified. The names have to match exactly. And then within our entity, we specify the ID class annotation and point to that new class we've created. And that's it. So this concludes our lesson. Database tables can have a primary key that concatenates multiple columns to form a unique identifier. We know that we can model those compound primary keys or those concatenated primary keys within our entities using the ID class and multiple ID annotations on our fields. But we also know that entities can be associated with other entities. So how do we associate an entity that has a concatenated primary key and the associated mappings with another entity? So how do we create that relationship between those two entities? What I have done for this lesson is I have created a market entity, and a market is something like the stock exchange, so maybe NASDAQ. And so the market entity has an ID, it also has a name, but it also specifies the type of currency that the market deals with. Our goal for this lesson is to associate the currency with the market. So before we begin with our annotation mapping, let's take a look at our data model. Here we see the market table, which is associated with the market entity. You'll notice that we have a market ID, so I'm using a surrogate key actually for the identity of the market entity. But you'll also notice we have the currency name field and country name field. And if we look at the constraints on this table, we see the currency foreign key is applied to the currency name field and the country name field. And they both point to the associated columns on the currency table. So our currency name maps to the name column on currency, and our country name column on the market table maps to the country name column on the currency table. So we are using these two columns to establish a relationship within our database. So we need to reflect that in our entity model when we associate these two entities. The mapping for this situation is almost similar to mapping something like a regular many-to-one. we do need the many-to-one annotation because one currency can be associated with many markets. So we do apply that annotation to our field, and then we're going to specify the cascade type, and I'm just going to specify all. Okay, so that looks fairly familiar. And then here's the part we may not have seen. So we have two columns that we need to join. So what do? We use the join columns annotation, and within the join columns annotation, we can specify multiple join columns. So we use an array, and then within that array, we place a single join column, and we specify the name of our join column. So we know we had the currency name column within the currency table. Now here's an important part. Once we import our join column, we need to specify the referenced column name. Because the name of the column within the currency table does not match exactly with the name of the other column we're joining to in the market table. So if we were writing the on clause, it would look something like market.currency_name is equal to currency.name. So we need to specify the name of the column in the currency table. And then we also need to specify our second join column, which was the country name. And we're going to specify the referenced column name as the country name. Okay, so we have our join columns in place as well as our many-to-one annotation. And it's very important that we use the referenced column name, even if these column names did match. So let's say name was currency name. You can still run into instances where Hibernate does not know how to match the columns, and you may see the currency name being matched up with the country name. So it's good in this situation to specify a referenced column name. So with this mapping in place, let's head to our application class and we'll set up our demonstration. So here you see creating a session factory, also creating a session, a transaction. We're assigning those variables different instances of their respective object types. And then we begin to create a currency, and then we create a new market. So what we need to do now is set the currency on the market. So we have accessors for the currency field on the market entity, and we just specify the currency. And then we're going to persist the market. So it's going to go from a transient entity to a persistent entity. And it's also going to persist the currency because we have specified our cascade type. And then we commit our transaction, so that will flush all of our database changes to MySQL database. And then I'm just going to pull out the market from the database. Once again, got a cast because we are using the session. And then we're going to specify the market class. And we're going to grab the identifier for the market and pass that in. Information to debug this. We'll get our currency, and then we'll print out its name. Okay, so we are ready to run this example. And there we see we're getting a little bit extra information from Hibernate this time. I set it to info. And you see that we have inserted our currency entity, and then we insert our market entity. We print out the name of our currency. So let's just go to the database and we can check on this. There's the currency table. We'll select everything from it. There we see the pound. And now let's see if our market's in place. There is the pound within the London Stock Exchange. So in this lesson, we learned how to establish a join or an association when there are multiple join columns because we are working with an entity that has a concatenated primary key. In this lesson, we're going to take a look at enumerations and how we can use JPA annotations to store enumerations within our database using Hibernate. So if we look at the account entity, you'll see that it has a field named account type. And the type of the account type field is account type. And if we take a look at that field, we see that the account type is actually an enumeration. And the enumeration has two values, one being savings and the other checking. So these values will indicate what type of account we are working with. And in this lesson, we're going to find out how to store these values for the account entity. If we return to the account entity, it's actually pretty simple. We just need to provide one mapping. I'm just going to specify the account type as the column name, and we wouldn't even need that as long as it would default. So you really wouldn't even need to put the column annotation in place. That's just something I do out of habit because I'd like to explicitly specify the name. What we'll see is that this account type field will map to the account type column on our account table. And I just like to explicitly define that mapping. But this is it. That's all we need to map an enumeration within our entity. So what I've done is I've prepared a quick demonstration. And here you see that we grab our session factory and then we create a session. So there's our persistence context being built, start that transaction, and then we use our helper method to create a new account. And then we set the account type and we're specifying that this is a savings account. So we see that line being called here. And then we will save our account. So this is going to turn that transient entity into a persistent entity, as well as fire off that insert statement. And then we're going to query the entity from the database and just print out its name and its account type. So let's run this example. Okay, and in our console, you see the insert statement being fired, and then our system.out.print lines are also wrote to the console. So there's the savings account, and then we are specifying that its account type is savings. So let's just take a look at that within our database. If I query the account table, there we see the account record was inserted for that entity, and the account type column was set to 0. Well, what does that 0 mean? If we return to Eclipse, we can navigate to the account type enumeration. And what that 0 means is it's the ordinal value of the enumeration value. So being 0 indexed, savings would be 0 and checking would be 1. So we're just storing an ordinal that corresponds with the value that was provided for the account type enumeration field on the account entity. Now, do you see a problem with that at all? Let's run through another demonstration just to see why maybe that's not such a good idea. So I'm just going to add a loan as another account type. Once we put that loan in place, let's head back to our application. And what I'm going to do is comment out all of our inserting of the account entity into the database. And then I'm just going to commit our transaction to keep that in sync. So I'm leaving the part that's going to pull out our account from the database. And then I'm going to specify that we're going to pull out the account with the ID of 5. And we'll print out its information to the console. So if we look at this console output, we notice that our savings account now has an account type of loan. Well, what happened? If we look at the account type, you'll remember I put in the loan value, and that actually shifted the ordinal. So loan is now the 0 ordinal value, and savings is the 1 ordinal value. So it's not very robust to use the ordinal value to store our enumeration values, because as soon as we change that enumeration, we have a problem. There's a solution. If we return to the account entity and we go to the account type field, we can provide the enumerated annotation. And this is a JPA annotation, but Hibernate, being a JPA implementation, can easily read it. It will work with Hibernate core. And within the enumerated annotation, we can specify whether we would like to store the ordinal value or the string value. So there you see we specify an enum type of string. And it is my recommendation to always go with string. So I'm just going to save that. And now we're going to head back to our application. I'm going to undo everything that I just did for our last demonstration. Okay, so we should be set back up. Now we'll run the demonstration. We see one more time our new savings account has an account type of savings. And if we head to our database, we'll check out our new account record. And this time we see that the string value of the enum value was stored within our column. And that's going to be more robust when we store our enumerations. In this lesson, we will turn our attention to inheritance. Inheritance is an object-oriented design principle that we use to increase the maintainability and the robustness of our applications. Our entities simply boil down to objects, so it wouldn't be uncommon to find inheritance used within our entity model. In order to be able to persist entities that leverage inheritance, we need to be able to provide mapping metadata that will instruct Hibernate how to perform those CRUD operations. To see this in action, we're going to walk through a demonstration. What I have done is I have created a stock and a bond entity. And these are two types of investments that we may want to track within a system. One thing that is common about both the stock and bond entity is that each of the entities has a name field, an issuer field, and a purchase date field. And those are some common fields between these two entities. So we're going to abstract those entities into an abstract class and have both of our entities extend that class so we can leverage some reusability within our application. Now, if we take a look at our data model, we're going to see that there is a table for the stock entity and there is a table for the bond entity. Within each of those tables, we will find those common fields, the name, the issuer, and the purchase date. And then there's also some fields that are specific to the stock and to the bond. So here we see a share price and a quantity for stock. With the bond, we see our common fields, but we also see an interest rate and a maturity date as well as a value. We're going to take a look at how we can leverage inheritance to persist these two entities. So let's return to Eclipse. The first thing we're going to do is abstract a super class that we can use and extend with these two entities. So I'm just going to use Eclipse to abstract a superclass, which I'm going to name investment. And then we will pick the common properties, name, issuer, and purchase date. Now we see that stock extends investment, and we can scroll down to make sure it got rid of our accessors. And it didn't, so I'm going to remove those. And now we're going to go to our investment class. And there we see it pulled out the properties we were looking at. We don't need that default constructor. And I'm just going to create accessors on the superclass. Now I'm going to head over to bond to extend our new class. So we just extend investment, and now I can get rid of the name, the issuer, and the purchase date properties. And we can also get rid of those accessors. So we are putting all that code in a common parent class so we can gain some reusability. And now if we look at our investment class, we have our accessors, and we also see that we have the column annotations in place upon each of our fields. Our inheritance is in place. Let's head over to the application. And just like before, we are going to build a session factory. We're going to pull out the session, build a transaction, then we're going to use a helper method to create a stock object. We'll save the stock object, build a bond object, and then save that bond object. So let's run this, and we're going to get an exception. The problem is we are not specifying a name field
For one of our objects, it'll probably be the stock object because that's our first one. Yep, it looks like we failed on stock. In order for Hibernate to pick up the fields that we have in our parent class or that parent in the hierarchy, we need to provide an additional annotation, the mapped superclass annotation. And what this will do is it will cause all of the fields within a parent class, which we could make abstract if we wanted. And that's actually a good practice to prevent anyone from instantiating this class. But the map superclass will cause these fields to be recognized by the persistence provider Hibernate. And when we go to perform our persistence operations, they will be taken into consideration and persisted to the database. So let's just go back, and now we will run through our demonstration. And there we see that the stock and the bond were successfully persisted to the database. So just putting that simple annotation in place fixed everything. Let's talk about that annotation a little bit. There are definitely some limitations to this approach. The mapped superclass is great when we want to share some state between our different entities, so they have the same fields and we kind of want to reuse those fields throughout different entities. One of the problems is this is much like an abstract class. We cannot create an instance of an abstract class. The mapped superclass is similar in that you cannot create an entity from a mapped superclass. So it's not like we could use the investment as the target of one of our associations. So you couldn't have a list of investments. Investment will never have its own persistence lifecycle. So whenever you're using the mapped superclass annotation, you need to ask yourself two questions. First, will you ever need to query across the class hierarchy? So would you ever need to have a bond and a stock being pulled back in the same query? If the answer is yes, the map superclass is not for you. The next question you need to ask yourself is if you will ever need to use just the type of the parent class to act as an abstract type for our concrete classes. So would you ever refer to the investment as opposed to the stock and the bond? Maybe you have a list of investments. And if you have that need within your application, you need to steer away from the map superclass. Now, there are other ways to solve those issues and to gain that functionality, and we'll take a look at those in later lessons. In this lesson, we will take a look at a more flexible strategy for mapping inheritance within our entities. We saw that you can use the mapped superclass to map a class hierarchy. However, as we discussed, there are limitations to a mapped superclass. For instance, if we wanted to have a collection value type on a different entity, so here we have a portfolio entity, and it's going to hold a bunch of investments, and we'd like to store those investments within a list or some other collection. We are not able to do that with a mapped superclass. So we have to put in place a different strategy that allows us to build entity associations and allows us to query across a class hierarchy. Let's start putting this new strategy in place. The first thing we'll need to do is navigate to our investment.java class, so our investment abstract class that is the parent of our hierarchy with the bond and stock classes. And we will remove the mapped superclass annotation. In its place, we will put the inheritance annotation. It is a JPA annotation, so we'll import that. And then we have to specify a strategy. And there are three types of strategies you can use for inheritance. We're going to take a look at the table per class strategy. This strategy means that we will have a table for each one of our concrete classes. So we will have a table for bond and a table for stock. This is very similar to using the mapped superclass strategy. However, now we will be able to use the investment type within associations and within queries. We will select that strategy, and we also need to annotate the investment as an entity. Okay, so we'll save those changes. The table per class strategy requires us to put a few other changes in place within our abstract class.
so within the parent class of our hierarchy. The first is we need to specify our ID within the abstract class investment. So we're going to create a new field of type long, and we'll give it the name investment ID. And this will serve as our identifier for both the bond and stock entities. And we're going to use a different type of strategy to generate a value for this field. We're going to use a key generator, and we're going to specify our strategy as table. Now we need to make our table generator. And if you remember, within our database, we have the finances keys table. So I'm just going to pull that up, and I'll copy the name of that table. Then when we specify our table name, I'll just paste that in there. And our PK column name, PK name. And then we have to specify the value column name, which was PK value. There we have put in place our table generator, and we still got one attribute to specify, its name, and we'll give it a name of key generator. I'll format this a little. So we set up our new identifier. We put a table generator in place because we cannot use the standard identity generator that is used by MySQL. We need to use a table generator when we're using the table per class inheritance strategy. And then finally, I'm going to put the column name in place, and it's going to be investment ID. And now we must add one more field to this abstract class, and that is going to be our portfolio field. We're going to make our association with portfolio bidirectional, because we actually need to provide the mapping information for the association within the abstract class. We always have to specify our join column annotation here, because the investment will actually be the owning entity, and we'll see that in a minute. So we're going to specify the join column, and it's going to be portfolio ID. And then we're going to specify that this is a many-to-one relationship, and we're going to specify a cascade type for that many-to-one relationship. Okay, so that put our mapping in place. Now, one of the things you got to be asking yourself right now is, well, when we specify the column name for the primary key, which is investment ID, or this portfolio ID as our join column, doesn't that mean that both of those tables will need to share the same column names? And if you were thinking that, you're exactly right. We will need to make some changes to our underlying table. So what we'll do is we'll go in and we'll change our stock ID to investment ID, and we're going to add the portfolio ID column. I'm going to make that a big int. And then we should also add a foreign key to the portfolio. We'll map that. Let's apply those changes. And now we need to do the same for the bond table. Portfolio ID column, big int. We'll map that. Let's apply those changes. Okay, so our table changes are in place. Those are all of our changes for our abstract investment class. We'll pick up in our next video. In this video, we will pick up where we left off in our last lesson. We were annotating the investment class so it can support table per class inheritance mapping. So we have all the annotations in place, and now we're going to finish our demonstration. The first thing we need to do is put accessors in place for the two fields that we created, the investment ID and the portfolio. So with those in place, we'll save our investment class. And now we're going to move over and take a look at the portfolio entity. The portfolio entity has this list of investments. We're going to establish this side of the association now. And it's going to be a one-to-many association, so we will use the one-to-many annotation. We're going to specify that it is mapped by the portfolio field on the investment abstract class. That is the field that needs to provide all of our mapping information. We can't put a join column on this investments field within the portfolio entity. It just won't work like that because of inheritance. With our mapping complete in portfolio, we have two changes we need to make within stock and bond. Having specified the investment ID, we need to now remove the ID that we had previously established for this entity. Remove that, and then we need to clean up the accessors. And we'll go over to the bond entity, and we'll do the same thing. So there we remove the identifier and all of its annotations, and then the accessor for the identifier. Clean up our imports. We'll go back to stock and clean up those imports. And now we are ready to work on our demonstration. So here you see the idiom we're pretty familiar with. We create the session factory, we open a session, and now we begin a transaction. I'm going to create a new portfolio and set its name. And then we create a new entity, a stock entity, and it's transient. We're actually going to set the portfolio on the stock entity. We do the same thing with the bond entity. We create a bond, it's transient, and now we're going to set its portfolio field using the accessor. Now we manage both sides of the relationship by adding the stock and bond to the collection of investments on the portfolio. And then what we're actually going to do is, instead of saving our portfolio, we're going to save our stock entity and our bond entity, and we will allow them to persist the portfolio through the cascade. Once we commit our transaction, we will see the insert statements fired off, and then we're going to go in and query for the portfolio that we just created. We'll return that using the get method on session, and then we will refresh the entity. Then we are going to iterate through all of the investments within the portfolio, and we are going to print out their name. So let's save our application class and run this demonstration. Let me expand this. In our first line, we see we're using our table generator, and we see that in our second line, so that's where we're getting our primary keys. We insert the portfolio, then we insert the stock, insert the bond, and then here are our queries from when we retrieved these entities from the persistence context or from the database using our session. I'm just going to take a look at this guy, and I'll open a new notepad session. That's quite the query. But the important thing is, and this is one of the disadvantages of using the table per class strategy, is that Hibernate has to perform a union. Now, when we have just 2 records, that's not a big deal. But if there were thousands of records, that union operation is going to get expensive. So there is a price to pay with table per class inheritance. And in fact, there is a price to pay with almost every inheritance strategy. Object-oriented inheritance and database inheritance don't really map up because there is no concept of inheritance within a relational database. There is a disconnect between them. And Hibernate does a good job of bridging it, but it just can't overcome some of the inherent defects in trying to map inheritance within an ORM. So there we see our output, and let's return to our investment class. Let's just quickly review. We swapped out the mapped superclass annotation with the inheritance annotation, and we specified an inheritance type of table per class. This requires us to make a table for each of our concrete classes that extend the investment class. We needed to supply a generator for our identifier, and our identifier is shared amongst both concrete classes. We also needed to specify our association to the portfolio entity within the abstract class so that it may be shared by both of our concrete entities. Now, having placed our identifier on the abstract class, we needed to go into the concrete classes, bond and stock, and remove those ID attributes from those classes. We also needed to make sure that both of our tables used investment ID and portfolio ID as opposed to something like their original identifiers, bond ID and stock ID. Now, one thing you want to be aware of is that will break what we have done in some of our previous lessons. So if you do run through this lesson, be sure to change your identifiers back once you are finished. In this lesson, we will discuss the single table strategy for mapping inheritance within Hibernate and JPA. The single table strategy is the most common strategy used to map inheritance. It is also one of the best performing strategies that we can use. The whole premises behind the single table strategy is to take every field within our entity and associate it with a column upon a single table. What we have done is we have taken all of the fields within our stock and our bond entities, and we have placed them within this table investment. We see the common fields between the two entities, as well as the distinct fields within the two entities. Now, what will happen is as we populate this table, some of our fields will just wind up being null, because when we insert a bond into the database, we will not be specifying a share price. Now, on the other hand, when we insert a stock, we won't be specifying the interest rate on the stock. So it's a trade-off. Sometimes we just have to accept that we're going to have some null values within this table. Now, some database administrators may not like that, but they also may not like the alternative of a table per class strategy, where we're actually going to duplicate a lot of fields. It's always a trade-off when we're mapping inheritance. But let's take a look at how this strategy works. The first thing we'll do is go to our investment class, and we're going to change the inheritance type, and it's going to get changed to the single table strategy. The next thing we'll do is we will specify what is known as a discriminator column. And this is a column that will reside within our inheritance table that will be used to discern between the type of investment that we are working with. So there will be a value put in that column for bonds and a value put in that column for stocks. So all we need to do is specify the name of that column and its investment type. You can see if we look at our database that there is an investment type column, and that column will hold the value that is going to discern between our stock and our bond records. We simply specify that on our abstract class, and then we also specify the table name, and that is going to be investment. So we'll import the JPA table annotation, and at this point our mapping is in place. Now, one thing that needs to also be in place when we are performing this type of strategy is our ID column, and any associations should be specified within the abstract class as opposed to the concrete classes that extend the abstract class. So we'll save everything there. And now we just have one other thing to do. We need to remove the table annotations from the entities bond and stock, because we will no longer be writing two separate tables. So we'll just take those out, and we will save our changes after we organize our imports. And now let's go over to our application class and see our demonstration. This is a fairly simple demonstration. It just creates a session factory, opens a session, opens a transaction, creates a new transient portfolio, and then we create a transient stock entity, a transient bond entity, set the portfolio on both of those entities, then we manage both sides of the relationship, and then we save our two entities by calling the save method on our session. Then we simply print out some debugging information so that we can see our entities have been inserted into the database. So let's just run this demonstration. And there we see we have utilized our table generator. And in fact, with this type of annotation, we won't even need to use a table generator. So for example, I can go in and remove this table generator, and we can just use the identity generation strategy. And you'll see that if we run this example, it works also with just our regular identity generation type. So here we ran it again, and we just see now the insert into the portfolio, the insert into the investment 2 times, Let's expand this. If we look at these insert statements, there you see the first one is going to be inserting our stock. And there you see that discriminator column being set. So it's being set to the name of our entity. And if we wanted to change that, we can go back to our stock entity. You can actually specify the discriminator value here. So let's say we just wanted it to be ST for stock, and then we go over to bond, and now we want it to say BND for bond. The discriminator value annotation allows us to specify the values that will be used to discriminate between our entities and their types. So let's run that again. And now looking at it, if we expand our console, now we see our values that we specified being used for discriminator values. If we don't specify those, it will default to the name of the entity, which is the class name. Then we see that we're retrieving our investments from the investment table. There is no need this time to do any union, so that's why we're going to get those performance increases. And then we're going to print out the name of our two portfolios. So that is our lesson on the single table strategy for mapping inheritance. In this lesson, we're going to have a quick discussion about organizing your persistence code. When you're building out an application, it's best to keep all of your persistence code in one spot. You want to separate it into its own layer. And what this will do is it will keep your persistence code from intermingling with your business logic. It can be quite confusing and hard to read code when it becomes twisted and intermingled and intertwined. That's why we have things like model view controller, because we like that separation. That separation allows us to look at an application and almost predict where we're going to find certain pieces of code or where the execution flow is going to head. When we have a layer in place, it's pretty common that we are doing things the same way in our layers. That way, for example, if you have one concept flowing through your persistence layer, so one pattern, and the pattern I would recommend is the DAO pattern, then you know for each of your entities, there's going to be a DAO, there's probably going to be an interface with it, and there's probably going to be some abstract DAO that performs a lot of the logic. So anytime you build a DAO for an entity, or you need to build another DAO for an entity, you already have that problem solved. And you can expect how that's going to look in your code. You already know, it's pretty intuitive. That's what this lesson is all about, advocating for setting up that persistence layer and putting some sort of consistent approach in place to performing persistence. The way I normally do this is to have something like this data package. And within that data package, I will place all of my persistence code. Now, I'm violating this a little bit right now because I have the application class within my data package, but normally that would be outside of this package. You would see a com.infiniteskills.web package if I was building a web application, and then within that web package, I would have all my controllers, basically the controller piece of the MVC pattern. And that controller piece would call the code within my data package, which is serving as my persistence layer. So that's how I would organize my code, and I usually like to build out an interface for each DAO that I'm creating. And the DAOs all work off of a sole interface that they all extend. So let's take a look at some of this code. Let's imagine that we wanted to create a DAO pattern and put it in place for this application. So we're going to walk through creating a DAO for the user entity. Now, you can see this code and put it in place for any of the other entities. I'm just going to show you the user piece. So the first thing you always start out with is a solid interface. The interface is nice because it creates a facade that we can program behind. Now, we're starting out with a simple DAO interface. There we see generic type parameters on that interface so that we can have generically returned types for some of our methods. So here you see that we return a generic type from our findById method. We have a method to find all of our entities, and that returns a generically typed list. We also have a method to save an entity, delete an entity, flush, clear. These things should look very familiar to you. we're really mapping a lot of what we do in Hibernate to just some more generic terms. Now, once we have that DAO interface, normally we will create an abstract DAO that will implement that interface. So here we see our abstract DAO class. It also has generic type parameters. And this class just provides the implementation for those operations which are generic enough that we can abstract them out and use them for any entity. So let's just take a look at this class and see what we have. Obviously, we are providing implementations for everything on the DAO interface, but we also have some other things going on. Here you see we are actually finding out the generic type that is going to be our persistence class, and that allows us to interact with the session. We also have a method to set the session, a method to get the session, a method to get our persistence class, and then we start getting into some of our implementation. So there you see we grab the session and we invoke the load method, and we're passing in our persistence class and an ID that is supplied as a parameter to this method. We have other methods that we have all this implementation for. There's our save method, our delete method, flush and clear, very simple, as well as delete. Those methods can basically support almost any entity. It's pretty abstract, and the problem is so clean cut that we can generically provide that implementation. So let's move on to the user DAO interface. And you see that this interface extends the DAO interface we looked at earlier. What this interface is for is if you have to provide some method that is specific to this DAO. So here we have a method that searches for users by their first name. Maybe we could have one that looks by the last name, or one that looks for people that have been registered for 5 years or 10 years. So we can put whatever we'd like on this interface that is specific to our user DAO. And now we actually have to have an implementation of that interface. So we build our user Hibernate DAO, and it extends the abstract DAO so it gains all that functionality. And then it implements the user DAO, so it has to provide an implementation for any method that is specified on the user DAO interface. You can see how quickly you could build another DAO for one of our entities. Let's say we were working with bank. We would just need to create a bank DAO interface. Then we would create a bank Hibernate DAO, and we would extend the abstract DAO and implement the bank DAO interface, and then provide an implementation for any method specified on the bank DAO interface. So how do we use this? Well, let's look at our application. So here you see we build our session factory, grab our session, and then we just create a new instance of our DAO. Here I'm setting the session on that DAO. Then I begin a transaction. I'm creating a new user. I save the user, and then we commit our transaction. Having this in place will really help clean up your code. It's going to make things predictable, more maintainable, and it's also a nice thing if somebody else takes over your code, because then they don't have a mess on their hands. And it's always nice when you walk into an application where somebody has really taken the time to put something like this in place. So anytime you can, put a structure in place, put a persistence layer in place. So we haven't talked a lot about querying entities. We've seen how to query by an ID, but we haven't seen how to do things like execute joins, or maybe execute a query that has some functions being performed on our columns, so we're getting some aggregate data. One thing I wanted to show you is when you hit one of those really tough queries that you just can't map using any means that Hibernate or JPA provides, there's always one fallback option that I like to use, and that is to create a view. So for example, one time I was building this application and I needed to crunch metrics. I had a metrics page that displayed all the stats from the last day, the month, the year. It was taking all of this logic into consideration, and this was just a huge piece of SQL just to even get this information in the database. Now, I was never going to be able to map this with Hibernate and JPA. What I did is I created a view in the database. Now, this is not the view I've created. but it is one we will use for an example. So here you see the vUser_credential view, and this is just a view that I placed into the MySQL database. And then what you can do is just map this view like an entity. So here with the table name, I specify the name of the view, and then I just map the columns as we normally would for an entity. Now I don't add a generated value annotation because we're not going to be inserting this entity. So that's another thing you'll have to take into consideration. You're going to need to create a DAO that is basically read-only. But this is still a really good option when you just have logic that is so complex that you can only really encapsulate it within native SQL. I'm just going to show you this demonstration. Here we've created our user credential view object, and we're pulling back that entity using session.get, and then we're just going to print out the first and last name of our user credential entity. There we see we're able to query our view. We'll look at the from clause here. We're querying the view. There is our view name that we were executing against. Just one handy little trick that you can use if you ever run into some really nasty logic for your queries. One of Hibernate's useful features is its ability to generate our DDL. If we provide the proper configuration, Hibernate will actually construct our tables that correspond with our entities. So it will basically build out our database to correspond with our entity model. Now this isn't something that you would run in production using the auto-generate DDL feature. But if you are performing development, it can be useful to have the tables constructed for you, especially if you're just trying to learn some things about Hibernate and experiment. So if you're building a proof of concept, it could be nice to just have tables built that correspond with your entities. One word of warning, though, is that sometimes this feature can actually mask errors that would occur if you had a solid table structure in place. So let's take a look at how we can auto-generate our tables. So the first thing we need to do is specify a property within our configuration. And this property is hbm2ddl.auto. And then we're going to provide values for this property. You'll notice that some of our connection settings have changed. So I'm actually running this against a different schema. Notice how we're using the iFinances2 schema, and I've changed my username and my password. And if we look at my database, we see that we now have iFinances2, and there are currently no tables within that schema. The first thing we're going to do is we're going to use the create option to tell Hibernate to create all of our tables that correspond with our entity model. So I just have a quick application we'll run. So Hibernate reads our configuration file and realizes it needs to create all of these tables. So here we see within our console output, the first thing it does is it looks to drop everything, and then it starts building our DDL. And if we go to our database now, we will see that we have all of our tables. Our example simply inserted record into the bank table. Another option is simply to validate. So what this will do is it will look at the tables and the objects required by our entity model, and it will just make sure that they are in place within our schema. So we can run this example. We have inserted a record into the bank table, but what Hibernate did before that is it just checked to make sure all those tables were in place. So for example, if we were to do something like, just change this to account 2. So Hibernate would be expecting an account 2 table. We're going to get an error. See, it informs us that we are missing an account 2 table that it expects to be there. Okay, so let's change that back, and we can close that. And now we'll head back to our configuration file. Another option is update. So basically, Hibernate looks at the existing schema, and it makes sure everything's in place. If it's not in place, it adds it. Let's go to the account class again, and I'm just going to add a new field there. So private string new field. And if we go back to our application and we now run our example, we'll then see when we check our database, the new field column was created. So it added the new field that we created to the database, essentially updating our database to be in line with the entity model. And now we're going to look at one final option, create drop. This one will create all of our tables, but then when we're done running our application, Hibernate will actually drop all the tables again, so we're left with a fresh schema. Let's run this example. We see it creating all the tables, and then notice it drops everything. So here we see it's dropping everything, then it's creating all the tables, so we're building our schema, then we perform our insert, so now our work is done being performed and our application's closing, and then Hibernate starts to drop everything. So if we look at our schema, you'll notice once I refresh that there are no tables left. So basically Hibernate cleaned everything up. Once again, strongly cautioning you, do not do this in production. If you run create drop in your production environment, people are going to be not happy. Just another option you have when working with Hibernate for proof of concept or when you're doing development. So it's time for a new chapter, and the title of this chapter is Hibernate Query Language and Java Persistence Query Language. Now, both of these query languages go by different acronyms. HQL for Hibernate Query Language and JPQL for Java Persistence Query Language. If you're familiar with SQL, you know that you write a query and it goes against the tables and columns within a database and it executes and gives you a result set. The Hibernate Query Language and Java Persistence Query Language work similarly to SQL, except instead of going against the data model, so against tables and columns, we're going against our entity model, so we're going against classes and fields in that class. That's what we're going to learn about in this chapter. We've looked a lot at mapping annotations and then how to insert and update information within our database. Now we're going to look at how to pull that information out when we need to execute a little bit more complex of a query than just find by the particular ID of an entity. So let's take a look at our chapter objectives. The first one is very simple. We want to learn how to pull back entities using HQL and JPQL. And the queries that we're going to make to do this are going to have different features. Some are going to be a little bit more complex, others are going to be a little bit more simple. Some are going to consider dynamic input, some may use different functions. So we're going to have all these different things that influence our query, and that's going to determine what type of data we retrieve back when using our persistence provider. Now, in order to execute these queries, we need to work with the respective APIs. So if we're using HQL, we need to work with the Hibernate API, and JPQL, we need to work with the JPA API. So there's going to be interfaces that we work with to execute our queries. And we're going to get introduced to those and learn how we can use them to pull entities back through our persistence provider. Now, as I've already alluded to, there's different capabilities within these query languages. And the more you can master the different functions and expressions that you can use, it's really going to determine how complex of a query you can craft. So we're going to learn the syntax of each of these query languages. Don't worry, they're very similar. And that's going to lead into our important lesson notes. We're going to learn both of these query languages in tandem because they are very similar. You'll notice that the interfaces we use to interact with them differ slightly, but for the most part, the queries are almost a match in a lot of instances. Now, HQL will definitely provide some more capabilities than JPQL, but it's nothing that's going to not allow us to look at both of these languages at the same time. Another thing I'd like to point out is there will be a populate.sql file provided in your working directories folder. If I tell you to use that file, make sure you run it against your database prior to performing any work in the lessons. And then finally, I just want to point out the differences between Hibernate's HQL and JPA's JPQL. JPQL is just defining a specification or a standard. HQL is a superset of JPQL. So anything you can do in JPQL, you can do in HQL. But the inverse is not true. You cannot perform every HQL function within JPQL. And that's because some of the functionality provided in HQL goes beyond the standard that is set in JPA and JPQL. So this is going to be a great chapter, and we're going to learn how to pull back some of that information we've been storing. In this lesson, we're going to learn how to execute an HQL and a JPQL query against our database in order to pull back our entities. To help us with our demonstrations, I have created two applications. One is an HQL application where we will execute Hibernate HQL statements against our database using Hibernate's API. And the other is the JPQL application where we will use the JPQL language within the JPA API to pull back our entities by executing queries against our database. We're going to take a look at both of these, but we're going to start with HQL. Before we get started, though, I want to remind you that you should run the populate.sql script, which can be found in your working files directory against your database. This will sync up my database with yours, and we can get some results that we will expect the same outputs from. Okay, so let's get started using Hibernate and HQL. Within the Hibernate API, there is a query interface, and the query interface is what we are going to use to execute our JPQL statements. Remember, our JPQL statements are like SQL, but for the object domain. So I'm going to declare a local variable of type query, and I'll name it query. And then we're going to use our session and the create query method on session. And from here, it's pretty simple. We just need to write our query that we would like to execute. We're going to select T from transaction, and we'll give the transaction an alias of T. This is just saying select every field on transaction, and you'll notice that I'm using the entity type here as opposed to writing in like a database table. Anytime we're writing HQL or JPQL for that matter, we want to be talking about entities. So we'll import the query, and we want to be sure to import the org.hibernate.query type. With that imported, what we can do is create a list of transactions because we're going to pull back every transaction with this query. And then we just simply used the list method on the query interface. So we'll import the list, and we'll make sure that we grab the right transaction. Then we'll just iterate through our transactions with a for each loop. And now we're going to print out the title of each of our transactions. Let's execute this example. And there we see that we fire off that select statement against the database via Hibernate, and then it returns back all of our transactions in the database, and it prints out the title of each transaction. In order to do that, we used our query interface, which is within the Hibernate library. That query interface is good for controlling the execution of our queries, and we'll see it can also do things like bind parameters, and we can also do pagination. So there's a lot this query interface can do for us. That was HQL. Now let's take a look at JPQL. So now we're moving over to the standard with JPA. The first thing we're going to do is work with the query interface, just like when we worked with Hibernate's query interface. But this time we want to choose the javax.persistence.query type because that will be within that JPA API. So we're working with the standard. And then we use our entity manager. And what do you know? Create query. We're just going to specify a string. Now I'm going to show you a little shortcut for writing a query. If you just want to select every field on an entity, you can just do from and then your entity type. So I'll give it an alias. And then we will order by t.title. So now we're referring to a field on our transaction entity. We're going to have a list of transactions. We're going to get our result list. That's a little bit different than the Hibernate API for working with these queries. And we want to pick our right transaction and import our list. We work with the transaction, we iterate through each one, Now, one thing you'll notice, and we got this on the other example too, is that it's complaining about the type. We're trying to take our return type and cast it. We just need to say that that is an unchecked cast. There's really no way around that. You can actually move that up to the method level for this example. Where you put it during your code is going to depend upon your logic. We have this query set up. Let's execute it. Okay, there's our first HQL query. Notice how our order by clause was put in place. Now we're just going to look at one more thing. We're going to look at what's called a typed query. And this is a different interface provided by JPA. It takes a generic type. So we're going to give it a generic type of transaction and import it. It uses a different method. We actually have to supply the class of the type we're trying to pull back in our query. This is nice because then you'll notice we don't even need to have suppress warnings. So we can do that unchecked cast now. If we run our example, we see the results are the same. Anytime you can in JPA or JPQL, make sure you use the typed query. The only time you wouldn't use the type query is if you didn't know the type that your query was going to return. So that was our first example with HQL and JPQL. Let's take a closer look at HQL and JPQL. We know that we can execute a query against the database and pull back all of our transactions. Well, that's great, but we need to add a little bit more logic in there. And the thing that's going to help us do that is by using the different expressions and operators provided by these query languages. So we're going to start out working with HQL, and we're just going to dress up our query a little bit to demonstrate some of the power of the query language. What I'm going to do is I'm going to add a where predicate to our query. And I'm going to use our alias of t to refer to the transaction. And then I'm going to say where the amount is less than 25. You'll notice with the dot operator, I am able to refer to a field on the transaction class. So if we were to look at transaction, there we see we have amount, and we're just simply navigating to that field using a dot operator. We can also navigate to associations that way, so I can navigate to the account in that manner also, and then access a field on the account using the dot operator. Let's return back, and we're just going to save this, and we'll execute our query. There we see that we bought socks, lunch, and breakfast, and they were all under $25. Let's add a little bit more to this query. I'm just going to drop it down to another line here. Let's actually look for things that were greater than $75. There we're using the comparison operator, greater than or less than. We can use equals, and we're comparing that to a number. And now we're actually going to add a logical operator. So we're going to say and. We're going to inspect the transaction type, and we're going to say where it is a withdrawal. So we wouldn't want to pull any deposits that were greater than $75. Simply looking for expenses. Now when we run that query, we see that our work shoes, our shirt, and our pants, and our groceries all cost more than $75, and they were withdrawals. One thing I'd like to point out with that query is that we used a string literal, withdraw. And anytime we use a string literal, we use single quotes. If you need to escape a single quote, so you need to put a single quote somewhere in your string. So let's say for some reason we wanted to put can't in here. You would just use to, and that would be properly escaped. We're not going to get anything back with this query, but we can see that the syntax checked out because we escaped it. So I'll change that back to withdraw. And now let's head over and we'll run an example in JPQL. There's not much difference here between JPQL and HQL. You kind of just have to feel it out and consult the documentation when necessary. But if you're trying to stay strictly adherent to JPQL, it's a little bit harder because then you'll want to look up every expression or operator you use to make sure you're adhering to the standard. But if you don't mind spilling over and using Hibernate, then you can pretty much go wild with any expression or operator. So I'm just going to illustrate some other expressions. We are going to add a where clause to our typed query. And we're just going to say where the amount is now between $75 and $100. We can use parentheses to separate that piece of our predicate. And let's also specify where the title is like S, so it ends with an S. Here we see we're using the like comparison operator, and we're actually using a wildcard with it. Once again, we have our string literal. And now we're using the between comparison operator. So just kind of further demonstrating the power of JPQL and HQL. Any JPQL query you execute will be a valid HQL query. The inverse is not true, however. So one thing I just noticed here is we need to put a space in. I accidentally broke our string prematurely. So let's save that, and now let's run our query. There you can see that we pulled back groceries, pants, and work shoes. So those transactions all fit our criteria. Now, one thing I'd like to show you, if you go to the Hibernate documentation, there's a great page for HQL, and just simply go down to the expressions, and here's a list of all the expressions, the operators that you can use when using HQL. For JPQL, the list isn't as well defined. One good resource is the wiki book for the JPA API, and that will include the JPQL documentation or some informal documentation on it. This has a really good example of different expressions and operators that you can use when working with JPQL. When we build applications, it's very common to accept user input. And user input is often used to determine the query that we will run against our database. Now, this can lead to some problems. If done incorrectly, such as when concatenating strings to form a query, we can open up our application to different security vulnerabilities. Applications that concatenate strings along with user input to form queries are creating the risk for SQL injection. And this can allow an attacker to access more of our database than they should, or they can execute some commands against our database. It's just not a great situation. Now, HQL and JPQL are also vulnerable to SQL injection if we form our queries incorrectly. However, both of the query languages provide us with parameters, which allow us to safely supply user input to our queries. And in this lesson, we're going to take a look at how to use parameters so we can safely execute our queries. Here we're looking at an example in HQL, and this query simply looks for all transactions that are of type withdraw that are above a certain amount. And what we're going to do is we're going to parameterize this query so that a user can specify the amount we would like to search for the transaction. What we're going to use first is called a positional parameter. And you simply put a question mark where you would like to supply that dynamic input. With our positional parameter in place, I'm just going to ask the user for some input. Please specify an amount. And now what we'll do is on the query interface, there is a set parameter method. We'll supply the position of the parameter. And in the case of HQL, our parameters are zero-based, so the first parameter would be 0. And now we need to provide the value we would like to pass to the parameter. Now, we need to remember we are working with entities, and the amount field on the transaction entity is of type big decimal, so that is the type of the value we need to pass in. We'll import that type. And we know that it takes a string in the constructor. So what I'm going to do is ask the user to provide us with a string. Okay, so let's execute this demonstration. There we see it's asking us for an amount. Let's say, give me everything above $75. There we see work shoes, shirts, pants, and groceries. All right, so that was our first example. Now I'm going to show you a better method than using positional parameters. We're going to look at named parameters. So when using named parameters, we just specify our parameter name prefixed with a colon. And then when we call the setParameter method, supply the name of our parameter, be sure to leave out that colon. And now we can execute our demonstration, and let's find everything over $10 this time. And now you see we get more transactions back than before. One thing I'd like to point out about the query interface, if you're familiar with using JDBC, you know you have all those set integer, set string, all of those methods. Those methods are contained on the query interface. However, the set parameter method is intelligent enough to discover the type of the field you're trying to set. The only exception to that is when you are setting temporal types, so dates, timestamps, and times. When you're trying to set a field using a parameter that is of a temporal type, you need to explicitly define the method that you'd like to invoke. So you'd have to pick set date, set timestamp, or set time. Now let's run through a JPQL example. The first thing I should say about JPQL is that when using the named parameters, everything is the same as HQL. The only difference is when using the positional parameters. Now, you probably want to stay away from them as I recommended earlier, but we're going to look at one difference just so you're familiar. Here we have a query that pulls back transactions between two different amounts, and it looks where the title ends with S. We're just going to add positional parameters so that we can specify the two amounts to select between. In JPQL, positional parameters are 1-based, so we're not starting with 0. And actually, when we put a positional parameter into a query, we need to specify an index after it. So here I'm going to put 1 parameter and then 2 parameters. Let's get some input from our user. So we'll ask for the first amount, and we're also going to get the second amount. We'll use our query interface to set the parameter with position 1. Remember, it's 1-based. And we're going to use big decimal because we need to specify the type. Let's use the scanner, and we'll get a string back. Use that to set our big decimal. Same thing for our second amount. We just need to change the parameter. So let's run this demonstration, and let's get everything back between $30 and $100. Okay, so we see groceries, pants, and work shoes. That's how you use positional parameters within JPQL, and that wraps up our lesson on parameters within HQL and JPQL. When building HQL or JPQL queries, there are times when we must leverage our associations to pull back different pieces of information or to add additional criteria to our query. In order to do this, we need to perform a join between our entities. Most joins within HQL and JPQL reference the associations we've established between entities. These are known as inner joins. So let's practice by creating a query that will select all accounts that have had a deposit of over $500 entered to them. Thinking about our model, we know that we have transactions, and they are associated with accounts. So if we were going to find all of the accounts that had a deposit of $500 or more, we would actually need to look at the transactions associated with the account. So let's start building this query. Once again, we'll use the session interface to create a query. And now we're going to provide our query string. We'll want to choose the Hibernate query. We're going to need to select all of our distinct accounts from a transaction. So here is T to represent our transaction, and then we'll specify our entity and give it an alias of T. Now we're trying to pull the accounts associated with a transaction, so I'm going to leverage the account association by using the dot operator and referring to the account field on our transaction. And now we need to specify our where clause, and all of these criteria are applied to the transaction. So we want to see where the amount is greater than $500. The transaction type is a deposit. So we'll use a string literal here. And we want to make sure that we space out our query appropriately. Let's execute our query. So we're going to be getting a list of accounts back because that is what is within our select statement. Here you see that we are leveraging the association to account to return a list of accounts. So I'll call this account, and we're going to have query.list, and that will return a list of accounts. And once again, we're going to get warned, and we'll have to suppress our warnings there. And then we're just going to iterate through each account, and we will print out the name of the account. Okay, so let's save this, and now we can run our application, and we see that we get the checking account and the interest checking account returned. And I see we didn't suppress this warning, so I'm going to go ahead and do that. And now we can remove the unused warning. This form of the join is known as the implicit form of the join. And what that means is that we are not using the actual join keyword within our HQL query. We're going to head over to JPQL, and we're going to run an explicit join, which is the preferred method of joining entities. We'll see that it uses the join statement within our query. Okay, so let's start writing our query. We're going to use a typed query, and it's going to return accounts. Name that query, and now we're going to use the entity manager to create a query, and we're going to specify the type that it will return because we're using a typed query. And now we can begin to write our query. We're just going to select the transaction from transaction, and we're going to give it an alias of t. Now we'll come back and take a look at what we select in a minute, but for right now, I just want to write the join and the where clause. So the next thing we'll need to do is specify our join keyword, and that's where the explicit part comes in. And now in our from clause, we're going to reference the account that the transaction is joined to, and we're going to give that an alias of A. And that's actually what we want to select within our statement. So I'm just going to select all of the distinct accounts, and now we're going to establish our where clause. So where t.amount is greater than 500, and t.transaction type is equal to deposit. Okay, let's break this up some. Now we need to execute our query, so we're going to create a list of accounts equal to our query after we get the result list. So we're going to assign our result list to that list of accounts. Once again, iterate through our accounts, print out the account name. Looking at this, I do notice one thing that's going to be a problem. We have misspelled transaction. So now we have transaction type spelled correctly. Let's execute our query, which leverages an explicit join. And there we see that we have executed a select statement against the account table. So let's just take a look at that query that it creates. You'll notice here we're performing that inner join, and it's looking at the account table. It's using the transaction account ID in the on clause as well as the account ID in the on clause. If we would look at the query that was executed by our HQL example, we would see the same query being executed. This is just the preferred method of executing a query, and that's the explicit form. If you're familiar with writing SQL queries, you know that we can use functions to hone in our result sets and execute more complex operations against our database. JPQL and HQL also provide us with functions that we can use to fine-tune our result sets. So in this lesson, we're going to take a look at some of the functions that we can apply, and we're going to see how to use them within a query that we write using HQL or JPQL. Our first example is pretty simple. We have a query that selects all deposits above $500. Right now, we have a transaction type that is equal to deposit. Well, what if we wanted that to be case insensitive? Well, we can use the lower function. So we simply specify the lower function and pass in our transaction type as an argument. And now if we run this query, it will be case insensitive. There you see that we returned 2 accounts that have deposits greater than $500. So let's head over and we'll run an example with JPQL that's going to be a little bit more complex. So in this example, we're going to not only return the account, we're going to get the name of the bank associated with the account, and we're also going to get the state associated with that bank. So let's modify our query, and we're going to adjust our select clause. I'm going to reference t.account.bank.name. So that will get us the name of our bank. And then what I'm going to do is I'm going to concatenate a space with that name. And then I'm also going to concatenate the state that the bank is in. So let's drop this down to another line. And now we're going to reference the transaction. We're going to work through the account association, then through the bank association, then through the address association, and then through the state association. So we just leveraged a lot of associations there within our query. You'll also notice that we're using this concatenation function. 2 arguments, takes them, concatenates them together. You can intuitively look at that function and understand how it works. One thing that is a little bit different about this query is that we're not returning an entity now. We're actually returning strings. Here we're getting the account name. We're pulling back the bank name concatenated with the state. So we're selecting 2 strings. Now, one of those strings is 2 other fields concatenated together, but it doesn't map to an entity, and that's my point. What we need to do is we need to find out how to iterate through that result set. What's that result set going to look like? Well, there's a name for this, and it's called a projection. Projections allow us to specify the exact properties that we would like returned in our result. They get returned within an object array, and each one of our selected fields will correspond with an index in that array. So we're going to have a list of object arrays, and of course this won't be of type account anymore. It will be of type object array. And now what we do to access the different fields returned is we access our array. The first index would be 0 because arrays are 0 indexed, and that would correspond with the account name. So that would correspond with that first field selected. And then our second index in the array would correspond with the bank name concatenated with the state. So let's also print that out. Okay, and I'm going to save our JPQL application. And now let's execute our demonstration. So you see, once again, we got 2 accounts, but this time we printed out the name of the bank as well as the state of the bank. So we have Second National Trust in Pennsylvania and Third National Trust in Michigan. That's an example showing first how we can use our concatenation function, second, how we can walk through multiple associations, and then third, how we can use a projection. Now, we haven't covered every function, and it's not worth your time to. Most of them are pretty simple, and just seeing a list of them, you can assume what they do. But where do you find that list? Well, there's 2 places. First, the Java EE tutorial will specify all of the functions that can be used within a JPQL query. So here is the Java EE tutorial, and it's in section 39.5.5.12. And then you'll notice it will also point to these 3 tables. You can view all of the functions available to you within this document. Now for HQL, you can head over to the Hibernate documentation, and this is back to section 16.1, and that will list all of the different functions available within Hibernate. So those are 2 references you can consult when you need to execute some sort of function within your query. One of my biggest pet peeves when working in a JDBC application is that SQL tends to find its home all over the application, and in a lot of times you'll see that SQL gets duplicated. The same can be said for HQL or JPQL. You could place your queries all over throughout the application. Now, luckily, we are provided with the named query annotation, and we can define predefined queries for our application. The named query annotation allows us to provide some organization for our queries, and it also provides us with some performance benefits. So in this lesson, we're going to learn how to use the named query annotation to create a named query for our application. Let's start by taking this simple query, which selects all deposits above $500, and turning it into a named query. What you'll do is copy the query that you would like to turn into a named query, and then go to the entity that most closely corresponds to this query. So for example, we are pulling back accounts. So I'm going to go to our account entity, and here we're going to use the named queries annotation. And this annotation is a JPA annotation, and it accepts an array of named queries. So now we need to specify the singular named query, and we'll import that annotation, once again, the JPA version. And now we need to provide a name for this query. I'm going to call it account.largeDeposits. One thing about the name for a named query is that it must be unique for the persistence context. So basically make these names unique for your whole application. Now, the second element we must provide for the named query is the query itself. So I'm just going to paste that query we copied. And with that in place, we have defined our first named query. So let's copy our query name. And now we will go back to the HQL application class, and we're going to build that query. So we're going to use the session interface, and we're going to use getNamedQuery. So that's the method we'd like to use. And we simply provide that query name as an argument to this function, and that will retrieve that query. So we'll no longer need this query that we've established within our code. And now we're referencing the named query. And what's nice about this is once our application starts up, that query gets defined once. So if we use the query multiple times, we won't have that string for the query being concatenated together multiple times. So that's going to provide us with some performance benefits. Let's just save this and we'll run our demonstration. And there we see we get our 2 checking accounts back that have had large deposits. Now let's run an example using JPQL. It's absolutely identical to the same way we do in Hibernate. We're going to use this little bit more complex query here. I'm just going to copy it and then we'll discuss it. So here you see that we're selecting the account name as well as the name of the bank and the state of the bank. We're pulling those back for a variable amount. You'll notice we have a parameter in this query, so we can specify the actual amount that we want to look for. And here we're looking for withdrawals. So maybe we're trying to look for withdrawals above a certain amount in accounts, and we want to see where those banks are just to see where that money is being pulled from. So let's head back to the account entity, because that's where we would associate this query with, because we are inspecting accounts. And we use the named query interface once again. And I'm just going to name this account by withdrawal amount. And then we specify our query. And now we have another named query in place. So we'll just copy this query name again. And then within JPQL and within JPA, the method is a little bit different. We're going to use, once again, the query interface. And on the entity manager, we have the create named query. And we just provide that query name as an argument. And now I'm going to comment out our first query. And at this point, everything's in place. Now, what's different about this one is we are supplying that parameter. You'll notice our query had that parameter in it. And this is just to demonstrate that named queries can also have parameters, so that makes them just as dynamic as any other query you would specify inline in your code. Okay, so we're going to look for all withdrawals that are above $99. Let's run this demonstration. And there we see we pulled back our accounts that have had withdrawals that are above $99. Named queries are a great way to organize your query code. Instead of embedding these queries within your application and possibly duplicating them, you can just attach them to an entity and everybody can use that same query within your logic. In this lesson, we're going to discuss lazy loading and how it affects our application when we query entities from our database. So in order to understand lazy loading, I'd first like to show you the problem we're attempting to address when we use lazy loading. So if we look at our account entity, we see a query that we're pretty familiar with, and it's pulling back all of the accounts that have a deposit greater than $500. We're just working with transactions and accounts. So let's head over to our HQL application, and here you see I referenced that named query, and we're going to execute it. Now, the query executes successfully, but I would argue there's something else going on here. Notice that we pull back our accounts, so we have one select statement for the accounts, and that's pretty much our query being executed. Then you notice we pull back these bank entities. So we're executing the select statements against the bank table. And in fact, we're executing one for each account that we've returned. Well, if we look at our code, we never even work with a bank when we run this query. So what's going on? Well, the answer lies within the account entity. You see that we do have an association to a bank. And if we look at the many-to-one annotation, we get some clues about what's happening. Within the many-to-one annotation, you'll notice this fetch type, and it's defaulted to eager. So what this says is when we pull back an account through our persistence provider, we need to immediately execute the query or do whatever it takes to make sure that the bank is assigned within the account. And because we're saying it's eager, we make sure that happens every time. Now, the opposite of this is lazy. And lazy says, let's wait a second. Let's not pull back that bank entity until we really need it. This is just on the many-to-one annotation. The default for the fetch type is going to vary depending upon the type of association. So for example, if we look at the many-to-many association, we see that the fetch type is actually set to lazy. In that instance, we would not pull back everything that is associated to the account entity. And let's take a look now at a one-to-many association, and we'll just see the default fetch type for this association. We also see that it is lazy. How do we change that association to pull back in a lazy manner? We just set the fetch element on our many-to-one annotation, and then we specify a fetch type, and we're going to set it to lazy. And now if we head back to our HQL application, we can execute our query. And now we see that those additional select statements to retrieve those bank entities and set that field on our account, they're not executed. What if we actually were going to use the bank? I'm just going to access the bank on our account, and I'll print out its name. And I'm just going to throw a little bit of debugging in here so we can see what's going on. Query has been executed. So we're going to execute our named query, get our accounts back, and then we're going to print out this statement, and then we're going to iterate through our list of accounts and print out the name of the account as well as the bank name. So let's check this out. Here is our select being executed for the accounts. Then we print out our debugging output. We print out the name of the account, and then you see the select statement get fired. And that's because we are now accessing that bank field on the account entity, and we actually have to retrieve the bank. But because we've set up lazy loading, Hibernate waits until we access that field, and that's when the query is executed. Now, this is important because it provides us with performance gains. This has been our discussion on lazy loading within Hibernate and JPA. In this chapter, we will learn about the Hibernate and JPA criteria APIs. These APIs give us an alternative way to query entities from our database. So let's look at our chapter objectives. The first one's very simple. We just want to make you familiar with both of the criteria APIs so that you can use them to retrieve entities. And as you become familiar with them, we're going to learn to perform more complex operations. We're going to put some filters in place so that when you execute your queries, you can target a subset of the data that's important to you or maybe the user. And then finally, we'll learn how to take those queries that we've executed and grab the result sets and page through those results. So sometimes we don't want to list every result in our query. We like to show them maybe 25 at a time or 10 at a time and allow our users to access a subset of the results. Let's talk about the criteria API. The criteria API is a programmatic way of executing queries via our persistence provider, Hibernate. This is in contrast to using a query language like HQL or JPQL. When we work with Hibernate, we will use the criteria interface. And when we work with JPA, we use the criteria query interface. We'll see examples of both of these interfaces in action as we work through this chapter. One of the big benefits of using criteria APIs is that it's very helpful for writing dynamic queries. A lot of times we'll have a search screen and there's multiple criteria that our user can use to filter their search. Well, that's usually conditional logic that we perform. And instead of concatenating strings to build something like an HQL or JPQL query, we can use the criteria API and it's going to help us build those dynamic queries. One of the nice features of the JPA criteria API is that it allows us to execute type-safe queries. So what does that mean? Well, when you construct a query using the JPA criteria API, the query will fail at compile time if there's an issue with some sort of type, instead of failing at runtime and leaving us to debug something within possibly a working production system. Anything you can catch at compile time is better than catching something at runtime. So here I want to show the difference between executing a query language query and using one of our criteria APIs. So here we see at the top our simple select T from transaction T query, and that would be a valid JPQL or HQL query. Now what we're going to do is we're going to use the different interfaces to construct that query. I just gave you a small snippet of what that code looks like. So basically we're moving from writing a query to constructing code that will then build our query. So let's discuss the important notes for these lessons. We will be learning both of these criteria APIs at the same time. There has been that fine line between Hibernate and JPA, where Hibernate is the persistence provider that implements the JPA interface. Well, in this case, there's not a very good match between the criteria APIs. You can't say there's a one-to-one mapping between these two APIs. The JPA criteria API looks a lot different than the Hibernate criteria API. It is the recommended approach because it can provide type-safe queries. As we work through our lessons, you'll see examples of both criteria APIs. And then the final thing I want to comment, we're looking at ways to retrieve data. And we have a few options here, HQL, JPQL, and that would fall into the query language category. And then we have this criteria category, and that would be the JPA criteria API and then Hibernate's criteria API. As we go through this chapter, think about what your preference is as a developer. So when you start working on your own projects, you have an idea or an area where you can focus, and you have an approach to solving your query needs. In this lesson, we're going to execute simple demonstrations against the Hibernate criteria API and the JPA criteria API. Now, when we work through each of these examples, we're going to essentially execute the same query. And the reason we're doing this is so that you can compare and contrast the Hibernate criteria API and the JPA criteria API. We're going to just run through probably the simplest example we can. We're just going to select all transactions from our database. So our persistence provider, Hibernate in this case, is going to return all of the transaction entities. That's our query. It would be equivalent to running select star from transactions. The first thing we need to do is create an object of type criteria, and we'll just name it criteria. And then we use our session interface to create the criteria. The createCriteria method accepts a class of the entity type that we're trying to query. So we're just going to pass in the transaction class, and there we have created our criteria. Now, what's nice about the criteria is if we wanted to do something different, like add an order to our query, so we're basically creating the order by clause, we just use the add order method, and then we can specify we want a certain field ascending or descending. So let's get all the titles of the transactions in descending order. And now we just simply call the list method on the criteria object, and that should return us a list of transactions. When we execute our example, we got all of the transactions titles in descending order. Now, we could make this a lot shorter. One thing that's nice about the criteria is that it chains. So calling the createCriteria method actually returns an object of type criteria, and we can just chain our method like this. And we can do the same when we call the list method. Just delete that. And now we'll have to add unchecked domain, and we'll format our class. So there in one line, we can write our query to select all transactions and order them with a descending title. And we can execute that, and we see it works. Okay, so let's clean up our class. And now let's start to do our JPA criteria API demonstration. When using the JPA criteria API, the first thing that we'll need is a criteria builder. So we'll import that type, and then from the criteria builder, we can make a criteria query. And the criteria query accepts a generic argument. So we're going to specify the type of our entity, which is transaction. And then we'll name our criteria query criteria query. We can create a query by specifying the transaction class, and we'll import the criteria query type. So we have our criteria query, and this is where we're basically going to set up any sort of restrictions against the query that we want to run. So if we wanted to order, or if we wanted to add a predicate to the where clause, we would use the criteria query. Now, when working with the JPA criteria API, one thing that we need to do is we need to create a root. And a root is simply a means of qualifying access to attributes. You'll see what I'm talking about a little later. So we use the criteria query, and we invoke the from method, and then we specify our class once again. So that's the class of our entity. The root is basically saying when we execute a query, if we want to access a property, so let's say we want to access the title on the transaction, we would access it like this. And that's just to refer to it within our query. Once we have created our root, we have to actually add that into our criteria query. So we invoke the select method and we pass in our root. So this is basically saying select all of the fields on the transaction. Because remember, we were using the root to access our different properties on the transaction entity. So now we're just kind of passing in the whole entity itself and saying, give me everything. That would essentially create our select star from transaction piece of our query. But we can't execute a criteria query. We need to use it to build a regular query or a typed query. So I'm going to declare a typed query and give it a generic type of transaction. And we'll just call this query. And then we use the entity manager to create our query. And now we pass in our criteria query. You'll notice we don't need to supply the class as the second argument when we create a typed query because it's inferring that from the criteria query. And now we'll use our regular query we just built with the criteria query, and we're going to get the result list. At this point, we would return all of the transactions. Let's execute this example, and there we see we got all of our transactions back. So let's just take a look at this. We created a criteria builder, which allowed us to make a criteria query. We set this root so we can access different properties. We tell the criteria query what we want to select, and then we pass our criteria query into the create query method on the entity manager, and that gives us a typed query. And from there, we can actually execute the query we want to execute. And this is all for a query that basically looks something like this. And if we wanted to turn it to JPQL, it would look like that. That's quite a bit of code for a very simple query that we'd like to execute. So it's good that we executed that same query so you can really compare and contrast these two criteria APIs and kind of make a good informed decision about which one to use. When we query data, it's very common to narrow our results set down to a particular set of interest. So for example, when we execute a SQL select statement, we often specify a where clause which contains predicates that will focus our statement down to a particular result set. So we may say where some column is equal to some value, and instead of getting all of the results back, we only get a subset of those results. This capability is provided by the Hibernate Criteria API. And in order to execute that restriction against our query, we use a criterion. What we're going to do is, in this demonstration, look at how to apply some criterion to our criteria API query so that we can narrow our result set. Particularly, we're going to try to find all of the transactions that were less than $20 and were a withdrawal. So let's start in on our demonstration. The first thing we're going to do is create a criterion, and I'll name it criterion 1. And in order to build a criterion object, use the restrictions class. And the restrictions class basically provides factory methods to build criterion. The first one we're going to use is the less than or equal to criterion builder. It takes two arguments, the first one being the property name. So we're going to inspect the amount of the transaction, and now we need to provide a value. So we're going to say where the amount is less than or equal to this value. And since our amount field is of type big decimal, we need to use the correct type, and we're going to put a value of $20, and that's our first criterion. Now we're going to build another one. Once again, we'll use the restrictions class, and this time we're going to use the equal method. And we're going to look at the transaction type attribute where its value is equal to withdrawal. So we've built our two criterion. Now we need to apply them. So this is pretty simple. You just call the add method and supply your criterion. With method chaining, this becomes very simple. So here we have added two criterion, and I'm just going to format that. I'll save everything, and we run our demonstration. Let's take a look at the query that was generated by this. So I'll just copy that. We'll open up a notepad session, and here you can see that we created a query, and that query has a where clause where it checks that the amount is less than or equal to some parameter that we've provided, and the transaction type is equal to some other parameter that we've provided. So it looks like this is using prepared statements, and that's exactly what we want to prevent SQL injection. Okay, so let's close that query. We'll go back to our class, and I just want to show you one other thing with this. Now, we've used the add method, and we've invoked it twice, passing both of our criteria. But what you can also do is use the restrictions class, and there is an and method on here. With that, we just supply multiple predicates. So we would supply criterion 1 and criterion 2, and then we could eliminate this invocation of the add method, and this would work as well. So we'll just run that quickly. That's an example of applying restrictions using the Hibernate Criteria API. So let's see how to run this demonstration using the JPA Criteria API. What we need to do is create paths to the different fields that we want to access on the transaction, and we're going to use those fields within our restrictions. So I'm going to make a path with a generic type of big decimal, and I will name this the amount path. We'll use the root to access that field. We'll just supply the amount field. Okay, so we've built that path, and now we need to build one more. This will be of type string, and this will be to the transaction type. And we use the root once again to create that path. We just invoke the get method and specify the name of our field on the transaction. Okay, so having those, we can now apply some different predicates to our select clause. So here we invoke the select method, and now we invoke the where method. Much like we used the restrictions class within Hibernate, we use the criteria builder to invoke different methods that are going to help us build our predicates. So here's the AND method. And within the AND method, we're going to invoke the less than or equals method. Here you can see there's a full less than or equal to, but we're going to use this abbreviated one. And now we pass in our path, so the amount path, and then we put in our value. So it's a big decimal, and we're going to go with 20. This is a varargs method, so we can supply multiple criteria to this. So I'm going to build another predicate using the equal method, and we're going to pass in the transaction type. Our transaction type will be withdraw. Okay, so let's format that, and we'll save everything. We'll see that our criteria query will get passed into the query method, and that builds our typed query. Now, just looking at the criteria builder, we see all these different methods that we can invoke to basically build a predicate. So there's many methods we can choose from there. There's greater than, there's in, is false, is member, is not, is true. Let's just execute this query. And there we see that our query gets executed. And if we look at our where clause, we see our conditions were applied to the query. Let's just return back to the Hibernate application. And just like our criteria builder, with the restrictions, you can invoke all sorts of methods. There's not, ors, you can check the different size of things. So that can help you build a restriction or a predicate or a criterion, depending on which API you're using or what terminology you'd like to use. One of my favorite things about the Criteria API is that it makes paging through a result set extremely simple. Now, when I refer to paging, I'm talking about when we access a result set, let's say 10 at a time. You'll get a list of maybe 10 results back, and you'll click the next button, and you'll get 11 through 20 back. With Hibernate, creating that type of functionality is a breeze. So let's take a look at how we can use the Criteria API to page through our results. First, you'll notice that I have created a simple example that gets all transactions and it orders them by title. So let's just run that example. There you see all of our results come back. Let's page through them instead of displaying all of them. On the criteria, we're going to invoke the setFirstResult, and this is simply the number of the record that we want the result set to start on. So if we were paging and our pages had 4 results per page, and we wanted to start on the second page, we would be looking at result number 5. We can express that pretty easily by taking our page number, subtracting 1, and then multiplying it by our page size. And with that formula, we can perform paging. Now, we also need to set our page size. And to do that, we use the setMaxResults method. So we invoke that method, and we will pass in how many items we would like per page. Let's run this query one more time. And now you see that we get 4 results back. And these results would be our second page. We can go up and adjust our page number. And now we'll see we'll get the third page. It's much more simple than writing this in SQL. If you've ever wrote it in SQL, you would much prefer to have this method. Okay, so let's head over to the JPA example, and we'll use the JPA criteria API to put this in place. I pretty much have the same query being executed. We are querying all transactions. We pass our criteria query into a typed query, and then we execute our query and get our result list. So what we need to do is we need to modify our typed query, and it also has the set first result method, and we just subtract 1 from our page number and multiply by the page size. So this is almost exactly the way Hibernate does it. So we'll just breeze through this real quickly. Notice I've set a different page size. We can run this example, and there we see we get 5 items back instead of 4 because we've changed our page size. Pretty simple, almost exactly the same as Hibernate. You're just working with a different interface. Now, one thing to look at is this is actually on a typed query, and if you remember, JPQL can be made into a typed query. So you don't really have to use the criteria API to do this. You can execute a JPQL or HQL query and then use the query interface or the criteria interface to page through the results. So just a simple example to show you how Hibernate can make paging so much easier. So congratulations, you've completed the course. Let's go over a few final takeaways. An important thing that you should have gotten from this course is that there's a different way to persist data in your applications, and that's using an ORM. We looked at Hibernate and JPA and how we can use them to simplify data persistence within our applications. Once we learn how to use those two technologies, we can create a standard persistence layer across all of our applications. So all of our applications can use the same ORM to interact with the database. And that's going to grant us many advantages because when you work with one application, the persistence mechanism is going to look the same as another application. You're also going to have multiple people that understand that architecture. And this really grants us a lot of the benefits that we see from an ORM. And then finally, I'd like to just touch upon JPA versus Hibernate. We know that JPA is the specification, so it defines the API for an ORM. Hibernate is an implementation of the JPA specification. Now, Hibernate also grants us additional functionality not specified in the specification. Where do you go from here? Here's what I recommend doing. There is a Spring course out there, and you will find that Spring pairs very well with Hibernate. Now, I happen to be the author of the Spring course, so if you like this course, you would also enjoy the Spring course. And then finally, take these newfound skills and apply them. Work on Stack Overflow answering questions about Hibernate or about JPA. Try to introduce these new techniques at your workplace. Try to teach others about them. All of these activities really strengthen your capability with Hibernate. And I just want to thank you for watching this course. I really enjoy making these courses, and it takes people that are dedicated, and I really commend you for taking that step and really taking hold of your career and advancing yourself. Once again, thank you.